Hello everyone, I welcome you all for today's session on DevOps Full Course by Intellipaat. DevOps, it is a leading cloud technology of today's era. Many of us have thought and tried to pursue a career in DevOps as a DevOps engineer. But before proceeding, all of us have doubts. And here we have Mandeep. He is my colleague. Hi Mandeep.
Hi.
He is a cloud DevOps expert and he will be answering a few common questions which all of us have in mind. So Mandeep, tell us, what are the basic skills required for one to become a DevOps engineer?
Yeah, hi Anmol. So DevOps can be learned by any person, either it's a fresher or the person who is working in IT, non-IT person also. So basically, if you see in IT industry, most of the time people who are having the experience in project management, the people who are working as a tester, developer, or the people who are working as an analyst also, these kind of people also learning about DevOps. So DevOps can be learned from anyone, but what we recommend is, like, if somebody is having a basic understanding of Linux and Python, it is always helpful.
Now that we know the basic skills for becoming a DevOps engineer, what is the scope of DevOps in future?
Yeah, Amol, that is a very good question actually. Most of the time learners also ask me the same question. So in this, I would like to inform that if you are working in either India or maybe you are working in Malaysia, Singapore, or maybe US, UK, wherever you are working, every country is having the requirement about the DevOps and it is increasing significantly. So if you see, as per NESCOM itself in India, there are more than 10 to 20,000 DevOps jobs are available as of now in Bangalore, Pune, Gurgaon, in these regions. Along with it, if you see US, UK, already these people have automated the whole process in the companies and everybody is looking forward for learning DevOps. Okay, and if you learn DevOps, in that case, I would like to tell you, like, you will able to get the job very easily because right now the requirement is more and the people with the required skill set of DevOps are very, very less.
So, is IT background necessary to learn DevOps?
No, Amol. I will like to say that IT experience is not needed mandatorily for DevOps. Anybody from non-IT background also can learn this course. The reason being is, like, if you check Intellipaat course content, we are giving Linux and Python in advance only as a self-paced material so that you guys can have a basic understanding about it. And once you learn that, we will be going through in detail about each and every tool. Let's say if you go through Git, Docker, Jenkins, Kubernetes, any particular tool which you are learning with Intellipaat will give you from basic to advanced, so that later on when you are performing the activity in the real-time scenario, you can easily do without any failure. Okay, so I would say that IT experience is not necessary for DevOps.
Okay, so what suggestions do you have for people who are starting to learn DevOps?
So guys, we are covering most of the tools in this particular videos in a detailed manner. But let's say if you want to have a detailed training, so you can go through the Intellipaat course content. We will be having a proper session over there for each and every tool. Either it's Git, Docker, Jenkins, Puppet, Kubernetes, Ansible. All these tools will be taught to you in a brief manner. Along with it, we'll be giving you the hands-on exercise, project work, and the interview questions as well, so that you can clear your job interviews also. And for the further details, you can go through the description box below for the content details.
That was really helpful, Mandeep, and I'm sure many of the doubts today were cleared. And now, before we begin with the session, please subscribe our channel and hit the bell icon for more such informative videos.
So in any tech company, in any tech team, you have two teams which basically contribute to a release of a software. The first team is called the development team and the second team is called the operations team. Right now, what is development team and what is the operations team? A developer is basically a person who develops the code, right? He would develop the code and the code would then be forwarded to the operations guy, whose job is to basically test the code and put it on the testing server or the production server based on the requirement, right? Now, what was the problem here? The problem was when the developer developed the code and he forwarded it to the operations guy, the operations guy's system could not run the code which the developer has forwarded, right? So obviously the developer would have tested the code that he's sending on his system first, and only then he's sending, right? On successful operation on his system, he will only forward the code to somebody else who wants to test it, right? But it did not run on the operation system guy. It could be the problem of environment. It could be the problem that he has not installed everything which is required by the software. So he used to push it back to the developer saying, your code is not running on my system. Please check your code. It is faulty, right? But now the developer was furious, it ran fine on his system. And if that operations guy is not installing something properly, it's not his problem, right? It's not his job to go ahead and fix his system and then run the code, because his job is to run or develop the code which he is doing, and the code is running fine on his system, right? So it's the operations guy problem that he's not able to run it on his system, right? So these were some of the problems that were between the developers and the operations guy, and this was solved later. But before that, there was a lot of problem in team communication, and it solved and it caused a lot of inefficiency in the team, right? When we talk about lean methodology, we were talking about faster release cycles, eliminating waste, but this was a waste that we were not able to eliminate using lean methodology, right? And this was solved using DevOps, right? Now the DevOps is what is DevOps exactly? It is not a tool, it is not a software suite. It's basically an idea, it's basically a thinking. And this thinking is obviously implemented using some tools. But right now, if you were to talk about DevOps, like I said, it's just an idea of working in a certain way that could solve the problem that we were facing between the development and the operations team. So if you were to draw some differences between what we were doing earlier when we were working without DevOps and what happens when we use DevOps, is that the traditional IT system was less productive, although it was very productive, as we saw in lean methodology, where we have eliminated everything. We have tried everything in our hands to solve it using the planning part, but there was still some room of inefficiency that we could not solve using planning, and that was solved using DevOps. So DevOps was more productive than traditional IT, right? Then in traditional IT, we had a skill-centric team, right? Each team was skilled in a particular territory, and we had a lot of teams in our organization which used to work on different things. Now in DevOps, what we do is the smaller teams are also specialized in different domains based on the silos, right? Based on the technology. So rather than having 4 people who are equipped or who are skill centric in one particular technology, in DevOps we had each person who was skill centric in a technology, right? So probably one person would know Kubernetes, the other person would know DevOps better, the other person would know Git better, the other person could know some other technology better. So we had silos like this, right? In traditional IT, we used to invest more time in planning. So when I talk about traditional IT, I'm talking about waterfall, agile, lean, both collectively, right? So there was still some planning involved when we talk about traditional IT. In DevOps, we are basically saying we do smaller and frequent release cycles, right? So we do smaller and frequent release cycles, as we saw by the end of lean and agile methodology, that we are doing smaller release cycles. DevOps take the advantage of those methodologies and implements it in its own model as well, that we have smaller and frequent releases, but they're still smaller than what we were seeing in lean and agile methodologies. How is it? We are going to discuss it in the future. So DevOps still shortens the release cycle by the help of automation. It's a release cycles, and hence releases software in even lesser days than, or lesser weeks than we had in traditional IT. If we talk about DevOps, guys, I would like to give you a fact that using DevOps methodology, you can have release cycles in a day rather than weeks or months. So every day there could be a release if you're using DevOps methodology to the fullest. Okay, so this was again a good thing. In traditional IT, when we were using waterfall model, for example, it was difficult to achieve a target or goal because the goal was set 1 year later, right? So there was a difficulty in doing that. Reason being, we could not foresee future, right? There could be some more problems that could be there while we are working on a project, but everything cannot be planned in advance. But in DevOps, because we are doing shorter release cycles, it is not that difficult to achieve a target or goal. It is easier to set objectives for a day than to set objectives for an year what you're going to do, right? And that is why DevOps makes it easy for us or for your employees to achieve their goals or their targets. Okay, so this was basically the difference between what we had in the past, probably when we were using waterfall methodologies in the past, and what is the present, what we are able to currently achieve using the DevOps methodology. So guys, like I told you guys earlier, DevOps is nothing but a methodology. It is an idea, right? It is not a tool, it is not a software, it's an idea or methodology of solving the problems between developer and operations guys, right? Now, this methodology involves a life cycle, which, as you can see in the diagram, that the first thing that you do is you plan what you have to do, right? Then you code your way in, then you build the code. Building the code means if you have a Java file, for example, you'll have to create a jar file or an executable file out of that. So that is called building, right? So building your code, and then you will be testing your code. So what executable you have built, you'll basically test that code for any faults in the functionalities. And if there are no faults, you'll basically release the code to the ops team. Now there are two kinds of release, guys. There's an internal release and there's an external release, right? The internal release talks about releasing the software to a different team of the company, and this is what exactly is happening. Then comes the release phase, where the developer guys release the software to the operation guys for their work, right? The operations guy will in turn deploy the software onto the target system. It could be a testing server which basically will test or do automated test on it, or it could be, you know, the production server where everything has happened, the testing has happened, and you're deploying it on the production server, right? So once you have deployed it, of course, now comes the operation phase. The operation phase can be done internally, or it could be done by your customers, wherein you know, you're operating the software or you release the software for internal employees to see whether you know, the traffic, when is it doing good when it holds when it's getting traffic onto it, is it doing good when normal people are doing arbitrary tasks on your software. And then you are also continuously monitoring it to see if you know, your task is or your application is functioning properly, and if it is not functioning properly, you're basically creating a log of events which are happening, right? Which this is called monitoring. And after monitoring again comes the planning phase, which means if you get any kind of feedback from the monitoring part, you again start planning it, how to do it, how to solve this kind of a problem that you're getting in the monitoring phase, and then code your way in, build the code, again test it, again release it to the ops guy, and this goes on and on until you get the perfect application. And there is no perfect application, guys, right? Always there will be new requirements coming in, always there will be some bugs, always there will be some security patches, and therefore this life cycle goes on and on. So this is what DevOps is, guys, right? And if you were to think about it, how is it solving the problem between the dev and the ops guys, is by automating this life cycle. Basically, that means that now the developer does not have to give the code to the ops guy. It'll basically be given through a tool which we have, so there is a tool called Docker, right? So basically the dev guy will enclose his code inside Docker and will push it to the ops team, and the ops team just have to run Docker and this code will run fine, right? There is no problem for dependency, there is no problem for configuration management. Everything happens automatically in this life cycle. So don't worry if you don't understand exactly what DevOps is, because in our next slides we're going to discuss how it actually works, right? So going forward, now let's discuss how the DevOps life cycle actually works, right? So if you were to that infinity sign that we had, it, if you were to condense it, or if you were to expand it, so that DevOps lifecycle diagram that we had, the infinity diagram that we had, if you were to expand it, it would look something like this, right? So you have something called as planning, you have something called as coding, building, and testing. Now this used to happen on the developer's side, right? And then we go on to the ops side, where we have release, we have deploy, you have operate, and then you have monitor, right? So in between this, we have to integrate this part of the developer's side to this side of the operator side, and this is done using continuous integration. Now, what is continuous integration we'll discuss in a while, but for integrating the developer and the operations guys, we use continuous integration, right? Now, before moving on to what is continuous integration, let's pay attention to what we have over here as well, right? So the planning and coding phase, we contribute, or we collectively call it as continuous development. What is continuous development? I'll explain you in a little while. Building and testing, we call it continuous testing, okay? Releasing and deploying, we call it continuous deployment. Operation and monitoring, we call it continuous monitoring, okay? So you start with planning, you do coding, you build it, you test it, you then release it to the ops team, then you deploy it, then you operate it, and then you monitor it. And this gives rise to 5 stages, that is continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring, which again goes back to continuous development. Now let's understand these terms. Let's understand what is continuous development, testing, deployment, monitoring, and integration. Okay. So this is the life cycle, guys. Now, why are we calling it continuous? Continuous basically means it goes on and on, right? It never stops. So like I told you in the diagram for DevOps, that the cycle goes on and on. It never stops. The product is always being developed, right? It is always in some part of the life cycle. So if you were to explain continuous development and continuous integration, continuous testing, this is the best way to learn it. Okay, so we have a developer who basically will be pushing his code to a version control system. Okay, and this version control system will basically, any changes in this version control system will be taken up by a continuous integration tool. Okay, so what is a continuous integration tool? A continuous integration tool does nothing but it joins each of these stages to each other. For example, if I have to go from continuous development to continuous testing, and if this happens in separate softwares, continuous integration will join these and this, right? Continuous integration will join testing and then deployment. Continuous integration will join monitoring and then again coming back to development. And how does this happen? It happens like this. So there is a software which basically does continuous integration. Okay, let's understand just this as a black box. This is a software which does continuous integration, and the function for this particular software is the moment you push your code to a version control system. This version control system is nothing but a software which takes care of storing your code. Okay, so the moment you push your code to a version control system or you change your code in the version control system, the continuous integration tool automatically identifies, okay, so there's a change in the version control system. So what it does is it takes this code and it builds it on the testing server. It first builds it and tests it on the on the testing server, and this is called continuous testing. Reason being, every developer who does this, continuous integration does the job similarly, right? So if there are 100 developers in the team, so for every developer, if we configure a version control system, that for every developer it has to test the code, it will always do that. Okay, so every developer who's doing a version control, who's pushing his code to version control system, continuous integration software is going to test their code on the testing server, right? And this is the reason it's called continuous, right? Because it happens continuously. Okay, so continuous development, we push our code to version control system. It is identified by the continuous integration tool. So the first job that continuous integration tool does is it pushes onto the testing server the code where it is built and tested, and if the test succeeds, continuous integration tool pushes it on the production server. Okay, now either if it's on the production server or if it's on the testing server. Now if on the testing server there are some bugs which are identified, the feedback is given through continuous monitoring to the developer. Or if the production server, if there are some problems on the production server, or like I said, when you deploy your code on the production server, it basically gets available to the world. and it gets continuously monitored, right? For any kind of problems which are occurring, it gets continuously monitored and the logs are generated, and these logs are being stored somewhere using continuous monitoring. So your production server is continuously monitored for any kind of activity which is happening on it, and the logs are being generated. Now, the developers, the team, now when I go back to the developer, why am I coming back over here? Because this identifies, or this tells us basically now that now when the development team is done with the release and now they have to see what other work I have to do, all they have to do is check the logs from the continuous monitoring tool, right? And they'll be able to identify, so okay, so this and this is causing a problem, this and this is causing a problem, and also the users are saying that, you know, we should have this feature. The client also came in, he also wants some features, so they plan a release, right? And once they plan a release, they again start coding, and again once they're done with the code, they'll push the code to version control system, which will be identified by the continuous integration tool, which will then automatically test it. Once it's been tested, if it's successful, it will push to the production server. Again, the logs will be identified by the continuous monitoring stage. Again, it will go to the developer after planning, and then he'll code his way into version control system, and the life cycle goes on and on, right? So this is exactly how DevOps work, right? Now let's look at each of these stages independently to understand what exactly happens in continuous development, what exactly happens in continuous integration. Okay, so in continuous development, you basically push your code to a version control system. The version control system could be a software like Git or a software like SVN. Right now, when the moment you push your code to the version control system, it basically creates a new version of your code. For example, if you wrote ABC on a text file, right? Now that ABC you wrote and you upload it on the version control system. So this was the first version. The version control system automatically makes it version 1. The moment you make some changes and again push it to the version control system, what happens is it creates, the version 1 was the text file having ABC. Now the new version that you have pushed, it becomes version 2, and the file would be ABC and probably whatever changes you have made to the file. Okay, so it creates a new version, and at the same time it also holds on to the previous version, so that in any case, in any problems that you might have in the future, if you want to revert back to the previous version, you can easily do that, right? And that is why we have version control systems like Git and SVN, and continuous development is an integral part of pushing code to your version control system. Okay, now this was continuous development. Then you have continuous integration. Now what is continuous integration? This is nothing but integrating your life cycles with each other, right? For example, once you push the code to your version control system, it obviously has to be picked up and pushed onto the testing server for testing, where it could be built and tested, right? So all these life cycles are integrated, or there is someone who is doing the manual job of a person of taking code from one stage and pushing it onto another, then taking the results from there, pushing it onto another, then taking the results from there, pushing onto another, and that manual effort is being done by a tool which is called the continuous integration tool. Okay, then you have continuous deployment. Continuous deployment basically means you will deploy your code onto a particular server. It could be a testing server, it could be a production server, and deployment basically involves putting the right kind of software on it and then pushing the build onto your server so that it has the right software environment where it will function, right? And again, installing softwares and system and everything is also automated using a tool which is used in continuous development lifecycle. Okay, then we move to continuous testing. Now continuous testing is again a lifecycle stage wherein you continuously test your software. So like I told you guys, in this what happens is you continuously build and then test your code. So your code is pulled from the version control system. It is built. So when I say built, it basically is converted to an executable file, and this executable file is then run, right? Now the continuous testing, how it happens is you create testing suites which are basically pre-installed in the testing server, and the moment it gets a new executable, all those test suites are executed on this particular executable file to check if all the tests are passed or not, right? And if all the tests are passed, it is then again picked up by the continuous integration tool and then pushed onto the production server. Once it reaches the production server, again it gets monitored, right? It gets monitored for user activity, it gets monitored for any errors, it gets monitored for any user comments on version upgrades, right? On version upgrades, or you can say any feature requests. So all those feature requests, all those errors, all those logs are then visualized or then are then stored inside a monitoring tool, right? And this monitoring tool helps us in sorting these logs based on what we want. It'll basically sort it on the basis of general logs, it'll sort it on the basis of error logs, it'll sort it on the basis of feature requests, right? So it becomes a one destination stop for you where you can check and plan your day ahead or plan your team's work for the near future. Okay, so this is continuous monitoring. So these were all the life cycle stages of DevOps, guys, and this life cycle stages basically make it possible for us to have shorter release cycles because all these stages are automated, right? And these are automated using tools, and these tools we'll be discussing in our next session, where we'll get an introduction to all the tools which basically come together to create a DevOps. Right. So far we have discussed the DevOps methodology, how the DevOps lifecycle work, but they are incomplete without their respective tools, which will map to each of the lifecycle stage in the DevOps lifecycle. Okay. So let's go ahead and start discussing these tools with their respective stages. So the first stage that we saw was continuous development. Now, continuous development is implemented using version control systems, like I told you guys, and in most of the companies, the most used version control tool is Git. All right. So Git is a version control system which we'll be also using in this course, right? And it is basically used when multiple people are working on one particular project. Right, so it is great for team collaboration. It is great for tracking changes, and is absolutely awesome on command line. All right, so this is what we are going to learn in this course. So for Git maps to the continuous development lifecycle stage, then we have continuous integration. Now, you heard a lot about this continuous integration tool when we were discussing in the DevOps lifecycle, and the tool is called Jenkins, right? So Jenkins is basically an open source tool, right, which is used to implement the continuous integration features that we saw in the DevOps lifecycle. So in this course, we'll be learning Jenkins, and there is a separate module on Jenkins that we'll totally devote to explain different features that you can explore in Jenkins, right? The next stage is continuous deployment, and continuous deployment basically means two things. It means configuration management, and it means virtualization and containerization. So we use Docker for virtualization and containerization, and what exactly Docker does is, so the problem of running your code on one system and not being able to run on another system is what is solved using containerization. So what containerization basically does is, it wraps your code along with the software dependencies, and all these software dependencies and code is wrapped around by a container, right? So a container is a physical entity which will basically wrap your software dependencies and your software, and it will, if you run that container on any other system, it will run as if it is running on the same system that is on the developer's computer. So a container is an executable form of an operating system which can be run on any system. The only pre-requirement is that you should have Docker installed on it, right? Similarly, you have configuration management. Now, configuration management, what is configuration management exactly? So say you have a computer, you have a freshly set up computer on which you have some operating system installed. Now, if you want to test your application on that system, what you have to do is, you first have to install all the softwares on it. Right, for example, like I said, you would need Docker for your container to run. You probably would need an Apache server. You would need Python. All these softwares which have to be installed can be installed using configuration management without even touching that remote computer or that freshly set up computer. And that is possible using tools like Puppet and Ansible, more of which we will be seeing in our course as we progress in our number of modules. All right. Our next stage is continuous testing. Now, continuous testing, as we learned, was all about creating testing suites which would automatically test your code once it gets built on your system, right? So all these automation testing suites can be created using the Selenium software, right? So we will be learning the Selenium WebDriver in this course as we move along, and we will see how we can create our automation suites in Selenium.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous delivery and monitoring. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
For testing our applications. Okay, so this was about continuous testing, and then next we have continuous monitoring, wherein your application is continuously monitored and the logs are created. Any errors are also monitored, right? So all of that is done using Nagios. So Nagios basically gives you a dashboard with all your services listed on it, and those services can exist on any system outside the network or inside the network, and all these services running on it can be seen on the Nagios dashboard. Okay, so it's a great tool for monitoring your application. It's a great tool for gathering user data or user activity data at a one-stop destination. Okay, so that is what Nagios is all about, and this brings us to all the tools. So these were all the tools that we will be discussing throughout the course, right? And this brings us to the DevOps Tools lifecycle. So you saw the DevOps lifecycle earlier, wherein you had a developer and the developer was basically pushing code onto version control system. This is a replica of that figure, and in this figure we have just replaced the tools with the life cycles. All right, so now what the developer does is he pushes his code to GitHub. From GitHub, Jenkins automatically detects that on GitHub your code has been changed. It pulls the code and pushes it onto the testing server, and it installs all the softwares required on the testing server, and the testing suite that has been built on the Selenium is already present on that testing server, right? So Jenkins pushes the code here, the code is built and tested over here. If it goes successful, Jenkins again pushes the code to production, right? And on the production server, Nagios continuously monitors it for user activity, how many users are logged on, what the users are saying about it. All of that information is saved inside Nagios, and that information can actually be seen on the Nagios dashboard by the development team, and they can make a plan for the next release, what all features they have to include, what all fixes they have to do, right? And once you do that, you again start on with your next release. So this is what you do when you are working with the DevOps tools, and this portrays the whole DevOps lifecycle that we have in a company, in any arbitrary company which is using DevOps.
Introduction to AWS. So I'm just going to tell you what exactly is AWS and then start off with it. So first of all, to understand AWS, you will have to understand cloud computing. So once you understand cloud computing, exactly, you can understand what exactly is AWS or Azure. So first of all, cloud computing technology is something, or let's say it is a tool, or it's multiple services provided to you via internet. So it can be any service. Let's say Gmail is a cloud service because you do not know where the Gmail's code is hosted. You don't know where your mails get stored, but it is a software on the browser which you get once you type the URL, and once you type it, you are able to see the platform and use the software. But you do not know where it is hosted, but obviously it is hosted somewhere in a data center which you're using through the internet. So that is called a software as a service. You're getting it as a service through the internet. So there are two other main types of services in cloud, which is infrastructure as a service and platform as a service. So if it is infrastructure as a service, in that case, you will get the infrastructure itself. That basically means you will get your servers, you will get your database engines, you will get your data warehouse clusters, you will get your DynamoDB or NoSQL tables. You will get every single entity which you have in a regular or a traditional data center. So you have your servers in which you can host your code, you can host your website, you have storage where you can upload information. So all of that is provided to you from infrastructure level so that you can have access to them. And once you have access to them, basically you're accessing them via internet. You're not going to the data center and accessing them. So that basically means infrastructure as a service. You're getting infrastructure through the internet. And the second, the final one is platform as a service, where you get a platform or a website in which you upload your code or anything. You upload your data, you upload your files, whatever it is, but you get a platform in which you can do certain actions, which is the only thing which you are given. So software, you can only use the software. In infrastructure, you get the whole infrastructure itself. You can install whatever you want in it. Platform is somewhat in between. You get the website in which you can upload your code, and it will automatically host your code on a server for you. So it is basically an intermediary between the infrastructure as a service and a software as a service. So there is a tool called Elastic Beanstalk, which is a platform as a service where you upload your code, choose the runtime, for example, PHP, Java, or Python. You choose your runtime, upload your code related to that, and it will host it for you. Okay, so yeah, so that's what are the three main services: infrastructure, platform, and software. So now you get all of these three different services from Amazon itself. So Amazon.com is a software as a service. You go over there, you buy certain items, you pay for it. So it's basically a platform, or it's basically a website from which you buy things, and it is only a software which you are using. You're not given access to the code, you are not given access to the server in which the Amazon website is hosted. Now, coming to platform as a service, you might not know this, but some of you might. So there is a tool called Elastic Beanstalk where you upload your code. So you get a platform where you upload your code. You can choose the runtime. You can basically select what type of an instance you want, operating system you want. Once you've selected all of that, you can basically, you don't need to do anything else. Elastic Beanstalk will manage all of your server needs. It will provision the servers in the background and host your code for you. Third one is infrastructure as a service, where you get an instance which basically is EC2. So EC2 is a server which you can launch on demand. That is, whenever you need, you can launch an EC2 server. And once you launch it, you can install whatever softwares you want inside of it, and you can use it for any purpose you want. So now, all of these three to Elastic Compute Cloud. So first, let's understand the first word, which is Elastic. If you have a server in your on-premise setup, let's say you have 5 servers to host your website. Now you want a 6th server because your website's popularity is increasing. So your website is getting much and more popular. So in that case, you will need another server. So to get another server, what do? You go and purchase a system, you bring it, you configure it with the appropriate softwares, you push your code into it, you set it up, and you have 6 servers right now. But let's say after 1 week, your website's traffic or your website's interest goes down by 50%. In that case, only 3 servers are needed right now. So you cannot just sell the other 3 servers because you have invested in them, and even if you sell it, they'll go for less price. So exactly to solve that particular thing, EC2 came, and the Elastic part of it is the so that came to save us from that on-premise setup where we'll have to invest capital to buy servers and then host our code in it. So now Elastic, it basically means it is the level at which a system is able to adapt to workload changes, provisioning and deprovisioning resources such that resources meet current demand. So that basically means, so the servers which you launch in EC2, you can set up a scaling policy which basically determines to provision or deprovision the resources. That basically means increasing the servers or decreasing the number of servers according to the current demand. So there is a service for this particularly called auto scaling. We'll not be looking into that. We might look into that in another session. So that basically is Elastic Compute Cloud. And also it is cost optimized because you only have the number of servers you need at that point of time. So right now you can see there are 3 users using EC2, and EC2 is provisioned a particular server. So this is the server which is handling these users. So now let's say there are 6 users using these servers. So each server can handle 2 different users. Now user traffic is increasing, your website is performing well. You need 3 servers right now. Without 3 servers, obviously your website would crash. Now suddenly your website's popularity decreased and your website's traffic is decreasing. Now there are only 4 users using your website. If you're using 3 different servers, there is no need for one server because 2 of these servers can accommodate 4 users. So AWS basically does that for you. So you can set up an auto scaling policy which will decrease the server by 1. And now you only have 2 instances running which can accommodate 4 users. So there are 2 things which you can benefit from this. One is high availability. Your website will be always running even if the traffic increases or decreases. Second one is scope optimization. That is, you only pay for the servers which are currently running. So when there is less traffic, if you want, you only have a minimum number of servers. That basically means you have reduced your cost a lot. Okay, now coming to regions and availability zones. I wanted to introduce this. This is not a major concept which you can start off with while you're starting off with EC2. So there are multiple regions in AWS. You can, let's say, if you're in Singapore, you can launch an instance or a server in US East. If you're in US East, we can launch an instance in Seoul. So you can launch an instance in any of these locations you want. You'll just have to change the location in the AWS console. So the main advantage of this is, let's say you are a developer in, let's say, in Mumbai. You create a website, you launch it on AWS. So right now you get to know that your customer base is global. There are some customers in Singapore and Sydney. So now you want to move your applications to Singapore and Sydney as well, so that the customers can get fast access. So now what you can do, if it is an on-premise setup, that is, if you have created a simple on-premise setup to host your application, if you want to create an on-premise setup in Singapore and Sydney, obviously there are a lot of restrictions. You'll have to get a place, you'll have to set up servers, and you'll have to proceed with it. But if it is AWS, it's pretty simple. You can just choose the region, create the servers, upload your code, and you are set up. So it's pretty simple to move your application move your application across multiple regions and availability zones. Okay, so I've explained about the regions. One more thing I wanted to introduce is the availability zones. So there are multiple availability zones within one region. That basically means there are multiple data centers. So if you take US East 1 in North Virginia, there are 6 different availability zones or 6 different data centers within that one region itself. So you can host your data or you can host your code in all of these availability zones, or one of these, or 2, 3 of these. So I'm just giving you an example. These are the geographical regions and these are the availability zones. So it is not that there are 6 availability zones in all of the regions. You'll just have to look into each of the region to check the number of data centers which are available within them. Okay, now coming down to EC2 instance types. So this again, there are multiple instance types which can be grouped together in these 5 different types. One is general purpose, one is memory optimized, storage optimized, accelerated computing, and compute optimized. So general purpose are the instance types which you can use for any usage. It can be for a simple server usage. You can basically store something. You can run simple code in it. You understood the word, right? The sentence general purpose. It's basically for that. Coming to memory optimized, you get an increase in the RAM more than the virtual CPU. So you get CPU and RAM in each of these instance types. So the RAM comparing to the virtual CPU will be a higher number. So for example, you might get 100 GB of RAM and 20 virtual CPUs, that is computing power. Coming to storage optimized, in this case, you will get an increase in storage, and also you get SSD storage. That is, your storage is faster than all the other instance types. So if your application which you're going to host in your EC2 server requires a lot of read and write, in that case, what you can do is you can use storage optimized instances, because they give you an increase in the read and write throughput, so that you can retrieve data and upload data to your EC2 instance, or you can retrieve you can basically retrieve data from a database which is running inside the server within basically faster than the other EC2 instances. Now coming to accelerated computing. in this case, these instances basically provide you a burstable performance. Let's say you are running an application in these instances, which have a baseline performance of 20%, and suddenly an algorithm starts to run, and your CPU goes to 90%. If it is a normal general purpose instance, there will be some, it might slow down, but accelerated computing has the power to handle that much. So it can handle high performance computation. Coming to compute optimized, it is basically the vice versa of memory optimized. In compute optimized, you get more, basically you can, for example, as I told you, in memory optimized, if you have 100 GB of memory and 20 virtual CPUs, in compute optimized, you might have 50 virtual CPUs and around 120 GB of RAM. So the compute optimized, that is the virtual CPU numbers, will increase in compute optimized. So these are the instance types which you can go with. But if you're practicing, if you're starting off with AWS, go with the general purpose instances because they come under free tier. Okay.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, and practical also. I'm encouraging people to take courses on Intellipaat.
Now let's continue with the session.
If you know what online cloud storage is, you know what S3 is. But of course, in S3 you get a lot of other things to do. Online storage is something wherein you can upload your files, folders, images, videos, songs from your local machine and access it from anywhere in the world. All these are online storage providers. Why are we using all these products nowadays? Because they provide a lot of flexibility, security, durability. You can upload your important documents once and can access it from anywhere as long as there is internet connectivity. That is not the only selling point of these providers. The documents or data we store are highly durable and secure. In olden days, we used to store our important documents, pictures, favorite movies, and videos, etc. in external hard disks, which were highly unreliable. You would never know when those can go corrupt. I still remember I had stored more than 100 GB of music files on one of my hard disk drives, but suddenly one fine day, when I tried to access that drive, it started saying that data cannot be read. You have to format your disk. I literally lost all those songs. If you use these online storages, you can be rest assured that your data will never be lost or will never get corrupted. I have already talked about APIs in the introduction part. Please go through it again. Here we'll just do a recap. What are APIs? Suppose you have written a program in any of the programming languages. It can be any other language apart from what I have mentioned here. This program caters to one or more of your application functionalities. You want this program to be called from some other program written by developers from other team or other part of your application at large. What we'll have to do is expose an API, and this API would be used by programs or other developers to access your program's functionalities. An API is a list of specifications which describes how information is exchanged between programs. So software that wants to access another will call the API published by the other program. In our case, this is the program, it has published an API, and this is another program which is using this API to access the functionalities provided by this program. That's all about pre-S3 talk. Let's jump into S3 right away. Simple storage service is storage for internet, similar to the other products like Google Drive, iCloud, Dropbox, etc. But S3 gives us a lot more control and can be used in programs. S3 provides web service which can be used to store and retrieve unlimited amount of data. S3 is used to store mainly binary objects. By binary objects, I mean videos, pictures, movies, songs, PDFs, Word documents, Excel files, etc. Before going into S3, I want to get the stage right with consistency model. S3 provides highly durable and available solution by replicating all data in multiple data centers in a region. When S3 stores your data, which can be any binary object, those are typically stored in multiple data centers using replication. Data uploaded in a particular region never leaves that region. There is something called read after write consistency which is provided by S3. This is the first consistency model provided by S3. And this is the second one, which is eventual consistency. Continuing with the consistency model, let's see how read after write consistency works. Remember one thing, this consistency model works only for new data or files or objects. In web service term, it is called new puts. Put method is used to upload new object or file or to overwrite existing files. That's why you have new puts and overwrite puts. S3 will be used to store your data. Data is stored in a single region and across multiple data centers. Data can be uploaded from anywhere, either from internet or from EC2 instances in VPC. Data to be uploaded is put in S3. The file is sent to S3 and S3 stores the file in multiple data centers. So the same data is replicated in multiple data centers in the same region. Success message of upload will only be sent after that. That means until and unless the file is not replicated across multiple data centers, the upload will not be successful. Let's see eventual consistency model. This is used for updates or deletes of files or objects. We'll use S3 to update or delete files. The file is there in a single region across multiple data centers using replication. You're trying to upload the same file again or trying to delete the file. You put your file and S3 overwrites or deletes it in a single data center. Once that is done, the success message is sent. See, this time S3 did not wait for this update or delete to get replicated across all data centers. Now suppose you want to read this file just after the update or delete was done. It might happen that S3 gets this file from this third data center. When you get it back, it might not be the updated one because replication has not happened yet. If delete operation was used on this file instead and you got a success message and the delete operation was not replicated to all the data centers, S3 still might fetch you this file. You'll get the correct output if you try read operation again after some time. This is called eventual consistency. You can mention during read whether you want consistent read or eventual consistent read. In case of consistent read, S3 will check all data centers and return the most updated data. But for eventual consistent reads, S3 will pick a data center at random and return the data from there without checking whether it is the updated one or not. Here are some of the points of differences between two consistency models. In consistent read, you will not get any stale reads. Eventual consistent reads, stale reads are always a possibility. Read latency is higher in case of consistent reads because S3 will check all the data centers, but eventual consistent read, it is pretty lower because S3 will read data from any one of the data centers. Read throughput is comparatively lower in consistent read for the reason mentioned earlier, and it is faster in eventual consistent read. Let's understand consistency model using examples now. How concurrent applications will behave with S3's consistency model. Concurrent applications are those which run at the same time. This is our timeline, start to end. Upper half belongs to application 1's timeline and lower half belongs to application 2's timeline. Suppose application 1 does some write operation W1. Application 2 does another write operation W2. W1 updates name field to EC2 and W2 updates it again to EBS. Application 1 does a read operation R1 at this time, followed by another read operation R2 by application 2. For a consistent read, R1 and R2 both return name as EBS. For an eventual consistent read, R1 and R2 might return name as either EBS or EC2 or no results, depending on the amount of time that has elapsed. Another example, but this time around W2 does not complete before the start of R1. Therefore, R1 might return name as either EBS or EC2 for either a consistent read or an eventual consistent read, because replication might not have been completed across all or any of the data centers. Also, depending on the amount of time that has elapsed, an eventual consistent read might return no results. Let's take a feel of S3, what it is now and how files or data are uploaded to S3 using a demo. We'll also see how files which have been uploaded can be accessed. I have a few pictures in my folder AWS-Foundation-S3 drive. I'll upload some of these pictures in S3. Click on Services, go to Storage, and you can find S3 here. Or else you can use the search bar. Before uploading the files, we'll have to create something called a bucket. We'll discuss bucket in our next part. Click on Create Bucket and give it a name. We'll create the bucket in US East 1 or North Virginia region. Click on Create. The bucket has been created. Hover around the name and click on this bucket to go inside it. Here you can upload your files. Click on Upload and then click on Add Files. I'll use my drive to upload a few files. Let's upload the picture of Superman. You'll see the status here. It is taking some time because this object or this file is being replicated across multiple data centers. Now the object has been uploaded or the picture has been uploaded. Hover around the name and click on this picture. This is the link which can be used to access this picture. Before doing so, we'll have to change the permissions. Click on Permission and click on Everyone, and here select Read Object. We'll discuss all this in due time. As of now, I just want to give you an overview. Once you copy this URL, go to your web browser and paste the link, which will show you the picture. You can upload multiple files also. You are uploading 3 files at one go or 3 objects in a single operation. So all 3 files are being uploaded. It will take some time, as I said, because the object is being replicated across multiple data centers. It is done. You will access the object using this link. Before that, change the permission. This object is being read from the S3 bucket. S3 follows a storage hierarchy in keeping data. By data, I mean documents, images, videos, etc. There is S3 service. Under that, we have buckets. Here are your objects. By objects, I mean data or videos, files, songs, etc. These objects are stored inside of the buckets. Then the bucket becomes buckets with objects. Management console or S3 APIs can be used to manage buckets and objects. What are buckets actually? If you have used Google Drive, you know that all your data are stored under a single structure called My Drive. You can create multiple folders in your drive, but you cannot create multiple My Drives. A bucket is similar to Google Drive's My Drive, with the exception that you can create multiple buckets. Bucket names have to be globally unique, irrespective of which region they are created in, and also which account those buckets have been created by. If you create a bucket with the name AWS Foundation in, say, Ohio region, and I create a bucket with the same name AWS Foundation Mumbai region, we'll get conflict. We cannot create. I mean, the first one would be able to create, but the second person would not be able to create. So that's why bucket names have to be globally unique. Maximum 100 buckets can be created by an account. You cannot create more than that. This is a soft limit. If you want to create more, you can raise a support ticket with AWS and they can help you out. While communicating using SDKs, endpoints should be used. These endpoints are S3 endpoints. For North Virginia, the endpoint is s3.amazonaws.com. For any other region, it is s3-the region code.amazonaws.com. How to access a bucket using URLs? As I told earlier, that S3 would mainly be used by application programmers. SDKs and APIs would be used to do so. Here are the types of URLs. Those can be used to access a bucket. First one is virtual hosted style. Here you start with your bucket name, then dot, and then S3 endpoint. If your bucket name is AWS Foundation, then the bucket endpoint URL or bucket endpoint would be http://aws foundation dot the endpoint s3.amazonaws.com, or if it is not in North Virginia region, it will be bucket name dot s3 hyphen the region name dot amazonaws.com. If you have objects, you can append objects at the end of the URL. Then we have path style. In path style, buckets are accessed using this folder structure: s3 endpoint slash bucket name slash object name. So if my bucket name is AWS Foundation, and I'm using the path style, so I'll use the endpoint first and then slash and then the bucket name, which is AWS Foundation. For any other region apart from North Virginia, you'll have to append the region in between. As bucket names can be accessed using URLs, that's why it is recommended that bucket names follow DNS naming convention.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the popular scripting language of DevOps? A. Java, B. Python, C. HTML, D. C++. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So let us get introduced to Git, but before that, let us understand why are we only learning Git? Why not some other tool, right? Like I told you guys, there are a lot of distributed version control systems out there. Why are we only learning about Git, right? So let me just compare it on Google Trends, and this is the result that I get. Right? So if I search for Git, Perforce and Mercurial, which are actually the top 3 distributed version control systems out there, you can see that the Git tool is the most famous among them all, right? So that basically means that if you learn Git, you have a high chance that you might land up in a DevOps job more if you know Git than Mercurial or Perforce, because Mercurial and Perforce, because the popularity is low, we can easily conclude that not much of the companies are using these two tools, right? So most of the companies are using Git. In my experience also, I've seen most of the companies do use Git, right? And that is the only reason we have included Git in our course, and that is the reason we are learning Git also today. All right. So moving forward, now let us see what Git is exactly. Right? So Git is a version control system. It's basically a software which falls under the architecture of distributed version control system, right? And it does the same things which any other version control system does. That is, it tracks changes, it keeps your files versioned, right? And because it's distributed, you have a local repository as well, and then you also have a remote repository. Now in case of remote repository, you get a lot of options, guys, but in our course what we are going to do is we're going to opt for a free option, which is GitHub, right? So you might know GitHub is famous for all the open source tools which it hosts, right? So we are also going to work with GitHub, but for now we are going to just focus on Git. First we're going to understand what Git is, and then probably later we'll see how we can use GitHub in conjunction with Git. All right. Our next session actually is going to talk about the life cycle of Git. So we have understood, why are we actually learning Git? We understand what Git is exactly, but we do not know how it exactly works, right? We know the architecture, but we do not know how it works. So basically we've divided all the commands that you could be used frequently or you will be using frequently among these 4 domains, right? The first domain is about creating a repository. So we'll be discussing some commands which will help you create a repository in Git. Then we'll be dealing with commands which can help you make some changes in Git. Then we'll be dealing with commands which will help you do parallel development in Git. And then towards the end, we'll also be learning commands which will help you in syncing your repositories. Okay. So let's discuss each of these domains one by one. So let's talk about how to create repositories. Let's start from the scratch, right? So our first, whenever you start a project, the first thing that you have to do is you have to go to your working directory and you have to do some code or make some code, right? So the first thing that I'm going to do is let me just switch to my terminal. Alright, so this is my terminal and I'm logged into an Ubuntu server. So what I'm going to do is I'm going to create a directory which is say called DevOps. Okay, so let me create a directory called DevOps and let me just cd into this directory. Okay, so I'm into this directory now. Let me just clear the screen. Now let us add some files. Say I add a file called nano. Let me add a file called 1.txt. Okay, and let us say hello world in it. So this is our first file. Okay, now let me add one more file. Let us add a file called nano2.txt. Let's say hello from Intellipaat. Okay, so this is a file that we have added now. Let's save this file. Okay, so now we have two files which are there inside a folder, DevOps. Okay, so this is not being tracked by Git as of now, right? But it is still our working directory. Now, for making it a Git initialized working directory, all I have to do is type in Git init and hit enter. Okay, and now we have a initialized Git repository in front of us. Okay, so this is how you can initialize a directory in Git. So now you have created a repository in which you have your code, which will now be tracked by Git. Let's come back to our slides. So this is exactly what we wanted to do. We wanted to initialize a Git repository, and we have done that. We have added some files in that directory. Now let's go ahead and see what our next command is. So our next command is about knowing the status of what are the files doing in that directory. Are those files saved in Git? What is the status of that directory? And the command for seeing the status of directory or the files inside it is the command git status. So let us quickly jump back to our terminal. Let me just clear the screen. And now if I want to see like if my files are being if my files are saved in Git, what exactly is happening with my files. So what I'll do is I'll just type in git status, and I can clearly see that my files are right now untracked. Okay, why are they untracked? Because I've not staged them yet. These are just files which the Git is seeing that they exist in the directory, but they have not been added to my file system yet. So this is what Git is telling me right now. Okay, and it is also telling me if I want to track these files, all I have to do is git add and then the file name. So I don't want to do that right now. So let us go back to our slide. So this is what git status does. It basically gives you a status of your repository or of your directory. What are the files which are in the directory? I mean, what is the status of those files? Okay, so we got the status. Our next command is about adding. Right, so basically we have made some changes to our file and now we want to add it into a repository, and for doing that all I have to do is just go back to my terminal and I'll say git add. I can either type in the name of the files, so say I want to track both the files, so I'll just type in 1.txt or 2.txt. You type this, or what you can do is you can just type in git add and then a dot. Dot means track all the files which are present in this directory. So I'll hit enter, and now if I do a git status, let me just clear the screen. If I now do a git status, I can see that my files are now being tracked. Okay, so my files are now being tracked. They are staged, right? So if you think about the life cycle, you were in the working directory. Now you are in the staging area. You have staged your files. You want these files to be saved in the Git file system. They're still not saved. They're still in the staging area. The next step is saving these files in the Git file system. And for doing that, the command is git commit. Okay, so how do you type in the git commit? You type in git commit, then you give a space -m flag, which basically means the message, and then you type in the message that basically would point to what you are basically doing in that commit. For example, in this case, since this is our first commit, we can simply type, let me just clear the screen, git commit -m. We can say this is our first commit, adding 1.txt and 2.txt. Okay, so this is what we do. We just hit enter, and now you can see that my files have been committed to Git. Okay, and now if I do a git status, now, you can see it says on branch master there is nothing to commit, working tree is clean. That basically means all the files which are there in this directory right now are clean. They are all saved in the Git file system, and there's nothing to worry about right now. Right? So now let's do a little experiment. What I'll do is I'll add one more file. Let me just create one more file, and let us name this file as 3.txt and type in test file inside it. Right? So now what happens? So if I do git status, you can see it will say that 3.txt is a file which is untracked in Git. Rest all the files which are there, it is not listing that because those are already saved in Git, and they are there's nothing changed to those files. Also, let us try by changing, the 2.txt file, which is not listing over here, right? So what we'll do, we'll just do a little change to it. Let me just add 1.2 over here. Let us save it and let me do a git status now. Let's see what happens. So if I do a git status now, it can see there is a modified 2.txt file and there is an untracked file which is 3.txt. Okay, so this is something what you get. So any changes that you do to a file, it will be reflected in the status of Git. Now if I want the 2.txt file to be saved, I have to stage it again and then I'll have to commit it. Okay, that is the only way I can modify the 2.txt file. Okay, so let's come back to our PPT now and let us go ahead and see what is our next command. So our next command is about syncing repositories. So now we have committed the files to our local system, but how do we make it available to the world, right? So for making it available to the world, the first thing that you have to do is you should have a Git repository. Okay, so let me just jump on to my browser and then I'll show you how you can create a Git repository. So just give me a second. Okay, so guys, you just have to sign up on GitHub, and once you sign up, this is how your page would look like. Now what I want to do is I want to create a new repository. So on your left hand side you will see a button called new repository. Just click on that, right? And now let's name a repository something. So let us name it as DevOps and hyphen course. Okay, so our repository name is Devops Course and the type of this repository is public, and let us just now click on create repository. Okay, so our direct repository has now been created, and now what I have to do is I have to copy this link. This is a HTTPS link, guys, so I have to copy this link. Let us copy this link, and now let's come back to our PPT to see what exactly we have to do. Okay, so now to add files to this repository or to push files to this particular repository, first I have to add it in my command line. Now for adding this repository in my command line, I have to type in the command git remote add origin. Okay, this is the command git remote add origin and then the URL to the repository. So let us do that in our terminal. So I'm here. So right now when I'll commit, basically my 1.txt and 2.txt will be saved. My modified 2.txt file and my 3.txt will not be pushed. Okay, so let us see if that happens. So now what I'll do is I'll type in git remote add origin and then the URL of my repository. So the URL is this. Let me copy that. This is the URL and I'll hit enter. So now my files or my origin URL has been added in my command line, right? It has been saved in this Git repository, my command line that is working on my Git repository. Okay, so now let's come back to our slide. So we have executed this command. Let's see what our next command is. So our next command tells us how to push files to my URL, right? So the command is git push origin master, and see guys, this is the output for your command. Now when you type in this command git push origin master, it will ask you for your username and it'll ask you for your password. So let us do that. So let me come here and let me type in the command. So the command is git push origin master. Okay, I typed in this command. It is asking my username. Let me enter my username. It is asking my password. Let me enter my password. I'll hit enter, and as you can see, it is pushing the files, and now my files have been successfully pushed to my repository. Let us check that. Let us come back to our browser. Okay, and let us refresh the page. So as you can see, it just says 6 minutes ago the files were committed to the repository and now they have been pushed, right? And over here you can see the message of my commit, which was first commit adding 1.txt and 2.txt. So you get the message over here. Here are the files, so you can see the changes or you can see the content of the files as well. If you click on 1.txt, my 1.txt had the content hello world, so it's being reflected here. Similarly, if I want to see my 2.txt, I can see that it says hello from Intellipaat, right? So everything is here, everything seems to work fine. And again, what I can do is now if I do a git status, you can see that there are 2 files which have not been added. So what I'll do is let me first make let me add first the 2.txt file, that is a modified 2.txt file, into my git repository. So what I'll do is I'll type in the command git add 2.txt. Let me hit enter. So now this file has been staged. right? So if I do a git status now, I can see that this file is now staged. Okay, but this is still untracked, so we'll deal with this later. Okay, so now I have a modified 2.txt file, and all I have to do is git commit, and now I'll specify the message as modified 2.txt. Okay, so this is the message that I'm passing. I'll hit enter, and now my file has been changed, but these changes have now been done to my local repository, not to my remote repository. So if I come back to my browser and if I refresh, you can still see the file which was added .2.txt. It still says hello from Intellipaat, and it was committed 8 minutes ago, right? So it still is not added to my remote repository. Now to add it to my remote repository, all I have to do is git push origin master. Okay, I'll hit enter. It'll ask me my username. I'll provide the username and the password. And now my files are being pushed to GitHub. It has successfully done that. And now if I do a refresh over here, you can see that it says that 2.txt was committed a minute ago, right? And you can see the message over here. It says modified 2.txt, right? And this is exactly what we did. So we have added the second file as well to our remote repository. Let's add the third repository file as well, which is 3.txt over here. So we'll do a git add dot git commit -m adding 3.txt, and now we'll do a git push origin master. We'll give the username, we'll give the password, and now my file has been pushed. And now if I do a refresh here, I can see even 3.txt has been added with the commit message adding 3.txt. Okay, so guys, this is how you can push your files, or you can sync your remote repository to your local repository. Okay, so this was the command for that. Let's move forward now and let's check whether this step I've already done. So basically you can see that I have now synced my local to my remote repository. I have as you can see in the browser. Okay, now let's go ahead and see what our next step is. So our next step is to basically show you guys how you can clone a repository. Okay, so this is when I have basically I have pushed my local repository to my repos repository. Now say you are another developer who wants to work on this code. Now how can you work on this code? All you have to do is click on clone or download and just copy this link. Okay, copy this link, go to your terminal, right, and let me create a folder, say test over here, and let me create a folder called test over here, and let me go inside the test folder. Okay, now what I'll do is I'll type in the command git clone and I'll give the URL and I'll hit enter. Now what it has done, it has successfully copied the directory over here. So if I do an ls, I can see that the directory has been copied, or my repository has been copied to my local. Okay, and the awesome thing about this is, now if I go inside DevOps Course, the directory, now over here I don't have to basically add a remote origin, right? Because you have cloned the repository, so this directory automatically knows where, if I push any file, where it has to go. For example, if I create a file, say I create a file nano4.txt, I say test file for clone. Okay, I'll say that, and now what I'll do is I'll add this, I'll commit this file, adding clone file. Okay, I'll hit enter. So my file has been committed, and now I'll do git push origin master. I'll give the username, I'll give the password, and as you can see, my file has now been pushed automatically. Okay, so if I do a refresh here, 4.txt has automatically been added, and I did not do a git remote add origin even if I am in a different directory. Okay, now let me show you what I exactly mean. If I create a folder, say I create a folder called test. Okay, test exists. Let me create a folder called hello. Okay, and if I go inside hello, and if I do a git init, say I did a git init, and now let me say create a file called hello world.txt, Let me add any arbitrary text into it. Now if I do a git add dot, and if I do a git commit, and I'll say let's adding file. Okay, so the file has been committed. Now if I do a git push origin master, it'll give me an error. See, it says origin does not appear to be a git repository. Why? Because I'm in a separate directory right now. Okay, now if I do a cd, I go inside test, which was my first directory where I created all the files. So over here, if I do a git push, if I add a file, say, let me first uh, pull everything. Okay, so because the git pull origin master. Okay, 1 second, guys. Okay, so I think this is now the repository. Okay, so the repository was DevOps. So let us go into inside DevOps, and let me just create, or let me just say git pull origin master. So this was the directory where we first created our code. Okay, let me hit enter. So now it has, as you can see, it has added 4.txt to it, because earlier we added in a separate folder, right? So now it has created 4.txt inside it. It has added 4.txt inside it. And if over here you can see I have not specified what origin is. It automatically knows what origin is. Why? Because DevOps is a Git initialized repository. Okay. Similarly, when I said that hello is a Git initialized repository, but in hello I'll have to specify what is the origin of that repository, right? But if I do a git clone, as I did in test, right, I went into test and I did a git clone of the DevOps course. When I do a clone, it automatically copies the parameter as well as to what my origin repository is. Okay, any files that I add, if I push it on origin master, it will know where exactly it has to go. Okay, so this is how git clone can be helpful to you. All right, coming back to our slides. So now we know how to clone a repository in Git. We also saw how to pull, files in Git, but let me show you again. So basically what we want to show you is that say you are inside this folder, DevOps course, which is the same repository as what you have. Let me just duplicate this session. Alright, so this directory, which is DevOps, is pointing to the same repository as DevOps course. Okay, now if I do an ls here, I can see that there are 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. Similarly, over here I have 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. What I'm going to do is let me add a file from here. So nano 5.txt, and let me say test file. Okay, I've added it. Let me say git add dot. So I've staged the file. Let me commit the file. Test. Okay, I've committed the file. And now let me push the file to my remote. So I'll enter the username, the password, and now my file has been pushed. Okay, so if I have updated my remote repository, this local repository of mine will not get automatically updated. As you can see, it will not get automatically updated. If I do an ls over here, I can see there are 5 files, and if I go here on my remote repository, if I refresh, I can also see here are 5 files. But imagine this to be one developer and this guy to be another developer. Now this developer will not have the updated files till he does a git pull. Okay, so if he wants also the updated files which have been put on my remote repository, all he has to do is he has to type in git pull origin master, hit enter, and now the files will be updated in his system. Okay, so if I do an ls now, you can see that 5.txt file has now been added to this directory as well. Okay, so for coming back to our slides, so git pull helps you in updating your repository to the latest commit which is available on your remote repository. So that is what git pull is all about. And the difference between git clone and git pull is, like I told you guys, git clone is basically used when you want to copy the whole repository at your local system. But if you want to update repository when you're working in it, if you want to update all the files which are inside it, you can use git pull. In that case, git clone will not serve the purpose. Okay. Moving forward, now let's talk about branches. Now, as you can see, now we are talking about parallel development. Okay, and as we learned in our previous topics or previous sessions, that if you want to do parallel development, or if you want to assign code to multiple developers, you basically branch out, right? You create a branch in your repository and you assign that branch to the developer who would be working on the code. Okay, so let us see how you can create a branch in Git. So for creating a branch in Git, this is the command: git branch and then the name of the branch. Okay, so let us see if we can create it over here. What I can do is, let me just clear the screen. Okay, and let us say I create a branch which is something like this: git branch, and say I create the branch feature 1. Okay, so the branch has now been created. Now if I want to list all the branches which are there, I'll just have to type in git branch, and I can see there are 2 branches in my repository now. One is called the master branch and the other one is called the feature branch. Okay, now any developer who wants to work on this code can basically work on this branch, and when he feels that his work has been finished, he can basically merge this branch to master. And merging means that whatever code you have added to feature branch will also be added to the master branch. Okay, don't worry if you're not understanding as of now, you'll understand as we move along. Okay, so I have added a branch feature 1. Now if I want to delete a branch, again all I have to do is git branch -d and then feature 1. Okay, so it says deleted branch feature 1. That's it. Okay, so now your branch has been deleted. Okay, and this is exactly what we wanted to do. Moving forward, now if you create a branch and you want to switch to that particular branch, the command is git checkout. Okay, so now let me create the branch again, git branch feature 1. So I've created a branch, and what happens when you're branching? Basically the last commit of your master becomes the first commit of your feature branch. Whatever you have created, whatever branch you have created, the last commit of your master becomes the first branch of your branch that you have created. Okay, so for example, in my master you can see that there are 5 files. So now if I go inside, if I do a git checkout into feature 1, so basically now I have switched to the branch feature 1, and if I do an ls over here, you can see there are 5 files. Okay, now what I want to do is I'll add a file. Say I add a file 6.txt over here. Okay, and I say hello world. Okay, and what I do is I save the file, git add dot, I stage the file, and now I commit the file, added to feature branch. My file has been committed, and now if I do an ls, I can see there are 6 files now. But mind you guys, this is not on my branch manager. Now if you want to see which branch you are on, just type in git branch, and you can see you are on the feature branch right now. Okay, now what I want to do, I want to check if my master branch also has these changes. So what I'll do, I'll just switch to my master branch, git checkout master. I'm on my master branch now, and if I do an ls over here, you can see that the 6.txt file does not exist here. Okay, reason being, my feature branch is isolated from my master branch. Whatever changes I'm doing on my feature branch, it will not get reflected on the master branch, whatever I do. Okay, and whatever I do on my master branch will not get reflected on my feature branch. It works vice versa. Okay guys, so this is a feature which you basically use when you want to do parallel development, so that no branch is it is interfering with each other. So now I don't care what my developer is doing on feature 1. When he says that the feature is complete, I'll ask him to show me, and when he shows me the feature and I feel it's right, what I can do is I can merge it with my master so that it becomes available to the world. Okay, all right, great. Now if I do a git status here, git status, one second, git status, it says on branch master, nothing to commit. If I check out to feature, yeah, so if I have switched to feature now all I have to do is I will type in git status, and it again says on branch feature 1, nothing to commit. Why? Because I've already committed 6.txt to it. Now what I want to do is I want to push these changes to my remote repository. So what I can do is git push origin feature 1. Why? Because now we are pushing the feature 1 branch. We are no longer pushing the branch, the master branch. We are pushing the feature 1 branch, right? And I'll hit enter. So it'll ask me the username. I'll hit that. It'll ask me the password. I'll put that, and I'll hit enter. And now you can see my files are being pushed. And now you can see that feature 1 branch has now been pushed to feature 1 branch of my remote repository. So if I go to my browser now and I refresh it, you can see the 5.txt is still not visible here. Why? Because I'm on my master branch. I'll click here. I can see that I have a feature 1 listed over here. I'll click on that, and now I can see that the 6.txt file is visible here, and with my commit message which was added to feature branch. Okay, so I can again switch to my master branch, and I can see that my master branch is clean. If I switch to my feature branch, I can see that my feature branch is having the 6.txt file. Okay, let's come back to our slides. Alright guys, so we now know how to switch to a particular branch. Now let's go to our next slide. Now we probably know all the commands through which we can probably start working on Git, right? This command is a very important command, which is git log command. Now what is git log command? Now git log command helps you to see the history of your repository, like what all have you done on your repository. Okay, now to see the history of a repository, the command is git log. Now let us go back to our terminal and let us just clear the screen. Now if I do a git log here, I can see the history of all the commits.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now let's continue with the session.
Okay, so I can see that I am on my head is on the feature branch right now, right? And I can see that the last commit was this, when I added 6.txt to the feature branch. Before that I had a test commit. Before that I had a clone file that I added.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous delivery and monitoring. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Before that I had some other commit, 3.txt, 2.txt, right? So similarly I get everything, I get a history of everything that I've done so far, right? And these are all the commit IDs, guys. This is what we studied earlier, right? So if I want to say revert to this commit, all I have to do is just copy this commit ID and I have to type in git revert along with this ID, and I'll be able to revert to this particular commit. But we'll do that later. We're not doing that right now. We'll do that later. But this is the history of your branch. Okay. Now, if I want to see the history of master, this is the history of feature 1. Okay, let me just clear the screen and let me see where I am right now. So I'm on feature 1. So if we go to git checkout and then master and then clear the screen, if I do a git log over here, you can see that the head is now on the master and only the log of the master branch I'm able to see right now. Okay, I cannot see the log of adding the feature file. Why? Because I'm on the master branch now. So whenever you do git log, you always see the log of what branch you're on. Okay, so right now I'm on the master branch and that's why I can see all these logs. If I am on the feature branch, I can see all the logs of the feature branch along with the logs of master branch when the branch was when basically the moment I create a branch in my repository, it gets created from the master branch, right? So say I did 3 commits before I created a new branch. Those 3 commits will also be a part of my new branch that I've created. And if I go inside that branch and if I do a git log, I would be able to see those 3 commits in the log as well. Why? Because those 3 commits are also a part of those of that particular branch. Okay. So, but the moment I do any other commits on master, those logs of that commit will not come in my feature branch. Reason being, now my feature branch is separate. All right. So I hope this is clear. All right. Coming back to our slides, guys. So we now know how to see the history of our our git operations. Our next command deals with git stash. Okay, so what is git stash? So whenever you're working with multiple branches, there could be a point where you don't want to basically commit the file is basically still not complete, right? But you want to switch to another branch because you want to probably fix something in some other branch where you're having a problem, right? So basically it's about multitasking. It's about putting on hold the work that you're doing right now, completing the work over there, and then coming back here again and then starting with your work, right? So let me exactly first show you why do you need the git stash command. Okay, so if I'm over here right now, let me just clear the screen. Okay, so let us see where we are right now. So if I do a git branch, I can see I'm on the master branch right now. Okay, so what I want to do is I want to create, or let me just switch to my feature 1 branch and let me create a file called 7.txt. Let me name it as slash file check. Okay, so I have created a file, but this file is still not staged. It is not committed yet, right? So I am on my feature branch right now. So if I do an ls, I can see 7.txt is here. Now, if I change my branch, what will happen? Let us see. So if I do a git checkout master, and now if I do an ls, you can see the 7.txt file over here. Why can you see the 7.txt file? Because this file is not being tracked right now. It is not a part of any branch, right? Because it has not been saved yet, correct? So what I can do, so let me just come back to my feature branch. What I do, I'll just add, or I'll just stage this file. So let's see what then happens then, right? So I'll do a git add dot, right? And now the file has been staged, but it's still not committed, right? So if I do an ls now, it has all the files. Now if I check out to my master, and if I do an ls here, I can still see this 7.txt file. Now this can become a problem, or this might cause a confusion when you're working within branches or when you're working with production code, because you don't want this file to be here when you're on the master, right? Because you don't want your code to go haywire or cause a problem because of an extra file, or probably you changed something in 5.txt. Let me give you an example. Let me check out to my feature 1. Okay, and let me go to 5.txt. So this is my 5.txt and it's there in the master as well. Let me change the contents of this file. Okay, so I've changed the contents of the file. I'll stage it. Okay, and I'll do a git checkout master. Okay, I'm on my master branch now. I'll do an ls, and now if I do a cat of 5.txt, can you see these changes are also there in the master? I don't want that. I don't want that to be reflected over here because my feature branch should be different from my master branch. Now to avoid this confusion, although this file is not saved on the master yet, right? It is just being reflected over here. Reason being, these files are not committed to your branch in your respective branch where you were working. Okay, so how can you avoid this? Now the way to avoid this is you would just check out or you would just check out to your feature branch where actually you want this file to belong. Okay, and it tells you that these two files are there which this has been modified and this has been added. Okay, so it gives you a notification, which is good. Now what you'll do is you'll say git stash. You'll just say this and hit enter. Now what will happen? Now if I go to my master, git checkout master, okay, and if I do an ls, I can see the 7.txt file is no longer visible over here. Okay, and also if I do a cat on 5.txt, I can see this is the original file that the master should have, right? Now say I wanted to do something in my master branch. I'm done with that work. Now I want to get back to the work that I was doing in the feature branch. So what I'll do, I'll just do a git checkout feature 1. I'm back here. I'll do an ls. So right now the files will be not saved. So if I do a cat.5.txt, it will still be the test file. It will still show me the committed version of the file. I mean, if I want to restore the files that I was working on, all I have to do is git dash and then pop. This is the command to basically come back to your working state. So I'll hit enter, I'll clear the screen, and now if I do an ls, I have 7.txt, and if I do a cat on 5.txt, I can see this is the modified 5.txt. So I'm now again in my working state. If I do a git status, it will show me that my files have been staged, but then they have to be committed now. Okay, so now all I have to do is I'll say git add dot, and now I'll commit these changes, committing stashed changes, and now these changes have been committed to my feature branch, right? And now if I do an ls, if I do a git status, I can see that my branch is clean, and I can now easily just go back to my master. I don't have to stash anything anymore. And if I do an ls, it is still isolated. Reason being, everything is committed to the branch now, and there is no dangling files here and there which could confuse me with the files that I'm working in whichever branch I want. Okay, and this is why we use the git stash command, so that we don't have any confusions. The files don't get mixed up with the files of other branches and we don't get confused. Okay, so guys, this was the git stash command. Let's see what our next command is. So our next command is git revert. Okay, so this is an awesome feature of Git. So let us come back to our terminal. Okay, so what I want to do is I'll just do a git log, and I have all these commits over here, right? So I want to go back to my first commit where I just had my 1.txt and 2.txt. Okay, I want to go back to this commit. So all I have to do is I'll just click, or I'll just copy this commit ID, right? I'll clear the screen. I'll do a git revert, and I'll just paste that commit ID, hit enter. Alright, so let's go back to our terminal. Alright, so now for doing this, let us first see where we exactly are. So we are on the feature 1 branch. Awesome. So now we want to revert the changes, right? So for reverting the changes, the first thing that you do is you see the log. So right now the logs is that the last commit that was made on which the head is right now is this commit where we added these stashed changes. See, this caused a problem in my code, and I want to revert this. So I want to revert this commit. So whatever changes I'm doing in this commit will be undone, right? Now for doing that, all I have to do is I'll copy this commit ID, okay? And before just doing everything, let me just do an ls, and I can see that I have 7.txt which I added in my stash changes, right? So what I'll do is I'll just do a git revert and I'll paste the commit ID, right? So let me just take the commit ID from over here, done, paste it here, hit enter, and now you can see it will say your 7.txt will be deleted, and we modified 5.txt, remember, right? So my file which was modified 5.txt will also be reverted. So these will be the changes which will be committed once I revert from this commit. So I'm like, okay, so I want to do this. So I save it, and now if I do an ls, I can see that 7.txt has been removed, and my file also which I had modified has now been changed, and you can see the changes over here. So that 2 files have been changed, 1 insertions and 2 deletions, and this is it, right? This is what just happened. And if now I do a git log, you can basically just see that when I did git revert, it basically committed a new thing on my feature 1 branch. It committed a new file on my feature 1 branch with the message revert of committing stashed changes, right? And it says this revert commits 9A60 90. So basically it undid the changes which I did in this particular commit. Now if you still want to go back to this commit and see what changes have actually been done, what you can do is, if I want to go to this commit, all I have to do is just copy this commit ID, and now I'll type in git checkout and then the commit ID. Okay, so now I'm in the stashed commit, right? So now if I do an ls, I can see that 7.txt is present, right? Now what I want to see is what all things did we modify. I think we modified 5.txt, so let's do a cat on 5.txt. So I can see it says test file 12, and here is my 7.txt, which if I do a cat, it will say stash file check. Okay, now what I'll do is I'll say git checkout feature 1, so it will again return to the latest commit on my feature 1 branch. So I'm returned now. If I do an ls, I can see that 7.txt file is not there. If I do a cat on 5.txt, I can see that it has again returned to test file. So my changes which I did over here, that is I changed file in my commit of stash changes, that is I changed the file content to test file 12, and I created a file called 7.txt which I had stash file check. I had reverted this commit, and reverting means undoing the changes that you did in that commit, right? And it undid the changes that I did in that commit. So I no longer have 7.txt which I created, and I no longer have the contents of 5.txt to be the same as what was there in that particular commit. Okay, but remember guys, you still have that commit in your logs, and if you want, you can go to that commit and see what all things you want to fix, right? It's right here. But the head of the feature branch has now changed to a new commit which basically has undid changes or undone changes of what was there over here. Okay, sounds great. So this was all about git revert. All right, moving forward, the next command is git diff. Now git diff basically helps us in understanding what all has changed, right? What is the difference between two files, or what is the difference between two commits? What are the difference between two files? You can all see that using the git diff command, right? For example, if I come back here and I want to see the differences between what I did over here and what I did over here when I actually committed the stash. So we can do that. Let us see how we can do that. So I'll type in git diff, okay, git diff, and then I'll type in this commit ID, which is my head right now, and this commit ID, which I basically reverted. So I hit enter, and it will tell me that what all did change from both these commits, right? So it says that you have modified 5.txt. So there are two versions of 5.txt, a/5.txt and b/5.txt, right? So the a file was deleted and the b file was added, and it also shows the content, what content was changed and what content was added, right? So if I am comparing the the head with my previous commit. It says basically this file was changed and this file was added, right? And if I see over here, it says that there was nothing before and then we added 7.txt. Okay, now if I do the same by reversing the order of the commits, let's see what happens. So what I'm gonna do now is I'm gonna say this is the commit which I want to check the difference with this commit. So now you can see that it says that test file 12 was removed and test file was added. Similarly, 7.txt was removed and null was added. Okay, so basically this should be your newer commit and this should be your older commit, and then it will tell the difference according to that, right? Similarly, if I want to do this, so I want to first check if everything is fine. So let me do a git status. Okay, so everything is committed on my FIFA1 branch. What I'm gonna do is I'm gonna change something in 4.txt file. Okay, so what I'll do is I'll do a git, I'll do a nano 4.txt, and let me change the file content to test file for diff. I'll save it. Okay, sorry. So alright, so let's call this file as test file for diff. I'll save it. Okay, the file is now saved. I'll do an ls. So now my 4.txt file has changed and I can see that in git status. Okay, but I want to know what exactly changed. So what I can do is I can do a git diff with my head. So head points to the committed version of my branch, and I want to check what is happening currently, right? What is the current current in my current directory? I have not committed or I have not staged the file for changes, right? My current directory is different from what is committed on the git file system. So that is what I'm comparing right now. I'm comparing my committed my latest commit with what is there currently in my folder, that is dot. Okay, I hit enter and you can see it says that there is something which has changed in the 4.txt file. So there was test file for clone before, which now has been changed to test file for diff. And this is exactly what I wanted to check. So git diff is basically used to check the differences between two commits or two files. Okay, and this is exactly what we have checked right now. Awesome. So let us come back to our slides. So guys, this brings us an end to all the common Git commands that you could be using in your day-to-day life while you're using Git, right? In our next class, we are going to discuss the most important topic of Git, which is merging, right? Now, before going on to the next slides, I would request you guys, you practice all these commands once on your own. You will understand how things are actually working behind the scenes, right? I've showed you the syntax, I've showed you how it works, I've showed you the results. I want you to practice on your own as well.
So guys, Docker was essentially a need which came out of the problem that we're going to discuss just now. So imagine yourself as a developer and probably you're just creating a website on, say, PHP, right? So if you create a website on PHP, the first thing that you would do is write some code. Now, when you want to test that code, the kind of environment that you would be putting it in, let's see what all components would be there in that particular environment. So the first thing that you would need in this environment that is around the PHP file is an operating system, right? So an operating system which probably would have a browser or would have a text editor, right? So you need an operating system to work on. Now, secondly, because you are developing a PHP application, of course, you need the PHP software installed on that operating system so that your file can actually work. Right? Now, when you're developing a web application on a particular language, it's not just the language which will suffice with what you're doing. You also have to take into mind the third-party applications, the third-party libraries that you would be including in your code, right? So the third component that you would need when you're developing a website are libraries, right? For example, if your PHP website has to connect to a MySQL host, then it would need a PHP MySQL library for connecting to it, right? So these are the components that are basically required by a developer to run his program, right? So what he does is he writes a program, he configures the environment according to the program, and when everything goes fine, his program works well. Now, the problem occurred when this particular program had to be given to someone else, right? So the developer finished his job. Now it was the job of the tester to check this program. So the developer would give the PHP file to the operations guy, and let's see what the operations guy would do. Now the operations guy in the same exact position that the developer was when he was starting to develop his code, right? So, but the difference over here is now the PHP file is running. It is just that he has to run this file on the system, on his system, right? So the first thing that the ops guy would do is replicate the environment that the developer is having, right? So he would get the same OS, the same software, and the same libraries to run that PHP program. Now, there are a lot of versions for a particular software. For example, for PHP, you have PHP 7, which is currently running, but there are companies which are still, they're still working on PHP 5.6 because of, probably legacy problems or because the commands have changed. And if they want to move on to 7, they'll have to change all the commands in the code base, etc. There are a lot of reasons, right? So there is a particular version that this company is also following, right? So this ops guy has to have the exact same version so as to make the file work of the developer, right? Now he tried his best possible judgment in it and he installed the PHP software. He installed the libraries, he installed the OS, but still the problem was the ops guy couldn't make the file run. And he came to a conclusion that the code is faulty. But the developer says it ran fine on my system. It's your system which has the problem, so fix it by yourself. So these were some of the statements which were exchanged between developers and operations guy. If you think about it, it was actually nobody's fault, right? The operations guy did what he could in the best of his ability to replicate the environment, but it didn't work out. Now, you guys might argue that why don't we, use VMs in this case? Probably the developer could work in a particular VM and then just give that VM to the ops guy, and then he can work on the same VM and probably run the file, right? That is a viable solution. But the problem is the size of VMs is too large to give to the ops guy and give to the testing guy on every feature that a developer adds, right? For in that case, every developer has to have a VM that he's working on, has to have his own version of the VM, because if you are adding, say, feature A, and feature A requires 3 or 4 more libraries that you have included into your particular VM, it will become inconsistent with what other developers have. Now imagine the ops guy having several versions of VMs and he not knowing what kind of VM he has to impose on the production server or on the testing server, which basically will act as the final version of the image on which all the features of all the developers will work. Now it's a very hectic situation. So the problem was that VMs were very large and they were complex as well to handle when we are talking about staging area or the deployment area, the production area. They were a little difficult to handle. Now, this was the problem that was there before Docker. So what did we need? We basically needed a wrapper. Like in the case of what we just discussed, the wrapper was a VM wherein it basically contained all the operating system files, all the software, all the code, and all the libraries together, and could be basically lifted and shifted to a different system where it would execute, right? But we needed something more portable. We needed something more smaller that could easily be given to some other person for testing, right? We needed something like that. We needed a wrapper around our files. And the answer to this was this particular scenario, that now if we get a wrapper which will basically contain all the files, in that case each and every environment of ours will become the same. The developer environment is going to be the same, and the moment gets passed on to the ops guy, he will again deploy the same wrapper, and his problem is also solved because the ops guy does not have to match the versions of the OS, the software, the libraries, because everything is there inside that wrapper, or everything is there inside that container, right? He just has to run that container, and he can just see if the code is working properly according to what has been specified or not. Right? So the answer was that all the environments, the developer environment, the staging or testing environment, the production environment, all of these environments are now going to be the same, right? And this was possible using Docker. So what is Docker? Docker is basically a software which helps us creating this wrapper around the files of a code, the operating system, and the libraries that we mentioned that are required for a particular code to work, right? But the awesome thing about Docker is that you do not need the environment to be in GBs, right? You do not need it to be somewhere around 900 MB or 800 MB or 1 GB or 1.5 GB. A container could be as low as 50 MB. That is the size of a container called Alpine. It's as low as 50 MB. So it becomes very easy to basically give it to other people to test your code with all the environment set up in that particular container, right? So Docker is a software which helps us enable that. Docker is basically a tool which helps us in containerizing an application, right? And now let's see how basically Docker is doing this. How is it so portable? How is it so low in size? So basically this is the architecture of Docker. So at the base level you have the hardware. That basically means that you'd have a computer, and on that computer you would have an operating system present, right? So this is your operating system. So it's as simple as you have a laptop, and on that laptop you have Windows or Linux installed, right? Now once you have the operating system installed, the next thing is the container engine that you would install. So the container engine is nothing but the Docker software that you would install on top of your operating system, and that is it. Once you have installed the container engine, you can run any type of container that is there in the repository on the or on the web, which is available. For example, if your code needs an Ubuntu container, right? All you have to do is write Docker run Ubuntu, and what would it do? It would basically download the Ubuntu container. Then you can add your code files inside that Ubuntu container and start working, right? But how is it low in size? How is it not in GBs when we compare it to the Ubuntu operating system? It's around 800 or 900 MB, right? The Ubuntu desktop version. But how come this container is so small? So the answer for that is the container does not contain all the operating system files, right? So as you can see, the container engine actually shares its space with the operating system. So a container is void, or a container does not have a kernel in place, right? It shares the underlying kernel of the operating system on which the container engine is installed. So if I talk about, say, you have an Ubuntu operating system or you have a Windows operating system, and basically what you do is you download the container for CentOS. So CentOS is basically a Linux distribution, right? So you download the container for CentOS, and now when you're working in that container, you feel as if you're in CentOS. But the point is that the CentOS operating system is actually not installed.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the popular scripting language of DevOps? A. Java, B. Python, C. HTML, D. C++. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
What is basically happening is your container is sharing the resources from the operating system, but your container has the minimum binaries and libraries that are required to run the CentOS commands, right? For example, for installing anything on CentOS, you pass the command yum install and then the package name, right? So it would have the yum package in there in the container, right? It would have all the repository URLs there in the container, and that's how it behaves like a CentOS operating system, although the container is nothing but a set of binaries and libraries which are important for the CentOS commands to work, right? That is all what a container is. But with the underlying virtualization of the kernel or the BIOS of the operating system, your container seems to be like an operating system, although it is not. And because of this very reason, that it virtualizes the underlying kernel or BIOS to make it as if it's running on its own, that it is its own kernel or BIOS, is the reason that the containers are very lightweight, because they don't need to have all the files required for an operating system. They just need the bare minimum binaries or libraries required for that particular environment to work. Okay, so if you again come back to see this architecture, you have the hardware. On top of the hardware, you have the operating system. On top of operating system, you install the Docker software, and on top of Docker software, you run containers. So all these containers have the minimum binaries or libraries, and on these you basically just put your code. In my case, I will put my PHP code on top of the container, and that would be app1. And there could be multiple containers running on my system. For example, one code file is running in Ubuntu, the other code file could be running in CentOS container, the third could be running in some other operating system or some other flavor of Linux container, and all this is possible using the Docker software. Okay, so this is the architecture for a Docker container or a container in general. And now let us compare it with a VM, right? So I gave you the example of VM when I said that VMs are heavy in nature. So let us understand how containers are different from VMs. All right, so on the right side, you can see the architecture of VM, guys. So on the VMs, you have the hardware, which is the same as the Docker architecture that we saw. Then on top of hardware, you have the host operating system, which is the same as the Docker container that we saw. Now, on top of the host operating system, you have a hypervisor or a VirtualBox kind of software, which will basically virtualize the hardware from the operating system and give it to the VMs running on top of it, right? So you have a hypervisor software in case of VM architecture, and then you have the container engine software in case of a Docker architecture. Then on top of the hypervisor, you have the guest operating system. And this is where the all of the difference is, right? So in case of containers, you just have the bare minimum binaries or libraries which are present. But in case of your VMs, you have the whole operating system, which is basically installed on top of the hypervisor. Alright, so because you have the whole of the operating system installed, your size of the VM is quite bigger than what you have in the container, right? Now, the VMs could be multiple in nature. When we talk about how many VMs can we run on a machine, it totally depends on the specs of the machine, right? What are the specifications of the machine? So in VMs also, you can run multiple VMs on a single machine. And also, one thing to notice over here is that there could be or there could not be a host operating system in case of VMs, right? So in case of virtualization technologies, it has advanced this much that the hypervisor itself, it does not require a host operating system. It could directly work on the hardware level as well. But usually when we guys work in R&D, or when we have the kind of laptops that we have, right, the kind of specification that we have, we go ahead with this kind of an architecture where we have an existing operating system. On top of that, we install tools like VMware or VirtualBox, and on top of that, we install the VMs. Alright, so guys, this was the basic difference between a Docker architecture and a virtual machine architecture. Moving forward, now let's just discuss, so we have understood why do we need Docker, and we have understood that what Docker is exactly, right? Now let's go ahead and see how we can install Docker on our machines. Now, when it comes to installation, there could be basically three kind of installations that you might come across. You could either have an Apple or a Mac system that you're working on, you could have a Windows system that you're working on, and you could have a Linux distribution that you're working on. So let me walk you through all the three domains in basically installation, so that we are on the same page once we come out of installations and when we are doing hands-on. I hope you guys all will be able to, go along with the video as we are performing the hands-on. Alright, so if you're on Mac, guys, all you have to do is go to this link. So this link is basically going to download the Docker toolbox for Mac. And once you have the Docker toolbox, it'll basically install everything. It'll install Compose, it'll install the Docker software, it'll install the other components of Docker. So you don't have to worry about what component is what. But basically just go to this particular link, download the Docker software. And once you have the Docker software, just come back to this CLI and just pass the command Docker version. And if you get the reply as the version of the Docker which is running on your system, it's your software is basically successfully installed, right? So this is the installation for Mac. If you talk about the installation on Windows, just go to this link, download the Docker toolbox, and everything is going to be set up automatically for you, right? When we talk about Ubuntu, things are a little simple on the Ubuntu side. All you have to do is pass these commands and your Docker would be up and ready, right? So for our sake, we will be basically doing all our hands-on today on the Ubuntu distribution of Linux. So what I'm going to do is I'm going to just go back to my terminal so that we can use the PuTTY software to basically connect to our Ubuntu distribution. So just give me 1 second. Alright guys, so this is basically my Ubuntu distribution, right? So what I'm gonna do is I'm gonna install Docker in it. So the first thing that I would pass is the command sudo apt get update. So the first command that I'm gonna pass is sudo apt get update. Once I've done that, the next command that I'm gonna pass is sudo apt get install docker.io. Alright, and then you'll be prompted for a yes or no. Just type in Y, which will mean yes, and this will install all the packages required for Docker to work on this particular system. Right, so if your internet is fast, it will hardly take a minute to install Docker, and once Docker is all installed and set up, we can go ahead and check whether Docker is working on our system or not by typing in sudo docker version. So just give it a minute and this will all be over soon. Alright, so Docker is installed now, and all we have to do now is check the version. So it's docker --version, and as you can see that the Docker version is 18.061 CE and the build is this. So this basically confirms that Docker has been installed on our system. So I've successfully installed Docker. So now let's go ahead and see what is in store for us on our next slide. Alright, so we have installed Docker on our system, guys, and I hope you guys are also, if depending on the kind of OS that you're working on, I hope you guys have also installed Docker on your system. If not, you can pause this video, do that first and come back, because I would want you guys to learn as much as you can from this session, and I would want you to follow me while I'm doing the hands-on so that you get the maximum knowledge possible from this session. Alright, so the next thing that we're going to do in this session is get acquainted with the Docker container lifecycle. Alright, so basically this is how this is the whole lifecycle of what a container goes through when we talk about the Docker ecosystem. Now, if you guys know what GitHub is, or if you guys have worked on GitHub, you guys might know that there is a central repository. Whenever you start, or whenever you have to start working on a particular code base, the first thing that you have to do is pull the code base from the central repository. Right, so that central repository is nothing but something on the cloud or something on the internet which holds all the code base for your organization or for your team that everyone is working on, right? So that is basically a central place where you can download everything from. And similarly, in Docker, we have something called as Docker Hub. Now, Docker Hub would contain all the container images that are present, that are open source images that are present. For example, I told you that you could run a container on Ubuntu, you could run a container on CentOS, you can run a container on Alpine, you can run a container on some other operating system. So all of that is present on Docker Hub. Right, so the first thing that you do is pull an image from Docker Hub onto your system, and this is your system where Docker engine is installed. And basically what you download from Docker Hub is an image of a container. Okay, so you get the image, and the next step that you do is you run that image, and the moment you run an image, it becomes a container. Right, so you can run that image, and that would basically be the normal way or the normal state of a container that it is running. Once you want to stop a container, that is again a life cycle state, that when you're done with working on the container, you can stop it. And once you are done with everything, you don't need it on your system anymore, you can remove it. So this is the life cycle of a container. The first thing that you do is you pull it from Docker Hub, it becomes an image, then you run that image, and it becomes a container. And the containers can either be in a running state, in the stop state, or in the deleted state. So this is the life cycle of, this is basically, I would say, a summary of what happens inside Docker. But of course, there is more to it, and we'll see as we move along in the session. Okay, so we've understood the common, the common ecosystem of Docker. We've understood what Docker is. We have understood how the containers work inside the Docker ecosystem. You first download them, they become an image, then you run that image, and then they become containers, right? So with this knowledge now, and with Docker installed on our systems, let's go ahead and perform some common Docker operations that you would be doing when you are working on Docker in your day-to-day life. All right. So this is the first command that we can try out when we are working on Docker. All right. So whenever you want to find out what version of Docker that you're working on, you can simply pass this command, Docker version, and then you can basically get the version that you're getting on. Let me quickly change the color of the terminal because I feel that this color is a little dull. So
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now let's continue with the session.
So that it becomes better for us to see. Just give me 1 second. All right, much better. So when we pass this command, Docker version, you get the Docker version, the current Docker version that is installed on your system, along with the build name. And this is exactly what this command does. All right. The second command that you can go ahead and try is Docker pull. So we saw the container lifecycle. The first thing that you do is pull the image from Docker Hub. All right. So and the syntax for pulling the image is Docker pull and then the image name. So as you can see in the screenshot, we passed the command Docker pull Ubuntu, and what it did was it downloaded a container from Docker Hub automatically. So what we can do is we can also try that out. So let me just clear the screen. All right. Okay. So we'll type in Docker pull and then the image name. So this is the image name and we'll hit enter. All right. So sorry about that. I forgot to use sudo. All right. So sudo docker pull Ubuntu, hit enter, and this would download the latest Ubuntu image on your system. Now remember guys, we have just downloaded the image. We have not run the container yet, right? So our next command would be docker images. So now if you want to check what image did you download and is it existing on your system to verify, all you have to do is type in docker space images. So about that. So sudo docker images, and then you would be able to see the image that you just downloaded. Okay, so this is the image that we just downloaded, and you can see the size. It's 86.2 MB. 86.2, that's too low to be an operating system, right? Imagine the beauty, guys. So an Ubuntu operating system, a VM that you're working on, is I think around 1.5 or 2 GB. But when we talk about this container, it's hardly 86.2 MB. Awesome, right? So once you have seen the images, the next step would be to run this image, right? Now to run this image, the command is called docker run and along with the image name, right? So you use some flags as well when you're using docker run. So let me explain you while I'm executing this command. So sudo docker run, this is the syntax. The next flag that you add is -it, which basically means make the terminal interactive. -d, which means run the container as a daemon, run the container in the background. So whenever I run the container, make it running in the background till basically I stop the container. So that is what -d does, right? So the command would be sudo docker -it. It means make the container interactive in the terminal so that I can also pass in commands. -d, which basically means make the container a daemon that it should be running in the background even though I'm not working on it. And then you pass in the image name. So the image name is Ubuntu, and then you hit enter. So can you see you just got an ID of the container? So basically this, if you get something like this, this means that your container has just started. And then to view all the running containers, all you have to do is pass the command docker ps, and that would list down all the containers which are currently running in your system. So let us do that as well. So let me just clear the screen. So just pass in sudo docker ps, and this would basically show you the container which you have just started. So as you can see, I started the Ubuntu container 29 seconds ago, and this is the container ID for that particular container. All right, so my container is running. So what's next? Next step would be to see docker ps would basically show you the containers which are run in the running state. But what if you want to see all the containers which are there in your system? For example, what I can do is I can do a sudo docker stop, and I can stop this container, right? So this container is now stopped, and what I can do is I can run one more container, which would be sudo docker run -it -d and then Ubuntu. Sorry about that. So if I do a docker ps, I would only be able to see the container which is currently running. So you can see it is up 7 seconds ago. But if I want to see all the containers which are there on my system that could either be in the start state or the stop state, all I have to do is type in the command sudo docker ps and then -a. And with this, I can see the containers which are running. So this is container which is running, which was made around 27 seconds ago. And this is the container which has exited, which we manually stopped. And we can see that also by passing the command sudo docker ps -a. Okay. Now the next step would be to work with the container. So we have started the containers, but the next step would be to start working on them. And how can we do that? We can basically do that using the command docker exec. So what we'll do, we'll just first get the container ID. So that container ID is docker ps. All right, so this is the container ID. This is where this is the container which is currently running. Now, if I want to get inside this container, the command for that would be docker sudo docker exec, so exec, then -it, make it interactive, give the container ID, and then bash. Bash would be that I want to run this container in the current terminal space that I'm working in, and the current terminal space is bash, and I'll hit enter. So let me just clear the screen. So can you see that you are now inside the container, right? So this is the container ID, and this is the user of the container. So we are basically acting as root of the container ID. That is, we are inside the container and we are acting as root. So this is basically the environment. This is the environment that I was talking about that the developer will start working in, right? And this is basically an Ubuntu container. So all the Ubuntu commands are gonna work inside this particular container. So once we are inside the container, we can do whatever like. So for example, if I have to update the container, I can do an apt-get update, and it will start updating the container as if it's a new operating system which is running on the system, right? And also to show you guys that this is different, or this is completely independent from what we were doing outside the container. You remember we have Docker installed on our host operating system. Now if I try to access Docker from here, I will not be able to do that. So if I do a sudo docker ps, you can see that it says okay, let me do a command docker ps. You can see that it says docker command not found, right? So basically Docker is not installed inside of the container, and that is the reason it is not able to access Docker. Also, an interesting thing that you can see over here is that I pass the command sudo docker ps, and it says sudo command not found. So the sudo library is not installed in the container, right? So I told you the bare minimum libraries which are required for a container to make it behave as a particular operating system is only present in the operating system, is only present in the container and nothing else. And that is why you can see even sudo as a command is not present inside the container. All right, so if you are inside the container and you want to exit the container, all you have to do is type in the command exit, and this will make you come out to your host operating system. But mind you guys, your container is still running. So if you do a docker ps, you can still see the container running in your docker ps space. Alright, so this is how you can get inside a container. All you have to do is docker exec -it and then the container ID space the terminal that you're working in, which in my case was bash. Alright, okay. Now again, so this I already showed you that if you want to stop a container, all you have to do is sudo docker stop and then the container ID, hit enter, and the container will be stopped. And then if you do a docker ps, you will not be able to see any containers which will be running inside the system. So as you can see, once we did a stop, there are no containers running over there in a docker ps space now. Okay. You can also kill a container in case a container becomes non-responsive and you're stopping the container but it's not able to exit. What you can do is you can kill a container. It's similar to that of stop, but when you stop a container, it basically gracefully exits the container. It's just like shutting down your computer or just switching off the power switch from behind the computer's power outlet. Right, so if you have the stopped the container but the container is still not stopping because of some program which is running in loop inside the container or something like that, you can immediately kill the container using the command docker kill and then the container ID. Then you have something called as docker rm. So basically I told you guys that if you do a docker ps -a, you can still see the containers which were stopped, which were in the stop state, right? But as we saw in the life cycle, there's a third stage of Docker containers, which is basically the delete stage. And to reach the delete stage, you pass in the command docker rm and then the container ID. And this would basically delete the container from your system. Now let's see how we can do that. For example, if I want to remove both these containers from the system, all I have to do is take the container ID, pass in the command sudo docker rm, and then pass the container ID, hit enter, and this would remove the container from my system. So similarly, if I want to remove the second container as well, I'll just have to pass in the command sudo docker rm, the container ID, hit enter, and the containers will be removed. And now if I pass in the command, let me just quickly clear the screen. Now if I pass in the command sudo docker ps-a, you can see there are no containers which now exist because we have just removed them from our system using the command docker rm. All right. Moving forward, now what to do when you have to remove an image? Now you guys know we already have an image in our Docker system, which is this. We have the Ubuntu image. Now if you want to remove this image from the system, the command for that is docker rmi and then the image ID. And this would remove the image from your system. So if I want to remove this, all I have to do is type in sudo docker rm. So rm was to remove the container. If you want to remove the image, just type in I as well in front of the rm command, and then the image ID, which is this. Pass in this, hit enter, and this would delete the image from your system. So if you do a sudo docker images now, you can see that the image is not present in the system anymore. All right. So this is how you can remove image from your system. And this was it, guys. So this was how you can basically go ahead and do these are some of the common operations that you would do in your day-to-day life while you're working on Docker. And I hope you guys are well acquainted with all these operations. So what I would suggest you guys is pause this video, try to do all those commands together, and once you're done with that, let's resume the video to going ahead, right? So our next topic is basically to create a Docker Hub account. So like I was comparing it to GitHub. So if you guys have worked on GitHub, you also have to create an account on GitHub in case you want to have your own repository where you want to push your own personal stuff or your personal code for your probably R&D or whatever you want to call it, right? Similarly, you have something in Docker Hub as well. If you have created a container for your own testing purposes or R&D purposes and you want to push it to Docker Hub so that in later time probably you can pull it whenever you want, or if you want to share that container with the other people, all you have to do is create a Docker Hub account and push your container image on that Docker Hub account. Right, so that is possible, but the first step would be to create a Docker Hub account, and for that you have these steps. So first you have to go to the website hub.docker.com. So let me quickly show you that. So all I have to do is go to the browser, go to hub.docker.com, and you would see a website which will look something like this. All right. The next thing that you would have to do is you will have to sign up on this website. So just choose a Docker ID. Now this Docker ID is basically like your username, and this username has to be unique. Right? Enter the Docker ID, enter your email address, your password, agree to the terms of conditions, and just click on sign up. After this, you would get a verification email on the email address that you specify over here. Verify your email, and that's it. Your Docker Hub account is all set up, right? I already have a Docker Hub account, so let me just quickly show you that. So my Docker Hub account looks something like this. Just give me 1 second. All right. So guys, this is my Docker Hub account. And as you can see, I have some personal containers that I uploaded over here. And I'll show you guys also how you can do this. But before that, let's come back. So once you have set up your Docker Hub account, you would be able to see your Docker Hub account, which would look something like this, right? And always remember, guys, remember your user ID, because it's going to help you out in the future when you are basically pushing your custom images onto your account, that is your Docker app account. Alright, so always keep your user ID handy. Alright, so guys, this is how you can sign up for Docker app. Once you have signed up, let's go ahead and see how you can save changes to a container. Alright, so what does this basically step means? So this step basically means that if I am on my system and say, I run my Docker command, now say I run a Docker container, right? So this is basically download and run the container for me. So sudo docker ps, this is the container that I want to go into. Alright, so I'm now inside the container. Now what I want to do is, let us do an LL, and you can see these are all the directories which are present inside the container as of now. Now what I want to do is, I want to say create a directory, and say I create a directory called app, right? So if I do an ls now, you can see there is a new directory app which has been created inside this container. Right now, if I exit this container and say I do an ls, if I do a sudo docker ps, I can see that the container is running. But the catch here is that if I delete this container, say I delete this container.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous delivery and monitoring. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so one more thing, guys. If you want to remove or delete a container which is running, you can pass in the command sudo docker rm-f and then the container ID. The other way to do is to stop the container first and then delete it. That is a general way of doing it. But if you're in a hurry and you want to delete the container which is in the running state right now, just type in the command sudo docker rm-f and then the container ID, and this would remove your container. Alright, so I've deleted my container now, and if I now type in, if I again run the image, that is sudo docker run -it -d and then the image name, and if I go inside this container, and if I do an ls, you can see the directory that I created, it is not nowhere present over here now. The reason for that is, whatever changes you made to the container, they were only present inside the container, and this container, when deleted, these changes do not propagate into the image that you downloaded originally. Alright, now if you want to make changes to a container and want those changes to be saved inside an image so that you can later on again launch a new container, and it should have all those files or folders or softwares that you installed inside the container, you would have to save these changes inside the container, and for that you would have to learn how to save changes inside a container. Let's go ahead and learn how you can save these changes inside a container. Alright, so for saving changes inside a container, the command is called docker commit. Okay, so you have to pass in the command docker commit, the container ID that you want to save, and then the new image name. So basically this will create a new image of a container, and once you pass in the container ID space, you have to give the new image name that you want that custom image to have, right? So for example, in my case, if I create the folder, say app, I do an ls, I can see the app folder is there now. Right, I'll just exit the container, I'll do a sudo docker ps. I can see this is the container ID. So I'll just copy that and sudo docker commit, pass in the container ID, and then the new image name. So the image name, let's say I say the image name is test. All right. So with this, if I now do a docker images, I can see that there is a new image which is present, which is called test. All right. And now I can run a container on the image test, and all I have to do is sudo docker run -it-d and then test. This would run the container, and if I go inside the container now, I can see that my changes would be there inside this container. So if I do an ls, I can see that the app folder is present. And this is how you can create a custom container. So I, for demo purposes, just created a folder. You can also install softwares inside a container. Like for example, you install Apache, you install MySQL, or any other kind of software that you want. Then all you have to do is save the container using the docker commit command, and you're all set. Whenever you run that image again, you would have all those softwares installed inside that container. All right, and this is how you save changes to a container. All right, so now let's do this example. So basically what we're going to do is we're going to run an Ubuntu container. We're going to install Apache on it. And once the Apache is installed, we're going to save that container into an image. All right, so let's see how we can do this. So let's clear the screen. Let's exit this container and let us first clear everything up. So sudo docker ps. So there are two containers running. Okay, so let me show you one more command, which is basically like a shortcut. So if there are like tens or five or more than 5 or more than 3 containers running on your system, you always don't have to pass in the command sudo docker rm -f and then pass the container IDs. The shortcut to remove all the containers at once is the command sudo docker rm -f and then pipe it with another command, that is the sudo docker ps -a and then -q. You pass in this command, it would remove all the containers which are present in your system. So if I do a sudo docker ps now, you can see there are no containers running anymore. All right. So this is the shortcut that you can use while working with Docker. All right. So my next step is to basically install. So first I have to run an Ubuntu container. So I'll do a sudo docker -run -id Ubuntu. All right. So my container is now running. The next thing that I have to do is install Apache server on this container. Okay. So let's take it a little differently now. So basically, okay, so let it be like this. We'll come back to the part that I wanted to explain to you guys later. So basically now I'll just exec into this container. Okay, I'm in. First thing that I'll do, I'll just update the container. So apt-get update. Okay, once it's updated, the next step is to install Apache, and for that the command is apt-get install Apache 2, and this should install the Apache software. All right, and service Apache 2 status would give us whether Apache is installed or not. So it says Apache 2 is not running. So let's start the service. So service Apache 2 start, hit enter. And if I now check the status of Apache 2, I can see that Apache 2 is running inside the container now. Awesome. This is what I wanted. So let me just exit the container now. And let me save the container. So we have installed Apache on our container. Next step is to commit these changes to the container so that it becomes an Apache container. All right. So I'll do a sudo docker ps. This is the container ID. I'll say sudo docker commit give the container ID, and now give the image name. So let's give it as Apache. Or let me make it a little more simpler for me when I move ahead. So whenever you want an image pushed to your Docker Hub account, there is a certain nomenclature that you have to follow when you're naming your image. So first of all, you would have to write the username for your Docker Hub account. Remember, I told you to remember your user ID, and this is exactly for that. So specify your user ID / and then whatever name you want to give to your container. So that would be Apache, right? So the naming would be specify your user ID / your container name that you want to give. All right. So sudo docker commit container ID and then the container image name that you want to give to your custom image. Hit enter, and this should basically save your images. So if I do a sudo docker images now, you can see that our image has been saved over here with the name hshr/apache. You should also notice that now my size of the container is 212 MB. Because I've installed the software, the size has gone up. It was 86 MB before, but because we have installed a software on it, it has now become 212 MB, which is fine. Alright, so now we have the new image. So what I'm gonna do is I'm gonna remove all the containers which are running now. So sudo docker ps, this is the container running. So let me just remove it. Okay, forgot to do the -f. Awesome. So now what I'll have to do, to check whether my image is functioning properly or not, what I can do is I'll just pass in the command sudo docker run -it -d and then the image name, this is hshr/apache. Okay, I'll introduce you to one more flag, which is -p. Now what -p does is it basically does port mapping. So when I've installed Apache, if I want to check if Apache is working or not, normally Apache works on port 80, right? So on containers port 80, Apache would be running. But if I want to check the port of the container, or if I want to check if everything is running inside the container fine, I'll have to map the internal port of the container to the outside host operating system. So in this case, I'll have to map it, say if I want to map it to port 82 of my OS, of my host operating system, to the 80 port of my container. This is the command to do that. -p space port number that you want to specify, the port number of the container that you want to link it with. So I want to link the port 82 with the internal port 80 of my container, which has the image running hshr/apache. All right, I'll hit enter. This would create the container, and if I do a sudo docker ps, I can see the container is now running. So let's exec into this container. So sudo docker exec -it, give the container ID bash, and if now I do a service apache 2 start, it should basically give me either an error that apache 2 not found, or it should start the service. So let's see what happens. So it says service Apache web server Apache. So this basically means Apache was present inside this container because we did the sudo docker commit. Apache was installed inside this container, and this now service has been started. Now remember guys, we have mapped it to port 82. So now let's check if we can access the Apache software on port 82 of this server. All right. So let me just go to the IP address of the server. So basically the server is running on AWS. So this is the IP address of the server, and I have opened it on port 82, right? So right now if I hit enter, it will not work. Reason being, I'll have to open the ports on this server. So let me just do that. Let me open all traffic so that we are on the safer side. Okay, so IP address : port number, which is 82. hit enter, and you can see the Apache is successfully running. So mind you guys, Apache is not installed on the server. It is installed inside the container, and that software is able to access on the browser using the port that you mapped on the container. All right. So our um, for our verification, what I'll do is sudo docker ps, and I'm gonna stop this container now. Sudo docker stop, pass this ID, and now if I do a refresh over here, you can see that it says the site can't be reached. Reason being, I've stopped the container over here. All right, and this is how you can save changes to a container, install software, and create a new image out of it. Now next step would be to push it to Docker Hub, right? So I told you guys, once you are done working on your container and you've created a custom container that you want your team to access, or you want it to be there on Docker Hub for safety purposes, you can push it to Docker Hub. And to do that, the command would be sudo docker push, which I'm going to explain in a little bit. But before that, we saw the life cycle, right? We saw we can push or pull from the Docker Hub. So this is the pushing state. So we had a Ubuntu container, we installed Apache on it, and then we committed the changes, and now we have an image on our local system. The next step is to push it to Docker Hub, right? And let me show you exactly how to do that. So this is your Docker Hub, guys, and the first thing that you would have to do is you would have to log into your Docker Hub from your console, and to do that you will have to type in the command sudo docker login, pass in this command. You'd be asked the username, so pass in the username of the Docker Hub and then pass the password. So if there is any problem with your password, it will give you this error. So let me just try once more. So I'll pass in the username and then I'll pass in the password. And on a successful login, you will get this message that is login succeeded. Awesome. So I have logged into my Docker Hub. Now what I want to do, I want to push my image. So I'll have to do a sudo docker push. And what was your image name? It was hshar/Apache. This was the image name, right, that we gave to our custom container image. Hit enter, and it will start pushing your image to Docker Hub. And once it has pushed the image, all you have to do is you can just visit your Docker Hub repo, and you'd be able to see your image listed over here. Just do a refresh and just go to the last page, and you can see this is the image that I just pushed to the repository, which is hshar/Apache. Awesome. So we have successfully pushed our image to Docker Hub. So it's very easy. Just type in the command sudo docker push, and that should be it. All right. So our next topic now is introduction to Dockerfile. Now the next step is, what is a Dockerfile? So a little introduction about a Dockerfile. So you just saw that if I had to make changes to a container, I basically had to run the container first, go inside the container, install whatever software I want, install whatever I want, and then come out, commit the container, and only then it will get saved. But there's a shorter version of this. When you're working on production grade environment, everything has to be lightning fast, right? And for making changes to a particular container image, you can also use something called as a Dockerfile, right? So we're going to discuss what a Dockerfile is now. So let's go ahead and start with this topic now. So a Dockerfile is nothing but a text document in which you write how do you want your container to be customized, right? So one example, like I just told you guys, was when I did it manually. I ran a container, I went inside it, I installed the software, came out, committed the container, and then pushed it onto Docker Hub. Now, all these changes can be automated using a script style, which we call the Dockerfile. Now, a Dockerfile is very easy to write, and there are basically some nomenclatures or there's some syntaxes that you would have to learn, but I'm sure they are very easy to learn, and once you learn them, it'll only be Dockerfile that you would be using rather than doing everything manually. Right, so let's go ahead and see how we can create a Dockerfile. So guys, these are some of the syntaxes, these are some of the important syntaxes that are relevant to creating a Dockerfile. Now, the first line of a Dockerfile is always from, right? So the image on which you want to make changes. For example, we made changes on the Ubuntu images where we installed Apache. Right, so what we did docker run -it-d and then Ubuntu. So in Dockerfile, the first base image that you want to work on, you'll have to specify it on the first line using the command from. Okay, so this area uh, of your presentation will basically tell you the Dockerfile content. So this is exactly how the content of the Dockerfile should look like. So the first command is from. So from Ubuntu. So the base image that I want to work on is Ubuntu. So this would be the first line. Second command would be to add all the files. So add is basically used to add files inside a container. Now, for example, say I create a HTML file and I want that HTML file to be added inside the Ubuntu container. So for doing that, the command add, the first argument would be the place where you want, where the files are present, and the second argument would basically be the location inside the container where you want all those files to be copied. All right, so add space dot, the meaning take files or take all the files from the current directory and put it inside /var /www and /html. All right, so this is what the add command does. The third is run. So whenever you want to run any command in the container, for example, I ran apt-get update and apt-get install Apache 2 inside the container, right? Now, if you want to run the same commands from the Dockerfile, you can do that using the command run. So over here, there are two commands that I want to run. The first is apt-get update and the second is apt-get install Apache 2, right? The -y signifies over here the option that we get, that whether you want to go ahead with the installation, yes or no. So if you specify -y implicitly in Dockerfile, it would not ask that option and it would continue the installation without any prompts. Alright, so run command is basically used to run any command inside the container on the terminal that you would have ran. Okay, then you have a command called cmd. So cmd keyword is basically used to run any command that you want to run at the start of the container. All right, and these commands run only when there is no argument specified while you're running the container. So while you're running a container, you can also specify any command that you want to run. So in case you specify a command while so for running a container, the command is docker run -it-d and then the image name. Now after the image name, you can also specify a command that you want to run inside the container. Okay, so if you don't specify anything like we did, then in the Dockerfile, this command will be running when we are starting the container. Otherwise, whatever command we specify in the docker run command, that would be running. Okay, then so this was about the cmd command line. So in this case, what we are doing is, what we want to do is, like, remember when we started the container, we always had to go inside the container and start the Apache service manually. That is, once the image is started or once the container is started, go inside the container and type in the command service Apache 2 start, right? So that had to be done manually. But when you pass it using the command cmd, which is nothing but all the commands run on the startup time. Whenever the container will start, this command will execute automatically if you specify it under cmd. So cmd Apache CTL -d foreground would do nothing but run Apache the moment the container starts, and this is exactly what we want, right? So this is possible using cmd. So again, I'll repeat it. CMD is used to run commands at the runtime of a container, and they run only when there is no argument specified in the Docker run command. If there is no argument specified, the cmd command will run, otherwise it will be skipped from the Docker file. Alright, the next command is entry point. Now entry point is exactly the same as cmd, that is it runs at the starting of the container, but the only difference is cmd will not run if you specify an argument in Docker run, but entry point will run irrespective of the fact whether you have specified an argument or not. Alright, so cmd and entry point can be used interchangeably, but if there are cases when you'll be running the container with an argument, so it's better to use entry point so that the command does not get skipped. cmd command will get skipped if you specify an argument after the Docker run command. Okay, so in our case we use the Apache ctl-d foreground with the entry point command. Alright, the next command is env. So if there are any environment variables that you want to set inside a container, you can pass it using the command env space the name of the variable and space the value of the variable. Alright, so in my case I specified a variable name which has the value Devops Intellipaat. Alright, so these are some of the commands that you can use to create a Dockerfile. Now let us create this Dockerfile on our system as well. So what I'm gonna do is I'm gonna go to my putty software and I'm gonna specify nano and then Dockerfile. So let me just create a directory first. So let me create a directory called Dockerfile itself. So mkdir Dockerfile. Let us go inside it. So cd Dockerfile, and now whenever you are creating a Dockerfile, the name of the file always has to be Dockerfile itself, right? So I'll specify nano and then Dockerfile. We went inside. So the first thing that we want to do is we want the Ubuntu image to be called. Then we want to update this image. So apt-get update. Then we want to install Apache inside it. apt-get -y. Sorry about that. So apt-get -y. Install Apache 2. Alright, sounds good. Then we are going to add all the files from this directory to the directory var www.html. So we're going to create this file. Do not worry, we'll just create this file. Right, once we have done that, the next step would be to run Apache in the foreground. That is, run it. So Apache ctl -d foreground. So this would run Apache automatically. Okay, and you specify the entry point and say I also want to specify environment variable. Say let me create an environment variable called name, and I want to specify the value as Intellipaat. Okay, sounds good. So this is my Dockerfile, and I'll just save this now. And let me create a HTML file as well. So let's create one.html, and let us make it a little simple. So this would be a hello world HTML file. Okay, the body, and in the body say I have an h1 which will say hello from Intellipaat. Close the header, close the body, and then close the HTML. Alright, this is what I want to do. I'll save this, and now we are done with the Dockerfile and we have the HTML page in place. So the next step would be to build this Dockerfile. Now let's see how we can build it. So for building this Dockerfile, all you have to do is docker build.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customer says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, and practical also. I'm encouraging people to take courses on Intellipaat.
Now let's continue with the session.
Where do you want to build it? I want to build it from the current directory, and the image that it will create, I want to name that image as, say, new underscore Dockerfile. Okay, so it will be named like this. So I'll hit enter, and I forgot to mention sudo. So let me just clear the screen. Alright, so let me first teach you guys how to run a Docker command without sudo. So for doing that, just type in sudo usermod -a-n-g and then docker and then $user. Enter, and now all I have to do is just re-log in into your session, and this should work.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the popular scripting language of DevOps? A. Java, B. Python, C. HTML, D. C++. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So if I do a docker ps now without sudo, you can see the command is running. Awesome. So what I want to do is I want to go inside the Dockerfile. Okay, and now I want to build this Dockerfile. So docker build dot -t new underscore Dockerfile. So you can see the Dockerfile is now being executed, and basically this is creating the container for me, and this will basically come up with an image which will have all the changes that we just told to the container. So now if I do a docker images, I can see that there is a new image which has been created, which is new underscore Dockerfile. So let us run this new underscore Dockerfile. Docker run -it-d. Also let us specify the port number. So let us open it at port 84, and then -d new underscore Dockerfile, and then hit enter. Okay, so the container is launched now. So if I do a docker ps, I can see that a container has been launched 7 seconds ago. Awesome. And it being opened on port 84. So let's check if everything is working well for us. So we just have to change this to 84, and you can see Apache is running. Awesome, Apache is running. And now let's check our web page if it's there in the container on route. So we named it as 1.html, and yes, so this is the HTML that we created, which has been added inside the container. So let me show you inside the container what exactly happened. Okay, so docker exec -it container name and then bash, and let me just clear the screen. Okay, and let me compare it with my Dockerfile. So the first thing that we did was apt-get update, apt-get -y install Apache 2. This basically installed Apache, so this was clear. Then we added everything from the current directory to where www.html, right? So if we go inside where and then www and then html and do an ls over there, you can see that the one.html file has been added, and at the same time Dockerfile was also added. So inside the directory we had these two files, right? One.html and Dockerfile. So both of these were added inside the container. Now to not have Dockerfile inside your container, what you can do is instead of dot, specify dot slash and one.html. That would solve this problem. It would only add one.html in the container. Okay, so it added one.html, and index.html is basically the default page of Apache that you see, right? So we added one.html, so this was added by the Dockerfile. At the same time, what we did again was we defined Apache to run in the foreground. So as you can see, we did not invoke the Apache service by going inside the container. We just went directly to the port number that we mapped the container to, and the Apache was up and running. So that is awesome. And the last thing that we did was we defined an environment variable. So what I can do is I can echo the variable, which is $name, and you can see this is the value of the variable that is specified in the Dockerfile. I specify the variable names to be Intellipaat, and if I specify echo $name, this is the value that I get automatically. So this was set by the Dockerfile in the container image that I just created. And now what I can do is I can just exit this container, and if I want you guys to use it, all I have to do is do a Docker push to this container on my Docker hub, and you guys will also be able to access this particular container. Alright, so for that I'll just have to change the name, do a Docker push, and you should be able to use it, but I'm sure you would not be needing it, because if you pass the same commands that are written over here, you would get the exact same container that I created. Alright, so let me know if you guys face any problems in the comment section, and we'll be happy to answer all the queries for you. Alright, moving forward, now we got to know how to create Docker files. We got to know how to build images from the Docker file automatically, kind of like a script kind of thing. Alright, so now let's start with our next topic, which is introduction to a Docker volume. So what is a Docker volume? So Docker volume is basically used to persist data across the lifetime of a container. For example, I demonstrated it to you guys that when you create a container, you make some changes in the file system, you delete the container and you launch it again, and the changes are not there anymore, right? So that can be fixed. So imagine it like this. For example, you're using Apache container and you have a website inside of it, and the container stops responding because of some reasons. What do, you delete the container and you launch it again, but with that what happens is your website content is also deleted. And if your website content is not present in this new container, it becomes a problem. So to solve these kind of problems, we came up with Docker volumes. So what Docker volumes does is it basically maps, or it basically hosts the storage outside of the container and maps it to inside the container. That is, the storage is there on the host system rather than on the container, rather than the files being written on the container itself. They are written outside the container, and that location is basically mapped inside the container. So irrespective of the fact whether the container is deleted or started again, the container which is being attached to that volume will have the same file system as that of the older container, and that is how this problem is solved, that is of persistence of data across the container lifecycle. Alright, so there are basically two ways to do it. one is called a bind mount and one is called a Docker volume. Now, what are the differences between a bind mount and a Docker volume? Let us see that. So basically a bind mount would be that, let me just come out of the directory. A bind mount would be that I mount a particular file location inside the container. Okay, for example, I created this Dockerfile directory, right? So what I can do is I can map this Dockerfile directory inside a container. Now to mount this particular Dockerfile folder inside my container, all I have to do is docker run -it, and then there's a flag called -v that I'll have to specify. Specify the location of the directory, which is /ubuntu/home/ubuntu/dockerfile. Now this is the location of my folder, and then what is the mount point of inside my container. So say I say it's /app, right? So I'll specify that, I'll specify -d, and then I'll specify Ubuntu. I'll hit enter, and my container is now launched. Now if I go inside this container, I will be able to see that there is a folder called /app which has been created, right? So if I go to app and if I do an ls, you can see the folder, the files inside this container are that of the Docker file. Now these files are not actually copied inside the container, but these are actually being mirrored from the directory on the host operating system. That is, if I duplicate this session, let me just duplicate this session. So I'll just go inside the directory Docker file, right? If I do an ls and say I touch a file, say 2.html, right? So if I do a ls in the container now, I can see that there is one more file 2.html, right? So it is inside the container. So whatever changes I make inside this directory will automatically or dynamically be available inside this container. Okay, the reason for that is that this directory is mapped to the directory /app in the container. All right, so this is called bind mount, but there's a disadvantage with this. The disadvantage is that a bind mount will only work when the file system is the same that you have specified, like over here in this container, right? For example, what can happen is I can specify this bind mount to be in the configuration of the container, and I can push it to Docker Hub. So anyone who is downloading this container will automatically have this bind mount on his operating system. But the problem which will arise is that, say you download this container on a Windows operating system, right? In the Windows operating system, this file path that I gave /home/ubuntu/dockerfile is not going to exist, and that is where it is going to give you an error and it will cause you a problem, right? So this way of persisting data is a little difficult, or is a little I'd say complex when it comes to different environment setups, when you're dealing with different environments. For example, if I have to talk about, say, a different operating system, say I want to work in CentOS, so in that the file structure would be a little different, right? For any other operating system, it will be a little different. For Windows, it is completely different, right? So a bind mount will not work in different environments, and that is where it has a disadvantage. But then this advantage is basically overcome by volumes. Now what are volumes? Volumes are basically entities, or are basically storage which is managed by Docker. Bind mounts are not managed by Docker, because you create the directory, you decide which directory your data is going to reside in, right? And inside that directory you are making the changes, and that is being reflected in the container. But if you create a volume, the Docker engine which has been installed on the host operating system automatically identifies where this volume has to exist, okay, and then creates that volume over there. Also, in bind mount, it is a little difficult to basically migrate the data. In volumes, it is very easy. You just take the volume up and then just put it on some other system and it will work. But in case of bind mount, you'll have to decide at which place you want to keep it and then bind that place to the container. Only in that case it will work, right? Let me show you what happens in case of a volume. Right. So in case of a volume, if you want to create a volume, this is the syntax. So the syntax is docker volume create and then name of the volume. So let me show you how you can create it. So let me just docker volume create and let us create a volume, say test. Okay. So this would create a volume called test, as you can see over there. Ignore the warning, guys. So this created a volume test, and if you want to see all the volumes which are present on your system, you can pass the command docker volume ls, and this would give you all the volumes which are present on your system. So on my system right now, only the test volume is present. I don't want to have to know where is it present because Docker manages the handling part of the file system itself. I don't have to worry about that. I just want to know that if there is a volume. So yes, there's a volume on my system which is called test. Awesome. All right. So the next thing that I have to do is basically I'll have to type this command docker run -it -mount. And so basically, if I were to give you the syntax, this is the syntax for mounting a volume. So docker run -it -mount source would be equal to the name of the volume. So in our case, the name of the volume is test. Then the target would be where do you want to mount it inside the container. So we want to mount it inside /app. Right, and then -d and then the image name. All right, so once the container is launched, now what we can do is we can go inside this container to check if everything is working fine, and we'll go inside app and do an ls. So there's nothing inside this volume as of now, right? So what we can do, we can create, say, touch, then one.html, and then touch 2.html. We can do all this, and then what we can do, we can also duplicate the session. Let me just duplicate the session, and what I'm going to do now is I'm going to launch one more container. Okay, so I'm going to launch docker run -it -mount and then say source is equal to test, and target could be some other folder as well, but for the sake of simplicity let's keep /app, and then -d and ubuntu. This would launch one more container, right? Let's go inside this container, docker exec -it, this, and then bash. Okay, let's go inside app. If I do an ls, you can see that whatever changes I'm making in this volume is also being reflected in this container. So say I create 3.html over here. If I go here and do an ls, I can see the 3.html as well. Alright, so this volume is basically being shared between two containers. Even a bind mount can be shared between two or more containers. A volume can be shared between two or more containers. But in case of volume, you do not have to worry where your volume is being stored. It is automatically handled by the Docker engine. Okay. The other cool thing over here is that if you delete this container and launch it again, it'll all be the container, or your end user will not even realize if anything changed. For that, let me give you an example. So let me just exit this container, and we created a image called new_Dockerfile. Okay, so what I'm gonna do is I'm gonna launch docker run -it, and then source say is equal to let me create one more volume, docker volume create, and let us create a volume for Apache. Okay. Now what I'm going to do is I'm going to launch docker run -it and then -- mount. Source would be Apache. Now look at this closely, you will get the difference. So source is Apache, and what I want to do is I want to target this particular directory var www and then html. So whatever would be inside this directory will automatically come inside the volume. Okay, so I don't have to add anything into the volume, and I'll show you how to do that. So you specify this -d new underscore Dockerfile. This was our image name, and let us hit enter. So it created the container. Let's go inside this docker exec -it and then this container and then bash. Okay, so we are inside the container now. Now if I go to cd var www html and do an ls, you can see the files are still here, but these files are also now mounted on the volume, and that is evident over here. So if I exit this container and if I launch a new container with the mount as Apache and target would be say /app and the image is this. Okay, so this is the Ubuntu image, right? So it should not have the files inside it, but if I go inside this container now, can you see the files over here are same as what was there inside this container var/www/html. Okay, now the beauty is this, guys, that if I come out, say I create a 2.html over here, right? So what I do is I come out of this directory, okay, and what I do is I create nano do.html. I create a file and then I specify that html body h1. This is the new html file. Close the header, close the body, close the html, come out. Okay, now I want to copy this tool.html inside this container. So what I will do, I'll do a docker cp /2.html and then /var/www/html and then the container id. /var/www/html. Okay, so now 2.html is present inside the container. Okay, now what I will do, I'll just delete the container. I'll delete the new underscore Dockerfile container, docker rm-f, delete. Okay, so ideally if I now launch a new docker run -it -mount, source is equal to Apache, target is equal to /var/www/html. Okay, and -p also we specify that we want 81 port to be exposed, and -d and then the image name new underscore Dockerfile. So what will happen now is this, that if I go on the browser, if I go to port 81, the container is running. If I go to 2.html, you can see that the new file is also there in this container, that is new underscore Dockerfile. So it does not matter if your container has the file or not. If you have mounted the volume and that volume at some point had that file inside it will have it inside this container as well. Okay, originally inside this image you don't have the 2.html, right? And let me prove that to you as well. So if I do not mount the volume and I launch this container, right? So if I go to this IP address and but on page 82 you can see the container is up and running. If I go to 2.html, it will say 2.html was not found on this server. Reason being, the volume is not attached to this server. This file only has 1.html that we wrote using the Docker file, right? For volume, we have it in attached in the container which is mapped to port 81, and that has the file 2.html, which is this. So awesome guys, we have successfully understood what Docker volumes are, and I'm sure that you guys have also understood. If there are any doubts guys, you can mention it in the comment box and we'll be more than happy to help you out with your doubt. Alright, so with that guys, now we come to the next topic of our session, which is how are microservices relevant, right? So till now we have seen how we can deploy a single container and do things with it. But usually in a production grade environment, we have multiple Docker containers which are working with each other. Now, why do we have that? Let us understand that using this topic. So first, let's understand what is a monolithic application. So guys, a monolithic application is an application which has everything inside one particular program, right? For example, let us take the scenario of an Uber app. So our Uber app has things like notification, we have things like mail, payments, location services, customer service, and passenger management. This is there inside one app, right? You can see all of these things inside one app. So if you can see it inside one app, that does not necessarily mean that it is actually one program of Uber that they have written, right? But for now, let's consider everything is under one program. When I say one program, probably you have written a Java file, or you have written a C file, and everything is there in that C file, or everything is there in the project in different files. Basically, everything is there on one server, is what I mean, right? So if that is the scenario, what will happen? That if I want to change code in notifications, I will have to pull the whole code base. I have to pull the whole code base. I will have to go to the notifications file. I have to change the code over there, and then I have to push the whole code again back to GitHub, which will basically get deployed on production after being tested and everything, right? But the problem over here is that if there is any problem in the notifications code that I just changed, it will have a repercussion on all the components of my app, right? There could be that I did a mistake and probably there is something wrong with the mail program now. Although my intention was not to touch the mail program, but because I had to work with the code base which had everything, probably something went wrong over here, or something went wrong over here, or something went wrong over here. So this was a problem with a monolithic application. That is that you had to submit the whole code base even if you had to change the minimist thing that is there in the code, right? And this also led to downtime, because when you are changing the code base, there will be a certain amount of downtime that will occur. And there is also a lot of risk, because like I said, the other files of the same project could be impacted. For example, in our case, I said that if notifications, or say if location services is not working, probably it will have an effect on payments, or it will have an effect on mail if the code is related to each other, or if a function is being called from each other, etc., etc. That is how a normal a program is. In one file you define a function, in the second file you're basically calling that function. That happens, right? So all of these are dependent on each other, and whenever the components, whenever the module, so all of these small things like notifications, mail, payments, passenger management, customers, or these are all small modules of a program. If these modules are interdependent to each other, it will be called a monolithic application, right? But when we talk about the disadvantages of a monolithic application, they are the following. So like I said, if the application is large and complex, it will be very difficult to understand. So if your Uber app is now having more and more features, and if someone has to add a new feature, he first has to understand all the dependencies between the components, right? He has to understand the whole code base, and then only he can add a feature as to understanding what will be the repercussions, or what all files he or her has to handle if he's going to put a code inside the code base, right? So it is a little difficult to understand. Second thing is, the whole application is redeployed. So like I said, the whole code is again deployed, and then there will be a certain amount of downtime which will be pertained to you updating the application, right? The third thing is, if there is bug in any of the module, and because in a monolithic application everything is dependent on each other, it can lead to an entire downtime of your whole application, right? It can bring down your entire application just because of a bug in a single module. So this is also a problem in monolithic application, because the components are dependent on each other. And the last one being, it has a barrier to adopting new technologies. And this basically means, say your notification code is in Java, and your and your passenger data program, because it's a monolithic application, also has to be in Java. All of your modules that you're defining, all of the features that you have defined, have to be in one particular language. That is what a monolithic application means, right? So there was a restriction to adopting new technologies as well. So it could not be like one module of mine is written in some other language, the other module is written in some other language. This was what a monolithic application was. Now, to solve this, we came up with a microservices architecture. Now, what is a microservices architecture? Each and every module, that is a customer services function, or the notifications function, or the mail function, the payments function, passenger management function, location services function, they're all segregated from each other. They all exist independently. That is, they're not dependent on each other. So if they have to interact, obviously they'll have to interact with each other. For example, in Uber, until and unless you don't make the payment, you will not be allowed to book a cab, right? So still communication has to be there between these two components. That is, the payment and the booking has to be communicating with each other. But now they don't have to communicate through in between the program. They can communicate through uh, probably HTTP ways, or by hitting the API of each other. They can do that by probably sending JSON to each other and stuff like that. So they can communicate in that way. They don't have to communicate from within the program. And that is the beauty of microservices, that the services that we are defining now are not dependent on each other. For example, say if the notifications is not working, the notifications module is not working, then in that case, it's not like your Uber app will go down. Probably in that case, it will say our notifications is having some problems, but you can still book a cab. You'll still be able to book a cab, because booking of cab is no way related to notifications. But if we compare it to a monolithic application, in that case, because the code was dependent, and if there was something wrong in the notifications app, the whole application could come down, right? Because the code was not isolated to their member functions or to the member modules. But now, because each and every function of the application can exist on a different server altogether.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous delivery and monitoring. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
The downtime of the application becomes almost zero when we have to update a feature. For example, if a developer has to update a feature in, say, the payments app, for example, he has to add a new payment method, he will only download the code base for the payments app, make the changes over there, update the code on the payments module, and if there are any problems, there will be problems only to the payments module. The other services will not be affected. Okay, and this is what microservices are. Now, you might be wondering that this is a Docker session. Why and how are these microservices related to Docker? So to answer that question, these applications, all these microservices are deployed on Docker containers. Okay, so all these act as separate entities, and these containers then interact with each other. And now this also solves the problem of barrier of adopting of new technologies. Reason being, your containers could be of different technologies. For example, your customer service could be written in Python, your notifications could be written in Java. But if your customer service and notifications programs have to interact with each other, they can interact through JSON. JSON is a way of writing a file, just like we have CSVs wherein values are separated by commas. In JSON you have a structure, right? Any kind of program, be it any language, can convert a file into JSON, probably using libraries or having inbuilt functions for that, right? And then pass it on to the other service which has to read the information. So with microservices, our problem of barrier restriction, of technology restriction was also solved. So the advantages would be, because the application is distributed, can be understood really well. It is not like if a developer has to work on a particular feature, he has to understand all the features of the application. He should know which application should he, or which modules of the program should that particular program that he is developing communicate to, and that's all. That all he has to know, and of course the code of his own function as well, right? And of course, if he makes any changes and if he makes any bugs also in the program, it will not affect the whole application. It will probably affect only that function which he is creating. Okay, I guess we have covered all the advantages. So the first one being easy to understand, then the code which has to change will only be changed for the microservices which has to be worked on. Then the bug in one service will not get into all the components of the application. It will only be isolated to that particular function. And of course, you can use any technology that you want with the microservice that you are working with. Okay, and all of this is possible using containerization. Okay, now because we were talking about deploying multiple containers, we have to talk about how to deploy them using Docker Compose. Now, if we were to deploy multiple containers, till what we have learned so far, the only way to do this is by either using Docker run, or probably creating a script file which will build multiple Docker files and then hence build those images. But there is even a shorter way to basically build images and run them, and that is possible using Docker Compose. Now, what is Docker Compose? Docker Compose is basically a tool which can be used with Docker to create multiple containers at once, create and configure multiple creators at once with a single command, right? And the way you can do that is by writing a YAML file, right? So you write a YAML file with all the configuration required for the containers. And of course, I'm talking about containers, that is more than one containers. You can have 100 containers also that you can launch with one single command using the Docker Compose file. Okay, and this Docker Compose file is written using a YAML format. Now we are working with us. Now, if I want to demonstrate the power of Docker Compose to you, I can do that using a sample Docker file that I have created. So this sample Docker file, what will it do? It will basically deploy a WordPress website. Now, a WordPress website has a lot of dependencies, guys. It has to has MySQL in the backend. It has to have the WordPress container in the front end, And of course, you'll have to configure the DB password and everything inside the container as well, right? Now, one way of doing it is doing manually, that installing WordPress and then configuring the variables inside it, and then doing the same with MySQL. But there's a shorter way to do that, and that way is using Docker Compose. Now, this Docker Compose file has actually been written in YAML file. So if I were to take you through it, the version of the Docker Compose file is version 3.3. And there are basically two kinds of containers that we are launching. The first kind of container is the DB container, and the second type of container is the WordPress container. Okay, so the first we launched DB container, and the image that we're trying to pull for the DB container is MySQL 5.7. Okay, in the MySQL 5.7 container, we are defining a volume which is DB underscore data, and this is the target of the inside the container where it should be mounted. That is var live MySQL. Okay, so the environment variables for this container are MySQL root password, that is MySQL data, MySQL user, MySQL password. These are the values to these environment variables that we are also configuring inside the Docker Compose file itself, right? So inside this container, these are the environment values which will be configured. And then, so this is the end of it. This is what we have done in the DB container. Now we are talking about the WordPress container, in which we specify that it depends on DB, which this will basically create a link between the WordPress container and the MySQL container or the DB container, right? And with this, the WordPress container will be able to communicate with the DB container. Then we specified the image of the container that we want to download. So it's WordPress, and that to the latest version. The ports that we want to expose. So inside the container, the WordPress is available on port 80, and we are mapping it on the host with port 8000. Okay, and then the environment variables we specify that the WordPress DB host is DB:3306. So DB is basically the host name for this service that just got created, which has MySQL inside of it, and MySQL is always available on 3306 port number. So that we specify over here. Then we have the WordPress DB user. So we specified the DB user, that is the MySQL database user, as WordPress. So that is exactly the same value that we're specifying over here. And the DB password is again WordPress, and that is also that we specified over here. Okay, and what else? So this is it. And after that, we specify that the volume which has to be created is DB data. So this is for the whole YAML file. That there's a volume which is being created, which is called DB data. Now this is a YAML file which will create two containers, which will configure it, and then this will happen in like 3 seconds, right? So let us go ahead and try this sample Docker file out. But before that, Docker Compose, guys, actually has to be installed on the system, irrespective of the fact whether you have installed Docker or not, right? So Docker, when you install, it does not install Docker Compose automatically, except the users who have installed it on Windows and Mac using Docker Toolbox. If you installed using Docker Toolbox, it has everything installed. But if you have installed it on Linux and you have just installed docker.io, it will just install the community edition version and the Docker Swarm. Docker Compose is not installed by default. Now to install Docker Compose, all you have to do is, let me first demonstrate it to you that Docker Compose is not present. So Docker Compose --version. So you can see it is not there as of now. So what I can do, I can go to my browser. I will search for install Docker Compose, and the first link is basically the official link. Alright, so for installing it on Linux, just click on Linux, and these are the commands for installing Compose. So first we'll copy this command, that is, we'll have to curl.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now, let's continue with the session.
The file, so the file has been curled now, and then we'll have to change the permissions for the file which has just been downloaded to be converted into an executable file, and that's it. And now if I run docker compose version, I can see that the Docker Compose version is 1.23.1 and the build is this. So Docker Compose has been installed automatically. Now the next step is to basically create a YAML file. So for that, let us create a YAML file so let me first create a directory. So it would be compose. Let's get inside compose. And now let's create a YAML file for WordPress dot YAML. Okay, and if you basically this WordPress compose file is available on Docker Docs, so you can directly go here and you can try this YAML file on your own as well. Just copy this YAML file, paste it into your YAML file that you are creating, and then save it. Just let's verify if everything has copied correctly. So yes, it has. And now finally save this YAML file and then pass the command. Okay, so there's one more thing that I want you to know, but that will be evident from the error, which is that the Docker Compose file has to be named a proper has to have a proper name. For example, if I pass the command docker compose for basically running your Docker Compose YAML file, the command is docker compose up and then -d. You pass it, and then it'll give you an error, can't find a suitable configuration file in this directory, right? So it says that file can only be of this name, docker compose.yaml or docker compose.yaml, right? So what we're going to do, we'll just name it the same. So I'll just rename the file to be docker compose.yaml. Okay, so the file has now been renamed, and now let's pass the command docker compose up -d. I'll hit enter, and as you can see, everything has started automatically, and it is pulling the containers as of now. Once it has pulled the containers, it will start configuring the container. So db container has been completed. Now it is downloading the WordPress container, and then it will configure it. And once the configuration has been done, yes, so it's done. So our WordPress website is now up, and all we have to do is go to the EC2 dashboard, go to the running instances. So these are the instances that we launched. This is my instance. I'll just copy the IP address, and WordPress would be available on port 8000. Hit enter, and here you go. So website is up and running, and if I go on continue, I'll just have to specify the value. So let's keep the site title as Intellipaat, username as Intellipaat as well, password would be Intel123, and then your email, so it would let it be something random, intellipaat@intellipaat.com, and we'll click on install WordPress, login, and then username or password. So let us specify it as the same that we give, right? And now if it logs in, that basically means that it is being able to communicate with the database as well, right? So your WordPress website is all up and running. It is now configured with your MySQL database, and that is how it is interacting. And this is your dashboard. this is basically from your WordPress container. Your data is all being stored on the MySQL container, and this is a classic case of a multi-tier app that you have just launched on Docker Compose. So if I do a Docker PS, you can easily see that this is the WordPress container which is running, right? And it is being exposed on port 8000. And then you have this MySQL container which is running, which is being exposed on port 3306, on which this WordPress container is being able to interact. Alright, so guys, this was how you can launch multiple containers at once using Docker Compose, and this is also kind of like a microservice, although this can be further be broken down, but those broken down services can also be launched through Docker Compose, and everything can be configured in the Docker Compose YAML file itself. Alright, but again, microservices are actually not launched through Docker Compose. They are basically put on something called as a container orchestration tool. So what is exactly a container orchestration tool? Right? So a container orchestration tool is when you have multiple containers that you have launched and you want to monitor their health as well. For example, if I come back to this example that we just did, what I'll do, I'll just docker rm -f and I'll specify the container ID. I'll hit enter. The container is removed, right? And now when I go over here and if I hit enter, it'll say the site can't be reached. If I hit enter again, it'll again say the same thing because your site is gone. You accidentally removed your container, or your container stopped working because of some reason, and now you're not able to access your container. Your website is down, it's gone. This was a problem which was there with traditional methods of using containers or microservices on Docker. But then there was something called as container orchestration, which became very popular, which basically says that all your containers health will be monitored by Docker itself. So if there is a container which goes down, if there is a container which is not healthy anymore, what Docker Swarm does is it automatically repairs it by stopping the container and launching a new one in place of it, and the end user will not even realize what happened. All right, so this automation led to what we today known as container orchestration. Now there are a lot of container orchestration tools. With Docker, pre-packaged comes Docker Swarm. So we're going to discuss Docker Swarm now. So what is Docker Swarm? So it's basically a clustering and scheduling tool which is used for container orchestration of Docker containers. And with Docker Swarm, you get the functionality of automatically monitoring the health of containers, and it helps you keep a healthy number of containers that you have specified always in the running state. That is the basic aim of having a Docker Swarm up and running. Now, how does a Docker Swarm basically work? So a Docker Swarm basically works like this. So a Docker Swarm cannot work with just one machine. All right. So because like containers, even machines can be faulty sometimes. Maybe you have configured Docker Swarm on a single machine, which can automatically repair containers. But what happens if the machine goes down? Right? So to mitigate those kind of things as well, we came up with distributed kind of an architecture wherein you have multiple machines running in the swarm. So in the swarm there will be one machine which will be called as the leader, which will basically tell the workers what to do, and the workers will have the containers running on them, right? So you have the leader like we have it over here, and then you have multiple workers which are running on the cluster, and these workers will run the containers that we want to launch. So this was about Docker Swarm, but this is not it. Let's go ahead and start a container, or let us go ahead and start a cluster using Docker Swarm. So let us see how we can do that. So for that, let's go ahead and first launch a machine on AWS. So we have the master. Let us launch a worker. So for that, let us launch an Ubuntu system. Okay, so now our Ubuntu system is now launching. Let's name this instance as a worker. Okay. So while this is launching, you'll have to do some steps on your leader. So say this is the instance that I want to become the leader for my Docker Swarm cluster. So what I'll have to do, I'll have to say Docker Swarm init, and then I'll have to specify the advertise address. So advertise address is basically the private IP address of the instance. So in my case, the instance is, this is the private IP of my instance, right? So I'll have to specify this over here, and then I'll hit enter. So with this, you will get this command: swarm is initialized, current node is this, and it is now a manager. So manager is nothing but a leader. Okay, and for any node which has to join to this manager, they'll have to pass this command, that is docker swarm join, and then this command that they'll have to pass. So for this, so basically I'll have to log into this particular worker of mine to install Docker first, and then we'll go ahead and join it to the cluster. So let us connect to our worker, and let me make the font a little bigger so that you can also see what I'm typing. Okay, great. So this is my instance. Now what I'll have to do, I'll have to first install Docker. So let me do an update first. So Docker is updated. Now let me, the machine is updated. Now let me install Docker. So sudo apt get install docker.io. Alright, so Docker is installed. Let us verify that by typing sudo docker version. Great, so Docker is installed. Now Swarm is automatically installed when you install Docker. So all you have to do now is go here, copy this command, and paste it over here, right? And also while we are doing that, I'll have to open the ports for these instances to interact with each other. So let me put all traffic over here, and now my instances should be able to interact. So I'll just pass the command here and hit enter. Alright, so I've figured out what the problem was. The problem was I've not specified the address correctly. So my master is basically on this IP address. So let me copy that and let me pass the command again. Now this is the command that we get. Let us copy this. Let us paste it over here. Hit enter, and you can see then it says this node joined as a swarm worker. Alright, awesome. Now if I go here and I do a docker node ls, you can see that there I have two nodes which are there. This is my current node, which is the leader, and it's in the ready state, and so is the second node, which is also in the ready state and is joined the swarm. So this is how you can create a Docker Swarm cluster, guys. So again, to be very clear, the first thing that you'll have to do is do a Docker Swarm init on the master node. Then you'll get a command. Just pass that command on the worker, and your worker will directly connect to your master. Now, if you want to leave the cluster, all you have to do is say sudo docker swarm leave, and you can see it will say node left the swarm. And if you do a docker node ls on the master, it will In a few moments, when the health checkup has failed, it will say the status is down for this particular node. Okay, if you want even the master to leave the swarm, all you have to do is pass the command docker swarm leave on the master as well. Now, as you can see over here, this node, because it has left, the status is now down, which basically means that the node is no longer reachable. Okay, now if you want the master to also leave the swarm cluster, all you have to do is say docker swarm leave and then say hyphen force, keep enter, and it'll say node left the swarm, and your swarm cluster has now been left. Okay, so this is how you can go ahead and create a docker swarm cluster. And the command, like I said, is docker swarm init advertise address equal to IP address of leader. Specify that, hit enter, and just copy this command on the worker and it'll work like a charm. Alright, so our next step is now to deploy an app on the Docker Swarm. So before that, let me quickly launch the Swarm cluster again. Docker Swarm init advertise address and specify the IP address of the master, which is this. So this is the IP address. So specify that, hit enter, and then copy this command and pass it on the worker. Okay, and if I do a docker node ls over here, you can see the cluster is ready. Awesome. Now what I want to do, I want to deploy an app on Docker Swarm, but before that we'll have to understand how does an application actually work on Docker Swarm. So an application works something like this. So basically you create services on Docker Swarm, and that service will basically create containers for you for that particular image that you have specified, right? So alright, so let's go ahead and create a service. So guys, this is the syntax for creating a service in Docker Swarm. What we'll have to do is we'll have to type in docker service create and then specify the name of the service. Say I want the name of the service to be Apache, and then specify the number of replicas that we want to run. So say I want to run 5 replicas, and then the port mapping. So basically I want it to be launched on port 83, right? And then the name of the image. So say I'm launching it on hshar/web app. Okay, I hit enter. It'll run 5 containers. It'll verify if everything is running fine, and once everything is running great, it'll exit. So now,
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the popular scripting language of DevOps? A. Java, B. Python, C. HTML, D. C++. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
if you want to see what all services are running on your Swarm cluster, all you have to do is say docker swarm service ls, docker service ls, and it will show you that this is the service which is running. It is running in the mode replicated, right? And it has 5 to 5 replicas running, and this is the image name. Now I'll show you a very awesome thing. So basically this port is 83 is exposed, right? So what I'll do, I'll go to the master's IP address, which is this. I'll go here, I'll type this, I'll go to port 83. Alright, this is working. Now what I'll do, I will go here, I will go to the worker, I will again go to the worker's IP address, and I will go to port 83. Awesome, isn't it? So basically in Swarm, any IP address either of the master or of the worker that you go on, they will have the application ready on both the servers on port 83. And the most awesome thing is that I showed you guys that if I do a Docker PS over here, I can see that there are out of 5 containers, there are 2 containers which are running on the leader, and there should be 2 containers running over here on the worker. So there are 3 containers running over here. So what I can do is I will basically just do a sudo docker rm-f, and what I'll do, I'll remove all the containers. Removed. And if I go to my master's IP address again and hit enter, I still have the containers running over here, right? Similarly, if I go here sudo docker rm-f, and then I say I want to remove everything. I forgot the sudo over here. It removed 3 containers, but if I go to my web browser and refresh the worker's IP address, I still have the container running over here, right? This basically means that my containers are being auto scaled, which means if they get deleted, it again gets created. So you can see I deleted the containers over here, but if I do a docker ps again, can you see it has 3 containers now launched? And I guess if you go on the worker and do a ps over here, now it should have 2 containers, exactly as we saw, right? So it automatically creates the containers again, and it will always maintain the number of replicas to be 5, because that is what you have specified, right? That is what it will always retain. Now you can always scale the replicas, and for that all you have to do is docker service scale apache, and then just specify the number of replicas that you want. Say I want only 2 replicas to be there. I'll hit enter, and then what it'll do, it will basically scale down to only 2 replicas. Now if I do a service ps docker service ls, you can see there are only 2 replicas running now. So if I do a docker ps here, I have 1 container over here, and if I do a docker ps here, I have 1 container running over here. Alright, so you can also scale up and scale. I can also scale up, right? So I can again just go over here and type in the command 10. It'll start 10 containers for that web app, right? And you can verify that. You can verify if I do a sudo docker ps over here, it has around 5 containers here, and if I do a docker ps here, it has around 5 containers here. If you want to remove a service, if you want to remove an application from the cluster, all you have to do is docker service rm and then specify the name of the service, and it will remove that service. And now if I do a docker ps, it should slowly remove everything out of here. So it's docker ps again. Slowly it will remove everything from the containers. So see, the containers are gone over here, and similarly if I see here, the containers are also gone over here as well. Okay, and again, like I told you guys, if you want to leave the node, all you have to say is do sudo docker swarm leave. This node has left the swarm, it will say. And similarly, if I want to leave the master as well, all I have to say is docker swarm leave, and on the master you'll always have to force, and it'll leave the swarm as well, and then you'll have a clean machine again. All right, so this is how you can deploy an application on Docker Swarm. All right,
Puppet is nothing but a configuration management tool which is open source in nature, right? And it helps us in basically keeping configurations consistent with what we require and what is there on our production, on our test, and our developer environments. Right now, the awesome thing about Puppet is that it can basically be installed on various platforms like Microsoft Windows, various Linux platforms, etc. Right, so it is very versatile. in terms of its working on different platforms, and also it basically does not use any programming language. It has its own declarative format in which you have to specify what basically if you want to install any type of or any set of configuration on any node or any group of nodes, the way to declare that is not dependent on any programming language. So Puppet has its own declarative language using which you can describe what kind of configurations you want on your slave nodes. Okay, so this is what Puppet is all about. Now there are some key features of Puppet which we are going to discuss next. So what makes Puppet so special? Why is Puppet so popular? So the first and foremost reason that companies adopt Puppet is because a lot of other companies have also adopted Puppet, and basically it is a tried and tested tool which helps every company in its configuration management needs. Right, so Puppet has established itself in providing the configuration management needs, and therefore companies who are newly coming up and are trying to adopt configuration management, they prefer Puppet because a lot of other companies are also using it. The second point is that there is a lot of, Puppet being an open source tool, there's a very big community for Puppet which constantly keeps working on Puppet and keeps on adding features, keeps on resolving bugs, which makes the Puppet tool in itself very mature, right? Why mature? Because if there is a tool which is privately owned by a company, obviously the kind of work which will happen on that tool versus what is happening on Puppet, it's going to be slow. Reason being, there are a lot of people who are working on Puppet. There are a lot of people who are enthusiasts, right? Who are not being paid. They're just doing it because they love, working on, or they love their profession and they love working on this tool, which is Puppet, right? And out of that love, they create features, they resolve bugs. So the quality of features and the quality that this tool has to offer is more than what a private company can produce, right? So therefore, this is a key feature of Puppet, that there's a large open source community for Puppet, which basically keeps on adding features, keeps on resolving bugs, and keeps the Puppet software in its most optimal state, right? The third thing is documentation. So documentation is very important for anyone who is trying to learn this tool, and there is an extensive documentation available for Puppet on their official website, right? So if you don't understand Puppet, you don't have to take help from your colleague, you don't have to search for tutorials. Just go to the Puppet online website and they have an extensive documentation on literally anything that you want to do with the Puppet software. Okay? And the fourth thing, which we have already discussed but is very crucial for its success, is platform support. Right? So Puppet can be used on Unix based systems, it can be used on Mac OS, it can be used on Microsoft Windows, it can be used anywhere. And because of this versatility of it being installed anywhere, it is very popular among companies where the fleet of servers are on different platforms, right? Their web server could be on CentOS, their DB servers could be on Ubuntu, so on and so forth. You could have multiple environments or multiple platforms in your company which are basically serving different purposes, but Puppet as a software can be installed on all of them, and your configuration management need is solved because of that, right? So these were some of the key features of Puppet, why Puppet is so popular, right? So now enough of bragging about why Puppet is so great. In our next session, we're going to start with the core part of Puppet, right, which is the Puppet architecture. So before dwelling into how Puppet actually works, or getting our hands onto the Puppet software, we're going to look at how the Puppet architecture basically works, or how Puppet internally works, with this slide which talks about the master and the slave. So the core part of the architecture of Puppet is the master-slave architecture. So there is one master and there could be numerous slaves which are being served by the master, right? So what happens basically, because Puppet is a pull configuration type of configuration management tool, so everything is initialized by the slave, right? So the way Puppet works is, so first the slave basically sends its state to the master, right? So when the master slave architecture is set up and everything is set, if there is any change on the master or if there is no change on the master also, the slave of Puppet, it time and again sends its state information to the master. And what master does is it checks whether the state sent by the slave is what is required from the slave or not, right? So there is a state for that particular slave which is defined on the master, right? So it checks against a state defined on the master whether the state is same or not. If the state is not same, if there is a change in the state, what master does is it sends the change catalog to their slave and tells the slave, okay, so these are the softwares and these are the versions that you have to install on yourself, right? So the Puppet agent then installs all these tools on itself or on the Puppet slave. And once it installs everything, it sends back a report to the master saying that, everything has been installed. Please check whether your requirements are now being met with my state or my metadata, which I'm sending it to you, right? So in the third and final step, master checks whether all the state is matching with what the requirements have been specified in its manifests, right? So this is a 3-step working of how the Puppet master and slave interact when there is a change which is supposed to happen on the slave. Similarly, now because there's a lot of communication or there's a lot of back and forth which happens between the Puppet master and Puppet slave, the communication which happens between these nodes is encrypted. And it is encrypted using SSL certificates, right? So there's an SSL connection which is established between the Puppet master and the Puppet slave. And the way it works is something like this, right? Now for SSL connection, we need certificates, right? So the first thing which happens is, because Puppet being a pull configuration type of tool, the Puppet slave first requests for the master certificate from the Puppet master, right? And which in turn the Puppet master, it sends the certificate back to the Puppet slave. So this happens instantaneously. Any slave which asks the Puppet master about its certificate, the master sends its certificate to the slave. But this is not where the connection has been established. Now what happens is, the moment master sends its certificate to slave, master also requests for the slave certificate, right? It requests the slave node to give master the certificate, and the slave obliges for this request and sends the slave certificate to the master, right? But still at this point, the communication has not been established, although the certificates have been exchanged, right? Now for the master to authenticate the slave, there is a manual step of signing the certificate that the Puppet slave is sending to the master, right? And in this step, basically the administrator or the DevOps engineer will go to the Puppet master and he shall sign the certificates of the nodes which basically he wants to attach to the Puppet master, right? Once the Puppet master signs the certificates of the slave, only then a secure connection is established, right? An encrypted connection is established, and then the exchange of data takes place. So this is how the SSL connection is basically set up between Puppet master and Puppet slave, and this will be more clear to you when we'll be setting up Puppet, which is basically our next session, where we'll be setting up a Puppet master and a Puppet slave on AWS, and we'll try to establish connection between them, and then I'll show you how you guys can basically sign certificates on Puppet master so that the connection becomes encrypted. So in this session, we're going to start with setting up Puppet master slave on the AWS management console. All right, so let's go ahead and start with this session. So I'll quickly jump on to my AWS management console. So guys, here is my AWS management console. The first thing that I'll do is I'll have to launch an instance, right? So I'll select the Ubuntu AMI, Ubuntu 18.04. I'll select this. I'll select the t2.micro, which falls under the free tier. I'll click on next. I'll select the number of instances as 2 because I want to create one node Puppet master server setup. So I'll mention the number of instances as 2. I'll click on next, add storage, and then I'll come to security group, right? So in the security group, what you have to do is you will have to have a security group which basically will allow TCP connection, all TCP connections from the IP address of your slave, right? Either you can do this, or what you can do is you can allow a TCP connection on the port 8140 from your this particular IP address, which is of the slave, if you want to be more specific, right? But for now, what I'm going to do is I'm going to open all TCP ports and I'll say it can come from anywhere, and I'll click on review and launch. The moment you click on launch, you will be asked to specify the private key that you want to use. So I have one private key already there on my system, so I've specified that. Now basically your instances are getting launched. So let's label these instances as master, and the next one would become slave. Okay, so we've specified this. And now while they are launching, let's have a look at all the commands that we're going to use to basically install my Puppet master and slave. So guys, these are all the commands. So these commands will basically run on my master, and then these commands will run on my Puppet agent, right? And in the end, we are also going to verify if our master and agent connection is successful by basically creating a file from the master on the agent with this particular content. So don't worry about it. We'll come to this part and I'll explain you what this file basically means when we get to this part of having the file ready on our system. Okay, so for now, let's start with the master. Let's start installing master. So let's see if our instances are ready. So yes, they are in the running state. So let's connect to our master first. So this is the master IP address. I'll connect through putty, specify the private key. Now this will basically let me enter my master server. So let me just change the font settings so it becomes more clear for you. And let me choose a color for the master as well, so that we don't get confused between the master and the slave. So this is my master server. All right, so while I connect to my slave, let me just update this machine. So while this machine is getting updated, what I can do is I can connect to my slave. So this is my slave, guys. Let's connect to it using putty. So this is my IP address. Let's specify the private key as well. And now we are connected to our slave as well. Awesome. Let's change the font setting for this. Let's make it a little bigger so that you guys can also see this. All right. So now we are on our slave machine. Let's update this machine as well. All right. So meanwhile, our master is now updated. Now let's go back to our notepad to see what we have to do next. So we have to install wget first. So wget is pre-installed on AWS. We don't have to do this. Next step is basically to download this particular file. Let's do that using wget on the master. So the file is downloaded, and now let's unzip the file using this command. So the file is unzipped. Now let's install Puppet master here. So we are installing Puppet master. Puppet master is now being installed. Once it's successfully installed, we can check the installation status by going to the policy. So Puppet master is nearly installed now. And now let's check the content of the policy. So yes, Puppet master has been successfully installed. And now what I can do is I can check the status of the Puppet master service. So this is the service status. So it is active and running. So that's awesome. So that's what we wanted. So our Puppet master is now installed on our system. Next thing is to basically fine tune some settings. So let's do that. So we'll edit this file, which basically are the defaults for our Puppet master for running. Right, here we are. So basically your Puppet master by default would use 1 GB of memory, but since our system is also 1 GB, what we are going to do, we are going to mention that the Puppet master can only use 512 MB of the memory. So Puppet master can work in a 512 MB memory as well if you are dealing with less number of nodes. So since this particular setup is for our demo purpose, so we can mention 512 MB for our Puppet master, which should be enough. So we'll save the file, and now the defaults are ready. And now for applying the defaults, we'll just restart the Puppet master over here. So Puppet master is now restarted, and now we'll open port 8140 through which basically Puppet communicates with the slave. through the firewall of the OS as well. So that's done and we're set. So Puppet Master is successfully set now. Let's go to our slave and start setting up our slave as well. So on a slave, we have updated the machine. wcat is pre-installed. We'll first download this particular file. So the file is downloaded. Let's unzip the file. The file has been unzipped. Now let's install Puppet. So earlier we installed Puppet Master. Over here we're installing Puppet, which is nothing but Puppet Agent, right? So once Puppet Agent is installed, I have to manually start it, and we can do that using this command. But before writing this command, what we have to do is we have to go to each machine and change the host file, right? So in the host file, I have to mention the IP address of the master. So we'll have to do this for both the machines. So let's specify the IP address like this, and let's specify the master's IP address in the master as well, and in the slave as well too. So we'll do a sudo nano /etc/host, specify the IP address, write Puppet in front of it, and save the file. Alright, so now we are ready to start the Puppet agent. So let's do that. So Puppet agent has now been started. Let's enable Puppet as well, which basically means on restart also, Puppet will be started automatically. So this is done as well. Alright, so now some steps happened in the background which we were not able to see. What were those steps? So that was basically what we discussed in yesterday's class. So the moment Puppet slave starts, it basically sends a request for the master certificate. How does the Puppet slave know where the master is? We just specify the IP address in the host file, right? So it knows where the Puppet master is. So it sends the request to the master. The master in turn sends the master certificate, and at the same time it also requests for the slave certificate. So this when the master requests for the slave certificate, the Puppet slave basically sends the slave certificate, and now we have to go to Puppet master basically. So we are here, we'll say sudo puppet cert list, right? So this should basically list any certificates which have been sent to the master. So let's check if we have any. So as you can see, we have a request from the Puppet slave on the master. So how do we know it's the Puppet slave? You see this IP address 172.31.44.167, and if we compare it with our slave, it's 172.31.44.167, right? So that's the slave's certificate which has been sent to the master. So we'll have to sign it now. So for that, the command is sign. And if there are more than one certificate or more than 2 or 3 certificates and you want to sign them all you have to do is sudo puppet sign and then -- all. Specify this and your certificate is now signed, right? So my Puppet master and Puppet slave can now interact with each other. So our next step is to verify this. So what we are going to do is we're going to come back over here, and now basically we are going to create a manifest. Now, what is a manifest? A manifest basically specifies what all changes have to be made on the agent or on the slave, and these are the changes that we are going to do. So basically we are creating a file which exists in this particular directory, right? So the Puppet master has to ensure that this file is present on this directory, and the permissions, the read-write permissions of this file is this, which is the user should be able to read-write and the other users of the OS should be able to read this particular file. Okay, and what should be the content of this file? The content should basically be it works on and then the IP address of the slave. All right, so this IP address is going to change with every machine on which this file is going to exist. So this is going to be the content. So let's create this particular file. So for that, first I'll have to create a path on the master. So this is my master. Let's create a path. Path is created. Now let's edit the manifest file on the master. So this is the manifest file, and the content of the file should be this. Let's copy it, paste it over here, save the file, and once the file has been saved, all you have to do is restart Puppet master. So I'll restart Puppet Master like this. So my Puppet Master has now been restarted, and all I have to do is go to the Puppet, and since Puppet is a full configuration tool, the slave has to request for the changes. So I'll say puppet sudo puppet agent hyphen test, right? So before I run this command, I want to show you guys that basically there is no file inside temp which starts with I. So I'll go inside temp, and if I do an ls over here, you can see there's no file called it works. So now what we're going to do, I'm going to say sudo puppet agent hyphen test. So this command will basically ask the master for the is there any changes required for this particular server. The master will send the changes to the agent. The agent will make those changes and send the report back to the master. So I'll hit enter now, and now you can see that there has been some things which have been done, and you can see a file has been created in /temp. Let's verify this. So let's do an ls now. So I can see a file has been created, it works. And if I do a cat on this file, I can see the contents of this file is it works on, and then the IP address of the slave, which is this, right? So congratulations guys, your Puppet Master slave setup is now complete, right? So now you can use the Puppet Master slave to basically do configuration management. So you just have to specify the configuration on the master, and then it will be applied on the slave. Or the code basics for Puppet, which will enable you to basically get started in Puppet and start your own configuration management projects. All right, so without wasting any time, let's go ahead and start with this session. All right, so the most basic or the unit of coding in Puppet is basically a resource. So what is a resource? A resource could be a file, it could be a command, it could be a package, it could be anything, right? So this is the basic thing that you define in a Puppet catalog, which basically has to be executed or placed on the agents, right? And the way to define a resource is like this. So basically first you define the resource type. So like I said, it could be a package, it could be a file, it could be anything, right? And then you define the resource name. Okay, for example, if it's a file, you'll specify the path over here. If it's a package, you'll specify the package name over here, and then you specify the attributes, whether it has to be installed, whether it has to be present there, whether it does not have to be present there, what is the permissions of the file. So all that can be declared in the attribute and the value, and then you close the brackets, which basically means that this particular resource has been finished, this particular resource has been defined. Now don't worry if you get scared, don't worry if you are basically getting scared with the syntax. So let me go ahead and show you an example which will clear things out more than what we are understanding over here. So guys, this is a sample syntax for a resource. So over here we have basically defined a package. So say you want to install Nginx on agent, all you have to do is define this resource. So what is Nginx? Nginx is basically a package. So the resource type goes package, the package name is Nginx. And what do we want with Nginx? We basically want to ensure that it is installed on the system on which we are targeting on, right? So this is how you define a resource in Puppet, and through this you can basically configure your agent's configurations using the resources. So basically whatever resources you mention gets installed on the agent. All right, moving forward now guys, when you combine a bunch of resources, now of course when you're dealing with an agent, it's not just one resource that you will install. You could be installing hundreds or thousands of resources together, right? So all these resources combined, they have to be one entity, otherwise you'll have to define each and every resource separately, probably in a separate file. So to solve that problem, what we do is we come up with something called as manifests. So what are manifests? Manifests are nothing but a combination, or they basically group resources together, and they are defined inside one file, and that file is called the manifest file. Okay, so the manifest file can have multiple resources inside them, and once a manifest file is basically applied on an agent or on a slave, all those resources are installed one by one.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now let's continue with the session.
Alright, with this guys, let's go ahead and start by creating our first manifest in Puppet, right? So what we're going to do is, let me jump onto my master. So guys, this is my master. Now the first thing that I want to do is I want to create a manifest so that basically if I want to install say Apache on my agent, how would I do that? So what I can do is I will go inside cd/etc/puppet. Here you go.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous delivery and monitoring. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
And now inside this directory you will have something called as code, right? So you'll have to go inside code, then there will be something called as environment. We'll go inside environment. Let me just do an ls over here. Okay, so we have to create a folder called environment. We do not have a folder called environment by default. So what we can do is you can create a path. So I'll do a sudo mkdir -p and let me specify the path now. So I want the environment folder, and inside the environment folder I want a folder called production. Now inside production I would need a folder called manifests, and inside manifests I will have to create a file. Alright, so let's first create this path. So this path is now created. Let's go inside this path. So we'll go inside environments, inside production, and inside manifests. Okay, so now we will create a file called site.pp. So let's do that. So what I'll do is I'll type in nano site.pp. Okay, and I'll hit enter. So this has to be backed up by a sudo nano site.pp. Awesome. Now the first thing that I would do is I'll have to specify the node. So right now we are not getting into which node we have to specify here. So we'll just specify node is default. That means that any agent who is basically requesting the master for an update, whatever we are going to write over here is going to be applied on that agent automatically. Okay, so what we first want to do is say we want to install Nginx. Okay, so I'll say package. So first I have to specify the resource type. This I specified, and then I'll specify the resource name. So this is the package name Nginx. I've specified that, followed by a colon. Then I specify the attribute. So the attribute is ensure, which should be equal to installed, right? Followed by a comma, and now I'll close the package. That's it. So this is one resource that we have defined inside a manifest. Now let us define one more resource. So what basically I want to do is I also want to create a file, and the file should exist in /tmp, and the file name should be say status.txt, right? So again it will be followed by a colon. Then I'll specify the attribute. Now the attribute for a file would be, the first thing that I would say is content. What should be inside that file? So inside that file there should be a text which says Nginx installed. Okay, followed by the mode, which would basically specify the permissions of this file. So say I want the permissions to be 0644 followed by a comma. Okay, so everything seems fine till over here. So what I'll do now, I'll do a control X, Y, enter. So my file site.pp is now saved inside the manifest folder, which exists inside the environment production. Okay, so this is done. Now what I'll do, I'll go to any of my slaves. So let's go to slave 1. This is my slave 1, guys. So what I'll do, I'll just type in puppet agent hyphen test, right? And I'll specify it with a sudo. So let's hit enter. Okay, so we'll have to specify hyphen test, and we'll hit enter. And now it says applied catalog in 0.01 seconds. All right, so let's check if we have the TMP file over here, which should have a status file. So the status file is not there. Okay, I think the name of the folder should be manifest. Let's check that. All right, so I think, guys, I got the problem. The folder name has to be environments. Okay, so if you look over here, all right, so let's try this. So let's try to change this folder name. So for that, I'll have to come out, again come out, and now let's just copy this folder, cp-r, let's call it sudo, change the environment folder to environments, and let's move it so that it gets renamed itself. So let's do a cp here. Okay, that's done. And now let's just remove environment. Done. So if I go inside environments now, let's just check if everything is there. So production is there, manifest is there, and site.pp is there. So let's try to do a test again. So it says there is an syntax error at the end of the site.pp file. Let's check what syntax error are we dealing with. So it's a good thing that we're getting a new error now. So I'll do a sudo nano on site.pp, and okay, so here's the problem, guys. We didn't close the bracket. So let's close it, save the file, come back over here again, and do a puppet agent test. So now I think we are progressing. Okay, so the catalog has been applied, and now let's check if the software was indeed installed or not. So how we can check that? We can basically just go to our EC2 management console. We did this on slave 1 test, right? And let's just go over here and paste this IP address. So yes, Nginx has been installed on slave 2 automatically. Again, if we want to check, so what we can do is we also wanted a file, right? So what we'll do, we'll do a cat on /temp with the status. So yes, status.txt file also has been created, and if you do a cat on that, it says Nginx is installed. Awesome, guys. So we have successfully implemented one manifest on your slave, which has basically installed Nginx, and it has created a file on the agent itself as well, right? So congratulations, guys, on your first manifest. Let's see what is next in our slides. All right, so we've basically created a manifest. Let's go ahead and see the different things we can do with the manifest, right? So there are 3 components of manifest. Basically, we can call these components, which can be used inside manifest for greater functionality. The first component would be variables, right? So you can use variables inside a manifest file to basically store values and then pass them on to the body, or you can basically create variables inside any or at any place inside the manifest, and then that variable can be called inside any resource, right? So let's try and check this. So if you can see of the example over here, the example says that it creates a variable called $text and it saves the value hello world inside it, and then it creates a file, right? And the content, it says hello world over here, but basically what we're going to do is instead of this, we are just going to put $text. Let's see what happens. So if I go to my terminal, so this is my master. So let me just change the site.pp. So what I'll do, I'll create, so like the slide says, you can create the variable anywhere. So what I'm going to do is I'm going to create a variable called text, and let's say the text says Intellipaat DevOps Course. Okay, let's say it says this, and the content would basically be changed, and the content would go something like this. It will be $text. Okay, let's try to save it, and let's go to our slave one, and let's see if we can do something with it. So what I'm gonna do is I'm gonna try and do the test again. So sudo puppet agent hyphen test. Let's hit enter. All right, so something happened. Let's check. So cat/tmp, the file name would be same, status.txt. Let's see what it says now. So as you can see, the text has changed to Intellipaat DevOps Course, and this basically value was taken from the variable. As you can clearly see that I defined the text inside the variable, and that variable was called over here, and this content was basically added to status.txt, and this is exactly what we wanted. Awesome. So you have seen how variables work, but now let's make it a little more interesting. So let's talk about loops, right? So what are loops? So whenever you want to run something iteratively without having the need to write the code again and again, that's basically the main use of loops, right? Now, how can you use loops in manifest is something like this. So say you want to install multiple packages inside your slave, right? Say I want to install Nginx and I want to install MySQL Server. So how can I do that? Now, in order to do that, what I'll do is in my variable, I'll basically create an array. So basically I've created an array which contains two values. One is Nginx and one is MySQL Server, right? And then inside the packages, what I've done, while I'm naming the package, I've basically called the variable $package, and then I've ensured that these packages are installed, right? So let's try this code out. So what I'm going to do is let me switch to my terminal, and this is my master, guys. So let us remove some code from over here, and this is what we want to deal with. So what I'm going to do is I'm going to create a variable called packages, and let's give the values inside packages. The first value that I want to give is, say, Nginx is installed on slave 1. Let's try to install Apache 2, right? And let's try to install MySQL Server. Okay, so I'm gonna show you guys that if you see right now inside my slave 1, if I check, do I have Apache 2 installed to service, Apache 2 status, you can see it says the Apache 2 service could not be found. So once we run this test, let's see what happens, right? So first I want Nginx to be removed. So what I can do is sudo apt get purge Nginx. So I'll just remove it manually from over here, and then this should remove Nginx. Yes, so Nginx has been removed. So I can just verify that by going over here and refreshing on the IP address. Let me just see if the service is also down. Service Nginx status. Service is running, so let's stop the service. So service Nginx stop. So we'll have to add a sudo. Yes, so Nginx service is now stopped. So if I refresh it, I can see that the website says the site can't be reached. Awesome, this is what we wanted. Now what we are going to do is I'm installing Apache 2 and I'm installing MySQL Server on my agent. So I have specified the site.pp on the master. And now let me go to my slave 1. So this is my slave 1, guys. And what I'm going to do now is I'm going to test. So sudo puppet agent -- test. I'll hit enter. And now it's basically applying the catalog. So my Apache, so first let's check if Apache is installed. So if I go to the browser and if I hit refresh, let's see what happens. Okay, so it still says it can't be reached. So let's check where the problem is. So if I do a service Apache 2 status, it says the Apache 2 service could not be found. That could basically mean that probably there's some problem in my site.pp. Okay, so here it is. Here is the problem. So I did not change the value of the packages over here. So I'll just have to specify packages and I'll have to save the catalog, and that's it. If I come back here, if I again do a Puppet agent test, let's see what happens now. Alright, so Apache 2 has been installed, and as you can see in the browser, it automatically refreshed, and now you can see the Apache page. It is now installing MySQL Server, so let's wait for it to install MySQL Server as well. Okay, so MySQL Server is also created. Awesome. So Apache 2 service is now installed, so we can also check it on the browser, on the terminal. Service Apache 2 status, and you can see Apache is now running on this slave. Similarly, if I want to check service MySQL Server status, so MySQL D status, I'm not sure what the name of the service is. Service MySQL status. Yes. So MySQL service is also active and it's running. So we successfully installed two packages, two softwares on this machine using loops in manifests. All right. So let's come back to our slides. So we are done with variables. We're done with loops. Now let's go ahead and understand what are conditions. Alright, so now let's discuss conditions. So conditions are basically statements which helps us to take a decision based on a particular output. For example, over here we say we are basically making use of the keyword only if, right? So only if this command is successful, only then it will basically run this particular command, which is Apache 2 is installed, right? Otherwise it will not run this particular command. And what this command is basically doing, this command is basically putting this text which is Apache 2 is installed inside this particular text file, which is /tmp/status.txt. okay, so this command says only if this particular command goes true, it should execute this particular command, right? And what is this command doing? This is basically saying, is Apache 2 present or not? So if Apache 2 is present, it will return something on the command line, otherwise it will not. So only if command ensures that if this command goes successful, this will return a code which is 0, and only if the code returned 0 is seen by this command, only then it will run this particular command which is written over here, right? If this returns the value false or 1, in that case this command will not run. So let's try this out. So let me go to my master terminal. So let's clear the screen first. So sudo nano init and sudo nano site.pp. all right, so what I want to do is I want to execute a command. So let's do that. So let's remove everything first. Okay, so basically I want to define a resource called exec, which basically deals in passing commands to the agent. So I want to do exec, and I want to name this thing as, say, conditions, right? I want to name it something. Let us name it like this. So conditions. And what I want to do is I want to pass a command which basically says that /bin/echo. Say we are checking if Apache is present or not. So we'll say Apache 2 is installed. So we'll say this, and this has to go inside /tmp/status_apache.txt. This will go over there. So this command should run only if the command the command would be /bin/which Apache 2, and only if this command is successful, it should run this particular command, right? So, and now we'll just close the resource, and that's it. Let's save the file, and now let's come to our slave, which is this. Let us try to run the test. So sudo puppet agent -test. This basically has now created a file. So let's see if the file has been created or not. cd/tmp/status So we don't have a file over here. So let's see status underscore. Okay, so let us go inside TMP first and then do an ls. So I can see status underscore Apache file is present. So I'll just cat it status underscore apache.txt. So it says Apache 2 is installed. Reason being over here do have Apache installed. But let us go to another slave which I have connected to my master. Let's see if we have Apache 2 over here. So service Apache 2 status. So Apache 2 is installed over here. Reason being, okay, so it has been a lot of time. So this basically, because Apache 2 manifest was present on the master, this slave also requested master for the manifest or for any change, and the master told this slave to install Apache 2 and all that. No worries. So what I'm gonna do is I'm gonna sudo apt get and I'm gonna purge Apache 2. Okay, so this will uninstall Apache 2. And now if I do a sudo service Apache 2 status, so it says Apache service is not found. Now what I'll do a sudo puppet agent -- test. So in this case there should be no file which should be created. Okay, so if I hit enter now, let's see what happens. So it says executed successfully. Now let's check what just happened. So I'll go inside /tmp. I'll do an ls over here. It has a file called status underscore Apache. Let's check that. So status underscore Apache. What we can do is probably this could have been created earlier. Let us remove this file first. Status underscore Apache we have removed. We'll have to add a sudo here. So it's removed now, right? Let me just check if this command actually works or not. So /bin/which Apache 2. So it is running service Apache 2 status. That's not there. So we'll have to remove this particular file. So we can do that. So sudo rm /user /sbin/apache 2. Either we can do this or, okay, let's first do this and then we can probably try something else as well. So user sbin/apache 2. Okay, so now if I do /bin/which Apache 2, yes, it's not returning anything now. So what I'll do is I'll just do an ls here. Okay, so my status file is not present, and now I'll do a sudo puppet agent --test. I'll hit enter. Alright, so the catalog has been applied. Now let's check inside tmp file. So cdtmp, we are inside, and now let's check by doing an ll, or let me do an ls. Okay, so we don't have the status underscore Apache file over here. Now it can be present over here. All I have to do is change the content. So we just learned about only if, right? Now let's learn about unless. So what unless means is until and unless this file or this command is not sending me 1 or is not false or is not executing properly, till then do not run this command. The moment it does not or is not successful, run this command. Okay, so now what we will do is, because our Apache 2 is not present on slave 2, I can just change this to unless, right? And I can say Apache 2 is not installed. And now in this case, what will happen is if I go to my slave 2, I'll just do a puppet agent test again. And in this case, it should create a file inside the temp folder. So if I do an ls, it has the status underscore Apache file. Let's do a cat on that. And it says Apache 2 is not installed. So basically we just made use of unless. So again, just for revision, what we just saw, unless basically deals with a command which it is waiting to become false. The moment that command becomes false, it will run this command. It will run this particular command which has been specified. Whereas the opposite of this is only if. Only if waits for this command to be successful, and only if this command is successful, this command will run. Unless this command is successful, this command will not run. Okay, so you can remember it like this. So with this, guys, we end the topic of basic coding in Puppet with the first slide, which will basically tell us what Ansible is. So Ansible, like Puppet, is just another configuration management tool. And what is configuration management? As we have already learned, it's nothing but installing softwares on multiple systems. For example, if you have a fleet of 150 or 200 servers and you want to do a particular software install on all those servers, if you do that manually, that will take a lot of time, right? And for that, we needed something which could automate the installation of softwares on multiple systems. And the way forward was configuration management. Right? And now what happens is any software that you want to install, you can do that on a single click of a button on all the servers which exist in your fleet using the master slave configuration, where on your master you would have the Ansible or Puppet master installed, and then on the slaves you just have to specify on which machine what to install, and everything will be done automatically. Right? This basically solves two things. The first thing is that the softwares which were installed, they were taking a lot of time if it were done manually, and now with Ansible or Puppet in the picture, where everything is happening automatically, it does not take that much time. Second thing is there is no room for error because everything happens automatically. Right? So if there was any error which could be committed while installing softwares, that is not the case now because everything is automated. So that is why, you know, configuration management as a concept became so popular, and that is why so many tools have been developed. And we have basically learned Puppet, and today we're going to learn Ansible, which yet again just solves the configuration management problem. Right? Now, some few facts about Ansible. So it was written by a person called Michael Dehan, right? And the name Ansible actually came from a fictional novel which was written by Ursula K. Le Guin in 1966, right? That's like 50 years before this novel was written. And there was a communication device in this novel, right? And the name of that configuration device was Ansible. So it is the name Ansible has been taken from there by Michael Dehan, right? And again, this software was acquired in the year 2015 by Red Hat. So now any updates or any features that are added to the software would basically be directed by the Red Hat company. But in its true nature, right now as well, Ansible software is open source and anybody can download it for free. Anybody can make changes to it because it is open source, right? So guys, as we discussed, that Ansible Playbook is the core part of what Ansible does in its day-to-day activity, right? So whatever you write inside the Ansible Playbook is actually executed on all the servers which are basically connected to the Ansible server. All right. Now, how do you write the Ansible playbooks? You write it in the YAML language, which is YAML int markup language, right? And this is the full form for that. And as we move along, I'm going to show you guys how you can start writing an Ansible playbook, right? So guys, Ansible playbook, let's focus on the word playbook first. Like, what is a playbook? A playbook means a book of plays, right? So a playbook essentially should have a lot of plays. So guys, you have the first level in the tree of playbook comes a play, right? And you can have multiple plays inside a playbook. Now, what is a play? A play is a combination of tasks that you want to do on a particular host, right? So you define a play, and inside the play you define the tasks that has to be done, and each task has something called as module. It has something called as notify. It has something called as handler, and a lot of other things as well.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the popular scripting language of DevOps? A. Java, B. Python, C. HTML, D. C++. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
right? We will discuss these things in detail when we'll be talking about Ansible roles. For now, let's just focus on the word playbook. So like I said, playbooks has a lot of plays and each play has a lot of tasks, right? Now let us see how we can define a play in a playbook. So guys, in a play, you can have 2 or 3 tasks or 4 tasks or 10 tasks or any number of tasks written, and these tasks are executed on a particular host using a particular condition, right? And that's why it's called a play. What has to be played on a host? This is one play that is being played, which is it is executing a command in host 1 and then it is also executing a script in host 1. This is just an example, although we will be doing this in this session, but let us take an example that these are the 2 tasks which have to be done on a particular host. So they can be combined inside one play and then they can be executed. Similarly, if I want to execute a script on host 2 and install Nginx on host 2, this would become play 2. Okay. Now, how do you write, or how would this particular playbook look like on screen? This is how it will look like. Okay, now out of these, which are plays, what are plays and what are tasks? Let's look at that one by one, right? So guys, this particular block of code is one play wherein you have defined the hosts, right? So whenever you define the host, you start with a new line wherein you are defining the host. That becomes the starting of your second play. Okay, now the next thing is inside a play you have tasks. So as you can see, you have tasks over here, and the first task that we have is execute command date. This is the descriptive name of the task, right? So this does not get executed. This could be any string that you want to give, right? Second thing is you'll have to pass the command. Now what command has to be executed on the terminal? That same exact command you have to mention here. Okay, then the second name is execute script on server, right? So what is the script that you want to run? test_script.sh. This is the script that I want to run. So in this, I have 2 tasks. One is execute command date. The next task is execute script on server. Every task will start with a name and has to be followed by a hyphen. Okay, hyphen marks the beginning of a new task. You specify the name of that task and then you specify how that task will be executed. All right. For example, in this case, there should be a command which is being executed. In the next case, there should be a script which has to be executed. The syntax will remain like this, right? Now, whenever you're starting a new play, in that case also you have to begin with a hyphen. You specify the host name, that is this, hosts : and then host 1. Then whether that particular command or whether that particular play has to use sudo, we mentioned that. So if you want to use sudo in these commands, all you have to do is type in sudo : and then say yes. Okay, then you give the name of the play. So the name of the play, it could be anything. Like I said, it's just a string. You can pass in anything over here. And once you've specified all these info, you start with the tasks, right? So this is play 1, guys. Similarly, now if you have to write play 2, I'll have to begin with hosts again, which I've done over here. Now where I want to run these, run this particular play, I want to run it on host 2. What is the name that I want to give this play? I am calling it play 2. Do I want the sudo to run? Yes, I want the sudo to run. Then what are the tasks that I'm executing in this play? I want to execute script on server. This is the name. It could be anything. And then I specify the script which has to run on that particular host. Then I want to install a particular package. So I'll say the name of the task is install Nginx, and the task that I have to do is installation. So that's why apt is written over here. So when you're dealing with Ubuntu systems, you'll have to type in apt over here. If you're dealing with CentOS or Amazon Linux, the command over here would be yum. Okay, so apt : and then the package name, which is Nginx, that I want to install, and the state is latest. So over here you basically specify the version that you want to install. So I want to install the latest version. So this is how you write a play. Now let us summarize what we just discussed. So we missed out on this thing that we always start a YAML file with 3 hyphens, right? So any time when you're starting with a YAML file, specify these 3 hyphens and only then begin with your playbook. So I start with specifying these 3 hyphens. Next thing I do is that I have to create a play. So for creating a play, I'll have to start with a hyphen. And the next thing that I'll have to specify are hosts, right? And the name that you're specifying for the hosts over here has to exactly match with the /etc/ansible hosts file. So whatever IP address you have mapped to the host name over there, right? That host name only you will be using over here. You cannot use some other host name. Okay. Once you have specified that, the next step was to specify the tasks. So each play is like a dictionary and has name, host, tasks, and the order doesn't matter, right? So you have the name, you have the hosts, you have the tasks. So it becomes a dictionary. So it has all these information, each play. And once you define that and execute that, then it executes according to what is asked inside that particular play. All right. So when you're writing a playbook, that becomes a list of dictionaries. So if this is one dictionary where you have hosts, name, and tasks, and this is some other dictionary where you have the separate version of host, name, and tasks, when you combine them together inside a playbook, it become a list of dictionary. Okay. So again, seeing what tasks are nothing but they are basically commands that we want or tasks or I can say things that we want to do on the remote server from the Ansible master. Those are termed as tasks. Then the next step would be to basically creating a playbook. How can we create a playbook? So first, let me just move on to my Ansible master. So guys, this is my Ansible master. What I want to do is I'll create a directory called Ansible. Okay. So this is my directory. Now I'll go inside Ansible. This is my Ansible directory, guys. Now the first thing that I'll do is I'll create a playbook. Okay. So let's create a playbook called sudo nano play.yaml. Okay. This is my playbook. Now I want to create a playbook wherein I will be installing the Apache software on my host 1, which I defined in my host file. Now how can I do that? The first step that you have to do in creating an Ansible playbook is define these 3 hyphens. Once you have done that, now you have to start with a play. How can you create a play? Start with a hyphen and specify the hosts. So I want to do this particular play on host 1. Okay. Then do I want sudo? Yes, I want sudo. The name of this play, let's call it play 1. Okay. And now let's specify the tasks. Okay. Now inside the task, guys, the first thing that you would do is you'll have to define a task. So let's name the task something. So let's call it install Apache. Okay. Let's call it this. Then what I'm going to do is I'm going to give the package name apt, and let's say the so if you want to see the syntax for that, the syntax is actually available here. So apt, and then you specify the name of the package that you want to install. So the name would be Apache 2 and the state is going to be latest. Okay, this is all you have to do when you're creating a play. All right, let's start by this. Let's see if this is working or not. So my play is now ready, right? Let's check if I can ping my host 1. So Ansible -m ping host 1. So it says could not match supplied host pattern. Okay, so I think that's because the name is slave 1. Yes, so the name is slave 1. So let's change that in our YAML file as well. So sudo nano play.yaml and the host name is slave 1. Okay. Now let's try to run this playbook. Now how can I run this playbook? Type in Ansible -playbook space play.yaml. Once you specify this playbook will start executing. Now before I execute this playbook, guys, let me quickly show you on my management console that if I go to slave 1 right now and if I go to this IP address, nothing is visible over here, right? It says the site can't be reached. Okay, now let me come back to my master. I'll execute this playbook. So now it is installing Apache. It will take some time, guys, because software installations take some time. So you can expect around 15 to 20 seconds it will take to basically install or do this particular task.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now let's continue with the session.
And once this task is done, what I can do is, so as you can see, it says task, the change has been successfully done, and OK is equal to 2, change is equal to 1, and nothing has been failed. Now if I want to do this, all I have to do is come back here, refresh it, and as you can see, the Apache software is now successfully installed on my slave 1. Awesome. So I have successfully done something on a remote system, right, which is this. So now what I'm going to do is, let me just uninstall Apache, sudo apt get purge Apache 2. I'll just uninstall the package, and I'll tell you why I'm doing that. So my package is being uninstalled. Now if I do a refresh here, you can see I'll again not be able to reach to this particular server. Now what I want to do is, I want to add one more host to my Ansible cluster. So let us do that. Let us launch an instance. It has to be an Ubuntu instance, and the processor is t2.micro. Security group, I'll select an existing one. Review and launch. I'll launch it with my key pair, and now it's ready. Okay, so my server is being launched. Let's call it Ansible 3.1. Okay, and now if I go to my running instances, I can see that a new instance is now being launched. Now what is the IP address of this instance? It's this. So let's copy this and launch a putty terminal. Let's select the color to be white so that we can differentiate it easily. Okay, let's click on open, and now let's log into our instance. Alright, so I've successfully logged in. Now how do you add a host? All you have to do is update the machine, sudo apt get update, and the next step would be to install Python, sudo apt get install Python. Once this is done, I'll just have to go back to my master. I'll have to make the keyless SSH possible, and for that I'll have to do an cd into the SSH directory, and then I'll have to do a cat on id_rsa. Okay, this is the code that I'll be copying on my slave 2. Okay, so this is my slave 2, guys. Now I'll be going inside the SSH directory, and I'll be going inside the authorized key file, and now let's add this entry over here, save the file, and now let's try to SSH from over here. SSH ubuntu @ this is the IP address that I'm going to connect on, and yes, I'm able to log into my slave. So to verify, this is the IP address 172.31.29.34, and if I check it over here, it's 172.31.29.34. Awesome. So let us remove this. So let us exit the SSH connection, and now I'll have to add this host in the Ansible host file. So in order to do that, I'll have to do a nano on /etc/ansible/hosts. Okay, and now let's just scroll down and add one more slave over here with this name, Ansible_SSH_host is equal to this IP address that is of the slave. I'll add this, I'll save the file, and now if I do a Ansible-m ping all, I should get 2 servers ready over here. Okay, awesome. Now why did I do this? Alright, so now let us go to inside Ansible, right, and let's try to edit our playbook. Let's try to add one more play inside this. So I'll add a play, and let's say I am doing it for slave 2. Okay, I want sudo to be there. I want the name of the play should be play 2. Okay, the tasks that I want to execute are as follows. So the first of all, the name of the task would be to install, let's say I'm installing Apache on this system and I want to install Nginx on my slave 1. Okay, so let's change all the things accordingly. So I'm installing Nginx on my slave 1 now, and I'm installing Apache on my slave 2. Okay, so name is equal to Apache 2, state is equal to latest. Alright, seems cool. Now I will be executing this playbook and let's see how it goes. So basically with one command, what we are doing is we're installing software on 2 different systems, right? And the software that we're installing are also different, right? So this is the IP address for my slave 2. So as you can see, if I'm going to the IP address, I can't reach anywhere. Similarly, if I'm going to this IP address, I can't reach anywhere. Okay, now let's come back to our master. All right, now let me execute this command. So it is Ansible -playbook and then play.yaml. Okay, so let's execute this. So it is executing play 1. It is installing Nginx on my slave 1. All right, okay, so it has been done. Now we are executing play 2 and I'm installing Apache. So as you can clearly see right now, if I show you the browser, my server 1 is already ready and it says welcome to Nginx. Awesome. And my slave 2 is also done. So if I go here and if I refresh, I can see the Apache page. All right, so I've configured 2 different servers from my master, right, at the click of one button, right? I just executed one playbook which configured 2 servers of mine, installed 2 different softwares on it based on the name that I specified. All right, so awesome guys. I think we have almost begin. We are almost a beginner now with the playbooks. I'm sure you guys can also write your playbooks, but let's take it a notch up. Let's try to do something else as well. Now, if you have to execute scripts on remote system, how can you do that? Okay, so in order to do that, all you have to do is you'll have to create a script first in the same directory where your playbook is present. So I have my playbook present in this directory, that is Ansible, right? So in this, let me create a script. So let's say I create a script called hello.sh, and what I want to do in this particular script is I want to create a file. Let's call it let the content be hello world for that particular file, and I want to put it in /var/www/html. Okay, I want to put it over here. Let's see how it goes. So and the file name has to be 1.html. So in this case, what is going to happen is that I'm going to execute this on slave 2 where my Apache is basically installed, and that should basically create a website automatically. And if I go to this particular IP address and I go to /1.html, if I hit enter, it should basically show me the web page over here. Let's see how we can do that. So I've created this script, guys. So let's save the script, and now let's try to make it an executable file. So let me make it executable. So I'm just changing the permissions for this file, right? And this has to run in sudo. Alright, so my script is now ready. Now I'll go inside my playbook, guys. So I'll go to sudo nano play.yaml, and I want to do this task on my Apache server, right? So I'm inside my Apache play, and I'm adding a new task now, which is adding website. Okay, and what I want to do is I want to run that script. So I'll type in script : and what is the name of the script? hello.sh. That's all I have to do. Now let's save this play, and now let's try to run this play. So I'll do a Ansible -playbook, and I want to run this play. Okay, let's see how it goes. Nginx is installed. Okay, so on slave 1 everything was executed, everything is same. So it says okay = 2, changed equal to 0. On my slave 2 there's one file that got changed. Now let's try to do a refresh over here. Can you see? Automatically a website was created which is now called Hello World. Now let me show you one more awesome thing over here. Now I'm not going to any of those servers, right? This is my slave 2. I'm not going over here. I'm still on my master. Now what I can do is I can just simply change the script file. So if I change the script file to be, say, I'll go inside the script file. I change the text to hello world 12. Okay. Mind you, I'm not going to any other server. I'm just running the same command again. Right. Again, the commands will run. As you can see, it says on slave 2 there's one change. And if I refresh it now, can you see the website has changed automatically? Right. And this has changed without me going onto this server. And this is the power of configuration management, guys. Now imagine you have 100 servers and you have to change a file on all those 100 servers. How do you do that? It is impossible to do it manually. I'm saying it is impossible because time is of the essence when you're working in businesses, right? So you can do it using Ansible in this kind of way, right? Now let us come back to a slide, guys. So if I'll come back to my slide, all right. So now we created our first playbook. In this particular example also, they're basically running a command and then they are running a script. So we did similar thing, right? But when you're executing a command, basically you cannot see the output. That's why I changed this particular demo, but you can also try this demo also. So the syntax is clearly visible over here. You can just write the syntax in a YAML file and then try to execute it and see how it works for you. You can also create a demo for your own self as well and see how things work out. All right. So we created the first playbook using this particular command, and we created this shell file or the script file like this, right? And then we changed the permissions for that script file. Once everything was ready, we executed the Ansible playbook, and the script file was automatically taken up and shifted or basically copied to the slave that I want to execute it on, and then my playbook was basically executed. All right, so guys, this is how you create a playbook. So guys, software testing is basically used in the development practice since its inception. Whenever you work on something, there always have to be a QA on your work, right? And that is exactly what software testing is for, right? So software testing started off as a QA process, but then as and when the softwares became more and more complex, there were new problems that we had to face every day, right? For example, the time it used to take between, the development happening and then after that you testing the product, that time period used to be too long, and therefore there used to be some lapses in the release dates. If there was a release that was planned on a certain date, because of testing, because of back and forth between the development and the testing team, it used to take a lot of time, and hence the deadlines were not met, right? So these were some of the problems that were there in the software industry prior to software and testing becoming itself a domain and being so popular in the industry, right? So yeah, so there are basically two types of software testing in the industry where people work, right? So the first type of testing is automated testing, and the second type of testing is manual testing, right? I'm sure the name is clear itself about what testing is. So in automated testing, what happens is that you write code for your application to be tested on, right? For example, if you created a website and let's say you have to check the login functionality, what you will be basically doing is putting your email ID in the user text box and then putting your password in the password text box and then clicking on login, right? So after that, there'd be a screen which would basically say login successful or something like that. And basically, if this has to be tested, all you have to do is, if you think logically, we'll have to have a software which can enter the details in the username and the password, and then there has to be a software component which would basically click on the login button, and after that, login successful. If message is being displayed, that means the login functionality is working fine, right? So this is how we see it, that logically, if there was a software, these are the things that are supposed to be done. And if you can think logically for a process, or if you can define something using a process, using a sequence of steps, that can be done using automated testing. But there are always sides to a software which cannot be automated. Let's say you're doing a release feature, you're releasing a feature right now for which probably right now the automated tests are not developed. In those kind of scenarios, one opts for manual testing, right, where a person would sit down and would look at it from the UI perspective, from the UX perspective, also basically checking whether the functionality is working or not, right? So this is what manual testing was all about. Still today, manual testing is practiced in the scenarios which I just told you, where probably the test cases are not ready, or what happens sometimes is it is just not possible to automate a particular task, because let's say you cannot include it in a process. What cannot be included in a process? Let's say the output is always random, right? So if the output is random, you cannot tell a computer how to judge that output. So in those kind of scenarios, you need human interference, right? And for those human interference cases, you have manual testing, right? Automated testing, whenever you can create a test case using a process, for those kind of testing cases, we have automated testing. So these are the two types of software testing, guys. Moving forward, now we will be focusing our attention towards automated testing today, because since our topic of discussion is Selenium, and Selenium itself is an automated software testing tool, right? So we will be focusing our attention towards automated testing tools. Now, except Selenium, there are various automated testing tools out there in the market. You have something called as Appium, you have something called as Cucumber, you have something called as Test Studio, and there is Selenium itself as well, right? So why are we studying Selenium today? The reason for that is Selenium is most widely used in the industry right now, right? So if you're applying for DevOps job, most probably in your JD, you will find somewhere that, Selenium experience is a must, right? When you compare it with other tools such as Appium, Cucumber, Test Studio, although they are used in the industry, but they're not as prevalent as Selenium tool, right? And that is the reason we have tried to include Selenium as a part of your DevOps curriculum, because there are there is a more probability of you being asked whether you know Selenium or not when you're applying for a DevOps engineer profile than the other tools. All right. But if in the core essence you understand how testing works, I think it'll be very easy for you to migrate from one tool to another. In case you have to design automated test cases, but that will never be the case, because your profile, which is a DevOps engineer profile, you actually don't have to develop test cases. What you will be asked to do is design architectures wherein you will design the DevOps lifecycle. These test cases will actually be done by software testers, but as a DevOps engineer, you should have a background on what actually happens inside testing and how a particular tool works, so that when you're doing the automation, it is crystal clear to you the technical side of things as well as the architecture of side of things, right? Because you must have heard that whenever someone becomes a manager, it is essential for him to understand how the work is done by his subordinates, and only then he becomes a good manager, right? If you are a non-technical manager and if you're handling technical folks, chances are there'll be a lot of back and forth between you and your subordinates, right? So similar concept you can apply in learning Selenium today as well, that if you're a DevOps engineer, you should know how the tool works, so that if someone tells you that so and so thing is not possible, you can just go ahead and show them that this is the way it happens, right? And also this knowledge is also helpful while you're devising architectures. Moving forward, guys, now let's start off with Selenium. So guys, what is Selenium exactly? So Selenium is a portable framework for testing web applications. So Selenium provides a playback tool for authoring functional tests. Yes, so Selenium also gives you, let's say you're not that much into coding, and what you want to do is you want to perform a set of actions on the browser, and you automatically want them to be recorded in the background. So that is also possible using Selenium, but there has to be some extensions enabled, and using them you can also play back a certain action that you did on a website. For example, let's say I first go on Google, I search for a particular term, then I click on the first result, right? If I'm doing these actions and if these are being recorded, these basically automatically get converted in the background into code, and then once you play back what you have just done, it automatically runs that code and repeats all the actions that you have done in the browser itself, right? So this is, guys, what Selenium is. So to summarize, it's only used for web application testing. It also gives you the flexibility of not writing code, and you can just have a playback tool for yourself, wherein you'd be just doing the actions, and once you end that particular recording, you can play it back, and then all the steps that you did will be repeated. All right. So this is a gist of what Selenium is all about, guys. Now, Selenium was actually created by this guy, Jason Huggins, in the year 2004. But when it was created, it was actually something else. So what Jason Huggins was doing was he realized that he was creating an application and he was doing the same test again and again, right? So for his own application, what he did, he tried to create something of an automated testing tool kind of thing, wherein his application could automatically be giving the same inputs again and see what the outputs are, and hence he will know whether his code is working or not. Right, so he wrote a JavaScript program for that, and then that's how Selenium came out to be. So the JavaScript that he wrote, the name of that application was actually JavaScript Test Runner, and once it was donated to open source, it was later named as Selenium Core. Okay, now there were some limitations with Selenium Core, and we'll understand them as we move along. So guys, Selenium has these four components. As time progressed, these are the four components which came into Selenium, right? Because Selenium Core, like I said, it could not do the job alone. It had to have helpers. So we have something called as Selenium RC, we have something called as Selenium IDE, Selenium Grid, WebDriver. What are these components and what do they do? We'll understand it. Let's pick them one by one and understand what they're all about. So guys, Selenium RC was basically used because Selenium Core, when it was written, it had a disadvantage that it could only check websites which exist on the localhost domain. That means anything on any other domain, any website on any other domain, that could simply not be tested because of its limitation, right? So what was Selenium RC? Selenium RC was basically a proxy server. Now what does this proxy server do? It basically takes a website and it makes the Selenium core think that that website is actually on the local host, right? So this was the sole job of what Selenium RC was, and Selenium RC and Selenium core together were first named to be known as Selenium 1. Okay. After that, we got something called as Selenium IDE. So Selenium IDE was basically a Firefox extension in the beginning, which could do that playback feature of ours that we were just discussing a few moments back, right? So if you are not into writing code,
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous delivery and monitoring. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
what you can do is you can do some actions and then play back those actions using this particular tool, which was Selenium IDE. And this was devised by Shinya Kasatani from Japan. All right. So the intent of writing this particular program was to reduce the time that we take in creating test cases, because earlier it used to be hundreds and thousands lines of code for just creating the test. So it could basically mean if you're creating an application for a particular client, you're basically creating two applications in that case, one application for the client and one application for actually testing out that product. And sometimes it used to be that the size of your automated tests used to increase the size of your application, right? So for these kind of scenarios and the time which is also being invested in creating test cases, this guy created Selenium IDE. Now, the next component was Selenium Grid. Now, because there could be multiple parts of an application that have to be tested, right? To reduce the time taken by the automated test also was long. Why? Because there were so many components to be tested throughout an application once a release was done. So Selenium Grid basically gave us the power of running tests parallelly when basically you were trying to automate something, or when you were trying to test something automatically, right? So Selenium Grid was an application which could help us test multiple parts of an application on multiple machines, right? And this reduced the time of testing an application drastically, because earlier what was happening was everything was in a queue process. So the first component would be tested, then the second component that would be tested, then the third component would be testing. Everything was happening on one particular computer. But with Selenium Grid, if you want to test an application, your code has to reside in one place, and from that one place you can just hit the test button, and it will deploy the application on multiple machines with the different components that are to be tested. And accordingly, the different components modules will be put on them for testing. And once the results were done, or the once we got the results, they were aggregated and given back to the server from where the test was started, right? So this reduced the time of testing drastically. The next component was Selenium WebDriver. So Selenium WebDriver is the modern way of Selenium that we have, right? So the modern Selenium, it does not require a proxy server, right? It does not require you to have a queue system. If you want, you can put, or you can test applications on parallel computers. That is what the modern Selenium software is all about. It's all consolidated, right? So Selenium WebDriver was basically a consolidated software, which was a combination of IDE and RC. And the way it worked better was that earlier what we were doing was we were interacting with the website through JavaScript. Now, and as the time progressed, the websites and the JavaScript and the browser itself were becoming more and more restrictive. And therefore, more and more releases were required with every browser upgrade, or with every Java upgrade, that, now the earlier product of ours is failing. We'll have to try something else. We'll have to try something new. And that is when the WebDriver scene came in, wherein it said, okay, let's put everything behind and let's try to invent something new so that this problem is solved forever. So Selenium WebDriver, it directly communicates with your browser. So it's just like you communicating with your browser, clicking somewhere and doing stuff. Similarly, your Selenium software directly communicates with the browser. So there's no problem with JavaScript. There's no problem with the browser itself, because the browser will think a user is working. And nowadays, it's most of the browsers, they have they allow automated testing to be done, because that has now become a necessity for the software industry that we're living in, right? So whenever you would be running a Selenium test, you would see the browser giving you a notification that the browser is being controlled by an automated or an automation software, right? So now the browsers have allowed automation softwares to actually communicate with them. But the first interface which was created to basically interact with the browsers was through Selenium WebDriver. All right. Now, if you were to summarize how Selenium components came to be in the perfect shape and size that we use today, is like this: that earlier there were 4 components which were devised: Selenium Grid, Selenium ID, Selenium RC, and Selenium WebDriver. Then Selenium RC and WebDriver were merged, right? And it was made a consolidated software application where we need not rely on external tools for doing basically something which was a hack kind of a way, wherein, like, for example, we were creating a proxy server for the website that we had to test, so that the software could believe it's working on the local host. That's kind of a hack, right? But now with Selenium 2, when it came into the picture, when it combined RC and WebDriver's functionality together, it no longer seemed to be a hack. Probably in the backend, it's still happening in the same way. But as a user, I will not think, okay, so now I have to run Selenium RC so that this website will appear as localhost. No. So that all happens in the backend. You will not even realize what is happening. For you, it will be like you're running the test, the browser will open, and the test will be executed. Now it works like that. And once Selenium 2 was released, we saw, okay, so now Selenium is working fine for us. More features and more bug fixes were done. And then we have the Selenium 3 that we are actually using these days. So any company who's using Selenium for automation these days are working on Selenium 3. All right. Moving forward, guys. Now that we understand the history of Selenium and we understand, okay, so what all can Selenium do and what all Selenium cannot do, let us pause the technicalities of Selenium and let us understand what is Maven. So, guys, Maven is very important component of your development practices that are followed throughout the world. Right? Maven plays a very pivotal role. What role does it play? Let us understand that in the further slides. So guys, Maven is a build automation tool. So it helps you to build your software code, and it addresses two aspects of building software. First, it describes how a software is built, and the second, it describes its dependencies, right? So whenever you build a software, there are a lot of files, that are working with it to basically give you the complete application. Like in our case, we are using Selenium, right? So for using Selenium with Java, so from if you're a Java developer, you might know that in Eclipse you can run your normal programs as well. It's just not for Selenium. So if you want to run a Selenium program, you'll have to download all the Selenium driver files, right? You will have to download. You will also have to install Maven in Eclipse. So there are a lot of things, or there are a lot of softwares that you install in a particular application for it to work, correct? So there are two things that Maven does. The first thing that it does is it downloads all the dependencies required, right? So you don't have to download each and every dependency separately and then put in a program and check whether it's working or not. What you can basically do with Maven is you can put all the dependencies in a code file, and you can just feed it into there's a file in Maven which is called pom.xml. Okay, so in that pom.xml file you can list down all your dependencies and it'll automatically download it from the internet. So this is primarily why Maven is used. Second thing is it also helps you to build your software application. What do you mean by that? So you might have seen that whenever you try to run a program which is a finished program, let us take an example of setups. So when you have, if there is any software that you have to install, you get a setup file for that. In that setup file you have a lot of files which are combined together. Similarly, when you're using Selenium, if you see if you create a program in Selenium and if you see the project that basically, if you see the project folder, you'll find there are a lot of files in there, right? But if you actually see how Selenium tests are run, what you do get when you're running a Java Selenium file, you do get a jar file, right? The jar file is actually the final output of your automation project, right? So your automation project, let's say it has around 100 or 150 files. It'll be very difficult for you to keep track of all those files. So what you do is you build your software program, and in that what happens is you put all the files, you consolidate all the files inside one particular file which is self-sufficient to run. Okay, so in case of our Selenium project, what we'll be doing is we'll be exporting all our Selenium files, all its dependencies, all the code inside one file, one jar file, right? And that jar file can run on any system on which you have a runnable Java software installed, right? Whenever you have Java software installed, you'll be able to run that jar file. So Maven also helps you to build software files, and at the same time, it also helps you in dependency management. Okay, you'll understand more of it as you move along, as you move on to the hands-on part, where I'll show you guys that a project is actually empty. There's no Selenium files over there, and what we'll then do is we'll put a dependencies list in the pom.xml that Maven requires, and I'll just save the project, and you will see that it'll download all the files required in that project folder automatically. Okay, so that is primarily why Maven is so helpful. Okay, so some more information about Maven, that it downloads dependency for a software program. Basically whatever dependencies that you have to include in a program, you will be mentioning it in the pom.xml file. Once you have added the dependency in the pom.xml file, you just have to save the project and all your dependencies will be downloaded. All right, now that is all the information you need about Maven, guys, to get started with the hands-on. I think whatever information that I've given you is enough for you to now get started with how to create a Selenium project, or how to get started into creating your own test cases. Okay, so what the first thing that you have to do is you will have to, when you're setting up the Selenium, tools on your system, the first thing that you have to have is Java installed, right? So first you will have to install Java. Now, what version of Java can you install? You can install any version of Java. You just have to go to your Chrome browser, just search for Java download, right? So basically you need the JDK to be installed, right? You go to that particular website. Let's say we go to java.com/download, and then you will click on Java download. Then it'll automatically detect what system size you're on, and you can just click on agree and start downloading everything. I'm not sure it will download your JDK or not. In case it does not download your JDK, you can straight away go to your browser and type in download JDK for Windows, right? And then you will see this oracle.com page. You come here and then you can download this. Once you have everything installed, your next step would be to install Eclipse. Okay, now there are a lot of versions for Eclipse, guys. Prasanjit is asking me, can we use Mac for Selenium hands-on exercises? Sure, Prasanjit, you can install Java on your Mac and then install Eclipse on that system, and it'll work like a charm. There are no differences. So the best thing about using Java with Selenium is, guys, that Java is platform independent, right? If I create a test case in Windows, you can run it in Linux, you can run it on Mac, you can run it anywhere. So that's the beauty of having Java as a programming language with you. All right, so once you've downloaded the JDK, guys, next step would be to install Eclipse. For that, just type in your browser Eclipse download, right? Like I said, there'll be a lot of options for you to install Eclipse. All right, so once you reach on this page, you can just click on the download 64-bit in case your system is a 64-bit system. Just click on this button and you'll be able to download Eclipse on your system. Once Eclipse is downloaded, when you'll click on the setup, you'll get a lot of options of different versions of Eclipse to be installed. What you have to choose is the Eclipse for developers, right? So it will have an icon just like this. If you can see in the screen corner, you can see it has an icon like this where it's a care kind of a symbol. You have to install this particular version, Java for developers, Eclipse for developers, and this already has Maven pre-installed in it. That is the reason we'll be installing this particular version. If I have to quote you the exact text, it would be Java for EE developers. I think that's the exact text. But the icon, if you want to analyze which version to install using the icon, this is the icon, guys. If you can see my taskbar as well, you can see that this is the icon, Java EE IDE. All right. So this is the name that you'll have of the Eclipse. You click on that, that will start installing. And once it's installed, you will get a UI which would be similar to this. You'll not see the code, but you will get a UI which is similar to what you're seeing over here. Okay. Next thing would be to create a new project, right? Okay, so Preeti has a question where I can get the steps. Preeti, on your LMS, there would be some hands-on documents for setting up Selenium. So those would be the exact steps that I'm telling you right now. So if it's not available to you, you can just mail the support team. They'll surely send you on email whatever is required. So Saladhi has a question. Which version of Eclipse are you using? I guess I'm using the 2018 version, Saladhi, but actually you can use any Eclipse version, that does not matter, right? Go ahead and about Eclipse ID version. So guys, this is the 2018, this is December of 2018 version, right? If this is the number that you're looking out for, it's 4.10.0. Okay. So, but like I said, you can install any version that you want and it'll work the same. Guys, this was the icon that I was talking about, Java for developers, Eclipse for developers, Java EE IDE. This would be the symbol that you would be installing. And once you install it, you will have Maven pre-configured in your Eclipse. Okay, so once you have installed Eclipse, you have Eclipse just like this on your system. Next step would be to actually create a Maven project. Okay, you have to create a Maven project in order to be in order for you to use Maven in your code. Okay, so what you'll do is you'll click on File, you'll go to New, and then you will find Maven project over here. Okay, click on that Maven project. It will give you this kind of a screen where it will use the default workspace location. So usually that's in your documents, or it would be inside your users folder, right? So if you want, you can change it. In case you want to pursue the same, you can just leave it at default and you can click on next. Then it'll ask you about selecting something over here. Do not change anything, guys. Leave everything at default and you can just simply click on next. Then you will have to give a group ID and an artifact ID, right? You can give any name that you want. Like in our case, let me give it test, let's say Intellipaat, and let me say the test is test number 4. Okay, so it would work, and then finally you can click on finish. So this would create a new project for you. As you can see, a new test 4 project has been created, and you can see that there are if you double click on the Maven dependencies, you can just see there's a JUnit dependency which has been downloaded. Right now, for downloading all your Selenium dependencies, what you'll have to do is you'll have to go into pom.xml for your project. Remember, guys, it would be inside your project, that pom.xml file. Double click on that. Now in this project, what you will have to do is go inside dependencies. As you can see, this is the dependencies tag, right? And what you'll have to do is you will have to replace or you'll have to add your dependencies between the dependencies tag. In my case, what I've done is I have all the dependencies which are required for Selenium to work. If you want, guys, I'm pretty sure this is also available in the document that I was talking about, where how to set up Eclipse, how to install Java and everything. This code is also there, but I've also put it in the chat box. So if anyone is doing the hands-on along with me, they can just copy this code, guys, and then you can just come back to your Eclipse IDE. Because JUnit is already a dependency which is there in my previous code, I'll just delete this dependency from here and I'll paste all the code over here in Maven. Okay, once I have saved once I have pasted all my code, just verify whether all the tags are being closed or not. So whenever there's a slash somewhere, that means the tag is being closed. So if there's a tag being closed, there has to be a starting of the tag as well, right? So you can see the dependency is starting, dependency and ending, and what is being downloaded is Selenium HQ.Selenium, and the artifact ID in this case is Selenium Chrome driver, right? Then you have Selenium API which is being downloaded, then you have Selenium server which is being downloaded. All of these are dependencies which will be downloaded automatically. Okay, if I save the program now, you can see that all the dependencies are automatically downloaded on my Maven dependencies folder, as you can see on my left. Okay, so once all these dependencies are downloaded, you're good to go. You can start your Selenium project. You can start working with your Selenium project now. Okay, so you can just minimize Maven dependencies. So once you have all the dependencies in this folder, guys, next step would be to go inside your code. So the code would reside in source main Java. Just click on that, and then you will find a file which is called app.java. Just double click on that. Okay, and you would have some sample code which is already written over here. Right now, because you have all the dependencies downloaded, that would not mean that your code can simply use them over here. Okay, for using the dependencies, you will have to import them in your code. Okay, now what dependencies you will have to import? In my case, I actually did some googling. So guys, it's not important to remember what all you have to import, right? What you can do is you can start off by writing your Selenium code first, see the errors that you're getting, and then accordingly you can add the import lines. Okay, that's the way I do it. You can follow that way as well, because it is absolutely impossible to remember all these files, right? So it's better you do some Google with the error that you're getting, and you know what has to be done. Okay, in my case, I have to do these 4 imports. So one is TestNG I'll have to import, because TestNG, we'll talk more about TestNG as we move along. Then I have to import Selenium drivers, right? So one is by driver I'll have to import, then the web driver I'll have to import, and then the Chrome driver I'll have to import because I'm using the Chrome browser today. Okay, so let's copy this code and let's try to paste it over here. Great. So guys, once you have done it, cannot be resolved. 1 second. Let me see what the problem is here at TestNG library.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now let's continue with the session.
Great. All right. So now once you have imported all the commands for importing have been put over here. Next thing is you can start off with your Selenium program. Okay, I'll be using this file for a reference. So always it has to start with public class app. In this is the new file that you would be getting. Public class app is what you'll be starting with. The main file, or when you're basically using TestNG, in TestNG there is no requirement of the main function. Okay, so what you can simply do is you can remove the main function from here. More about TestNG I will make you understand. Right now just assume you just have to remove the main function and you'll have to write something like this: @test. Why do we write it? I'll explain you as we move along, but right now just understand you have to write @test. Okay, under @test you would be defining any function that you want. I'm basically getting an error. We'll fix it, don't worry. Okay, so after @test you will have to create a function that basically will be executing in your Selenium program. So as you can see in this particular diagram, before @test you will have to import so WebDriver is a library that you imported over here, right? So you will have to create an object of WebDriver. If you guys are not acquainted with programming, guys, it's totally understandable, don't worry. The only thing that you have to take care over here is about the logic. Okay, so I'm just explaining you the logic. If you still don't understand, just understand that you have to include this line before @test. Okay, so let's include this line, right? So now I have an object of the class WebDriver. All right, next step would be to put @test. We have done that, and then you will have to create a function which will basically do all the Selenium operations for you. Okay, let me run this file first, this particular file, and you'll know exactly what has to be done, and then I'll explain you each and every line which is over here. So if I run this program, this failed. Let me check why it failed. Okay, it says this version of Chrome driver only supports Chrome version 75. Great, I'll come back to this, guys. This is an error that we can only resolve once we have all the concepts in place. But what was the intent? The intent was to install Selenium as of now, and the intent was to install Java, Eclipse, and set up the Selenium dependencies in your system. I'm sure till this step, all you have to do is import the Selenium dependencies, create a Maven project, have the Eclipse installed on your system, have the Java installed on your system. If you're done till this step, then you're fine. We can move on. And then I will explain you this as we move along, because right now you will not understand what this error basically means. Okay, let me come back to my slides. All right, guys. So we have installed Java. We have downloaded and installed Eclipse as well for developers. We created the Maven project and we acquired the Maven dependencies. Let's move on to the next slide. All right, so our next step would be basically to create automated tests, right? Now, what is the process of creating an automated test in Selenium? The way you work with Selenium is, the first thing that you need to have is you will have to find an element first. So just look at it logically and then we'll understand how it works in the code. Okay, so first thing that your program will do is it will find the element on which it has to do an operation. Right? How do tests works? You basically, let's say we have a website. On that website, on some text box, I'll have to insert something. So that is what, for inserting that document, first I'll have to find that element on the whole website. Let's say there's one text box that I have to enter some text in. How to find that text box on that web application is something that I'll have to do first. So I'll have to find the element, right? Second step would be to perform the actions. So in our case, the actions would be to put some text, right? The first step, finding the element, was to find that particular text box. Let's say I'm on facebook.com and I have to enter the username. Okay, so what would be step number one? Step number one would be to find the username text box on facebook.com. Okay, once I've found the text box, which is basically my element, next step, the second step, would be to perform the action. In my case, that is to put the email ID over there, to type the email ID over there, which I have, right? And then that is done. Again, there would be one more action that I'll have to click on login after entering the password. And then the third step, so all these two were actions. That is, I entered my email ID, I entered the password, and then I clicked on login. These were actions. Then the third step is testing and reporting. So once I've logged in, I'll have to test whether the login was successful or not. That is my testing part, right? So I test it, and then whatever is the result, I give it in terms of in form of a report. That is reporting. So that is all step number 3. Testing and reporting is step number 3. Step number 2 would perform actions. Step number 1 is finding the elements.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the popular scripting language of DevOps? A. Java, B. Python, C. HTML, D. C++. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And this same logic we will be following in our program as well, that we'll be writing for our Selenium test case. Okay. Next step would be, guys, to understand how can we find elements on on our web page. So the elements can be found using these following properties. You can find an element by its ID on a web page. You can find an element by its name on a web page, the class name, the tag name, the link text, the partial link text, and then the XPath. Okay. Now, what do I mean by all these elements? Let's go ahead and let's open a sample website. Let's say I open Facebook. I hope it's not logged in. Great. So over here, what I'll be doing is I will have a particular element over here. Then I'll have a particular element over here, right? So how do I know that I have to go to this particular text box, right? Or how do I know I have to go to this particular text box? So this can be done by right clicking on the web page and clicking on inspect. Okay. Once you are in the inspecting mode, what you can do is you can go to this particular icon, which says select an element in the page to inspect it. Let's click on that. And now I can click on any element over here, and it will basically show me the corresponding code for that on the right hand side. Let's say I click on the email text box. Okay. So if I click on the email text box, this is the code which is highlighted so that I know, okay, so this is the code that I have to have a look at. Now, if I have a look at this particular code, what all do I get? Right? You can see the input type is equal to email. The class is equal to input text. Okay. The name is equal to email. The ID is also equal to email. The data test ID is equal to royal_email. So these are all the things using which I can find an element on my page. But how do I decide which one to use? Okay, that you decide by little R&D on the website. Let's say I inspect this particular text box as well. Okay, and let's see what all differences do I get over here. Can you see the input type is equal to password? Okay, so that is something which is different. Class is equal to input text again. Even the class over here was input text. So if I'm searching an element using the class, I will not be able to get to that particular text box because there are two text boxes with the same class. So I always have to pick an element that will be exclusive for that particular element, right? For example, in this case, uh, the exclusive part would be probably the name. The name over here is email, and the name over here is pass. Or if we have a look at the ID, ID is also different. ID over here is equal to email, and the ID over here is equal to pass. Okay, so the IDs are different. So I can either search the element using the ID, or I can search the element using the name. To confirm this, let us also check a third text box. Let's say this also is expecting an email, right? This text box is also expecting an email. Let's check what the code says about this particular email or this particular text box. So the input type equal to text. Okay, great. Class is equal to input text. Okay, data type equal to text. Great. Name is equal to registered email. Okay, value is equal to true. Placeholder, etc., etc. So there's nothing which is in common in terms of ID and name when I compare it with my text box, which was over here, right? These two text boxes and this text box has nothing in common when I would consider the properties which are name and ID, right? So that is evident, right? So once you have done this kind of an R&D, you can go back to your terminal and you will know, okay, so when I'm working, I can, when I'm working with this particular page, I can actually identify this username using that particular ID, which was the that particular element, which was either ID or name, right? I can go to that particular, I can search the element using that particular thing, and I'll have to enter the value which corresponds to that particular field, which is either ID or name. Okay, coming back to our slides, you can see that if you have to find an element on the web page, these are all the things that you can look out for and see whether they are individual or they are exclusive for the element that you want to be on. And if they are, you can basically take that thing and you can include in the code, right? For example, if I have to find a button, let's say I have to click on next on this Gmail page. Okay, if I have to click on next, I inspected, I found out that the class of that button, it's unique to that particular button, which is CWAK9, right? This is the class which is unique to that particular button. So what do? I write my code to be driver.findElement by class. So if it has to be something else, let's say by XPath, I write by .xpath. If it has to be tag, it will be by .tag, by .class, by .name, or by .id. Okay, and then you start with the brackets, and in the inverted commas, you specify the value that you saw while you were inspecting the element. Okay, you put that value over here, and basically Selenium, when we will run Selenium, it will identify, okay, so that is where I have to go, and that is what I have to find. So over here, we're not performing any action, guys. We're just finding the element and we're storing it into a button or a variable called button, right? So that if there is any action that I have to perform, I can basically do that action on this particular variable. I don't have to write this particular line again. All right. Now, before moving on, guys, I also want you to pay attention to this particular element, which is XPath. Okay. Now, XPath is something which is basically a code which every element on your website will have and which will be always unique, right? But you cannot get XPath directly. What you'll have to do is you will have to install an extension for getting the XPath of an element. For example, let us say I have installed the extension already, right? For me, the extension is actually CrowPath. I'll show you how you can install this extension on your system, right? Let's say I click here, inspect element, and then I click on this particular input text. This is the XPath that I will get, okay? And all I have to do is I will copy this particular value. I will go to my browser, or sorry, my Eclipse IDE, and I will say find the element by XPath, and I will set the value of XPath to be what I just found on my browser, which is this. Okay, this is my XPath. Now, how do you install this extension for getting your XPath? If you're using Chrome, guys, there is an extension called CrowPath. So you just have to search on Google, write CrowPath for Chrome, right? the first link, just click on that. Since mine is already installed, it will not show me the option of installing. It will just show me an option of remove from Chrome. Just click here. It will add the extension to your browser. Once it's added, just restart your browser once, and then once you'll be clicking on inspect, you should be able to see CrowPath tab on the most right hand side of this particular tab. Click over there, and whenever you want to see the XPath of any element, just click on inspect, go to that particular element. Let's say I'll go to password now, so you can see the XPath for that particular element. It's this, and your XPath, guys, it will always be unique. Okay, so you can be rest assured, if I'm not able to figure out what is unique for an element, I can always rely on XPath. Okay, I hope it's clear to everyone. All right, let us come back to our slides, guys. All right, so guys, we have understood all these things, that whenever I have to find an element, I can find it using all these attributes. And among these attributes, if I have to find XPath, I'll have to install an extension in my browser. And then when I inspect it, I will be able to find the XPath, which is always unique for a particular element. Okay, let's move on to the next slide. Next step is to perform an action. Okay, now that we have understood how to find an element on a browser, let's go ahead and perform an action on that particular element. Okay, so performing an action, it could be either you want to click on that element or you would want to write something in that element, right? So if you have to click, the function for that is click. Let's say this is what we did in our previous slide, that we were able to find that element, correct? Let's say I want to click on that element, so I will just have to write dot and then click in case I want to click on it. In case I want to write something in that element, I will have to write dot send keys over here, and in the brackets, in inverted commas, I'll have to put the text that I want to write in that particular text box. Then you have something called as clear. If there is a text box that you want to clear, you found that text box. Next thing, you want to clear it, click, just write dot clear, and that will clear that text box, right? If you want to submit a particular information that you have provided in the text boxes, just find the button for submitting. You can either click use this particular function, which is click, or you can use this particular function, which is WebDriver. Submit. Okay, so once you use that particular function, you should be able to do as per whatever these commands correspond to. For example, if you want to click on that particular element, you would be able to click once you specify the click syntax over here. If you want to write something, just write send keys over here, and you'll be able to write in that particular element, just like that. All right, so this is how you perform action. So on this particular slide, we understand that we can do 4 things. We can either click on a particular element, we can either write in a particular element, we can clear a particular element, or we can submit the information using a particular element. All right, and the syntax would go just like this. Whatever the syntax was for finding, in just in front of that, just write dot and just write the action that you want to perform, and that would be it for performing an action on a particular element. Next thing would be to test whatever we have done. What is the output that we are getting? Next step is to check whatever we have got, right? So testing is basically done using TestNG. So you have Selenium for finding the element, you have Selenium for doing any actions. If you want to now do a test on the output, whether it's right or wrong, you use TestNG for that. Okay, now what is TestNG? TestNG is basically a testing framework wherein NG means next generation. Now it was inspired from JUnit, so it basically mimics to a certain level that whatever JUnit does, TestNG can mimic JUnit to a certain level, right? But basically, whenever you have found an element and you have done some action on it, now the next step when you have to do testing on it, you will be using TestNG for that. Okay, I hope it's clear with everyone. So guys, like I said, TestNG, whenever you have found an element and you have performed an action, now when you have to test whether that output is right or wrong, you use TestNG for that. Okay, so TestNG basically makes use of annotations. What are annotations? That @ test that I wrote in my app.java over here. This is one type of annotation. There are numerous annotations. We'll understand each of these annotations as we move along. But for now, just understand that a feature of TestNG is that we have annotations. Why do we use them? We'll explain you as we move along. Okay, so TestNG has a mixed use of annotations, which helps us to create test cases easily. Then test cases can be grouped and prioritized more easily using annotations. Don't worry if you don't understand this, I'll explain you while I'm doing the hands-on. So TestNG supports parameterization, that is, you can pass parameters to TestNG. This actually would not make much sense for us while we're testing, but yes, this is a feature. It supports data-driven testing using data providers. That is, you can put some data on the testing application and you can check how your application is responding to that data. But this, we are using Selenium for this, but this again is a feature you can use TestNG to provide data to. But the problem would be that for finding the elements, you would have to use Selenium. Okay. Now, once the testing is done, you can also generate HTML reports, which basically mean if a test failed, if you want to have a nice web interface to see where test failed and what exactly in that test failed, it supports HTML approach. So whenever you run a test using the TestNG framework, you will have the reports generated in the output folder of your project. You can check that folder, double click on it, and then you'll be able to see a HTML page where all the details of your test would be written. Okay, parallel text execution is possible, so that's self-explanatory, and it readily supports integration with other tools and plugins like Eclipse, build tools like Ant, Maven, etc. So TestNG can be used with Eclipse, which we are using actually, and it supports Ant and Maven. So we are using Maven in this project. So TestNG can be used with Maven as well. All right. Next step would be to setting up TestNG on our Eclipse dashboard. So let's do that. Now, if you have to set up TestNG, guys, all you have to do is you have to import this particular library, which is already there in your Maven dependencies, because that is the code that we pasted in the pom.xml file that automatically downloads the TestNG library. And because we want to use the annotations, right, in TestNG, we are specifically importing only annotations in our program, right? And that's how this thing would be able to work. Now, how does this work? We'll explain it as we move on the further slides. But how to set up TestNG, just include the code that I gave you in your pom.xml file. That will automatically download the files that are here. Then those files you will have to import in your code using this particular command. Once you have done that, TestNG is up and ready to use, and you can use it freely. Now let's understand how to use TestNG actually. So we would have set up TestNG by now by using this particular command. Let's come back to a browser, and now let's understand how can we use TestNG. So TestNG uses something called as annotations, which I told you are nothing but these kind of texts, which are @test or @before method or @before class. Why do we use them? Let's understand that. So as annotations in TestNG are used to decide the flow of the program, which means now your program can be structured in any sequence that you want, right? But what happens is if you specify annotations in TestNG, and no matter where your code is written, the annotation which has to execute first, the function which is below that annotation will execute first, irrespective of the fact whether it's in the end of the code, whether it's in the middle of the code, or whether it's in the starting of the code. Okay, so these are the annotations, guys, which are available in TestNG that mostly is used while you're creating test cases. You have something called as before shoot, you have something called as before test, you have something called as before class, before method, and @test. Okay, so what basically happens is that before suit executes in the very beginning. After that, you have before test, which executes. Then you have before class that executes just after before test. And then you have before method, and then you have @test. Okay, so all your testing that you would be doing would be included in @test. Now, the one question that you can have in your mind right now is, why don't we just have @test? Why do we have all these methods or all these annotations? Why do we use them, right? So what happens is, before a test has to be executed, it could be that you have to initialize some variables, right? It could be that you have to open the browser, you have to test something, or you have to basically set up your environment in a certain way before your actual test runs. You have these annotations, right? So as we move along in complex software testing architectures, you would understand its importance, wherein, let's say, something has to be executed before the other code runs, right? So in those kind of scenarios, you can use annotations and you can specify that this line of code should run before the test has to run, or this function has to run before the test will run, right? And it makes your life easier when you have annotations in your hand, where you don't have to actually worry like, where exactly should I add my code. You can add your code anywhere, until and unless it is under the right annotation, it will work perfectly as you desire it to be, right? That is why you use annotations. So just like if you have before shoot and before test, you also have annotations such as after shoot and after test and after class and after method, right? All those annotations you can also use. Now let's go on and let's try to run some annotations in TestNG. So basically, we in this particular exercise, we will not be performing any test, but I basically just want to show you how annotations actually work. Okay, all right. So here we are in our code. Right now, @test is giving me an error. Let's try to define the code first, and let's try to fix the error after that. So let's say I define a function, public void test. Let's say there's a function that I defined like this. See, as you can see, the moment I include a function here, the error is gone, right? So basically that error was saying that I don't have anything under my annotation, and that is why it was popping an error to me. Now what I want to do here is I want to print something on my terminal. So let's print system.out.println, and let's print, let's say, test is executing. All right, and let's put the semicolons in the end. Okay, so this function should basically work. Let's save the program, let's try to run the program, and let's see what the output is. Can you see it says test is executing? Great. Now let me add an annotation over here. Let's say I add an annotation which says @before test. Okay, and now let me write a function, public void. Let's name the function as before. The naming of the function could be anything, guys. It could be random according to your choice. And now let's specify system.out.println, and now you specify, let's say, before test. This is the text that I want to print. Okay, I'm getting a warning over here. Let's see what the warning says. Import before test. Okay, all right. So the problem is over here. This has only imported the test annotation. If I specify a star over here, guys, it'll import all the annotations which are there in the TestNG. Okay, so as you can see, the warning is no longer there. Now let's try to run this program. Now, if you go according to the sequence of the program, guys, we have this function first, and then we have this function. So ideally this should have run first, but because we are using annotations and whatever we have studied, if that is right, I should be seeing this text first, and then I should be seeing this particular test. Let's try to run it and let's try to see what happens. Okay, so my test has executed. Let us check the results. So as you can see, first it printed before test, and after that it printed test is executing. Although my code, according to my code, the sequence goes that first test is executing is written, and then before test is written. Okay, so guys, this is exactly why we use annotations, to specify the sequence in my program. All right, one second, guys. Okay. All right, guys. So I think I missed one step for you guys. So basically, when I am importing the dependencies, so the code that I gave you, it does not have TestNG in it. Okay, and that is why UPA is getting an error, which is import TestNG error. So if you want to install TestNG manually on Eclipse, what you can do is you can just go to help, and you can then go to install new software. Okay, so once you're over here, now you'll have to enter a URL over here. The URL that you have to enter would be beust.com/eclipse. Okay, and then hit enter. So once you do that, you will find that in this particular space, you will have TestNG. Just select that and click on next. Just to follow the normal installation wizard procedure, you click on next. It will install TestNG in Eclipse for you. And I guess, Uma, that would solve your import error that you're getting on TestNG. So just try that, Uma, and let me know if that works out for you. I'm sure it'll work out. The URL to be entered is beust.com/eclipse. Okay, and install each and every file that you see over there. All right. Moving forward, guys, let me just come back to my Eclipse. All right, great. So now what we have done, I lost the app.java file. Yes. So we have tried @test. We have tried @before test. Let's see the other annotations also that we have. Okay. So we tried on test. We tried the execution sequence for that. Okay. So I won't care about the sequence here. I'll just write before method, right? And now what I would do is I will define a function below it, public void before method. So the name of the function does not impact anything, guys. You don't have to worry about that. And let's say I print something over here. Let's say I print system dot out dot print ln, and let's print before method is executing. Let's put a semicolon and we're done. Let's save the program, and now let's click on run. So you can see that first before test ran, then before method ran, and then test ran. So before method is just before your test. So your test method, just before your test method executes, you will have to run before method, and your before method will run, and before your before method you will have before test, which is running. So whenever you're planning on putting some dependencies that are related to your actual test, if you have to sequence them, you'll have to sequence them like this. The next annotation that we have is before suit. So let's understand that. And then we have before class as well. So let's put all these annotations together. Let's put before suit and let's put before class, and let's see how the execution method sequences. So let's first put before class. Let's define the function, public void before class. This is the function. And let's say what I'm doing is I'm printing this statement with this would be before class is executing. Similarly, let me just copy this, put it here, write this as before method, before suit, change the method name also as before suit, and change the text as before suit. Great. Anything else that we're missing? We've included suit, we've included test, class, method, and test. Great. Now let's save the program, run the program, and see what the sequence is. Okay, so first the suit is running. Before suit is the first order of execution. Then we have before test. Then we have before class. Then we have before method. And then finally we have test. Now let me show you something very interesting, guys. So let me come back to my code. And what I'll do is I'll write one more test annotation. Test. Let me write public void. And let's say the function is test2. right? This is the function. Let me write system.out.println, and what I want to print is test who is executing. Now let's see how this works. Okay, let me save the program. Let me run the program. Great. So as you can see, the total test runs are now 2 because there are 2 tests in my program. So first, before suite is executing, then before test is executing, then before class is executing, before method is executing, test is executing, then again before method is executing, and then test2 is executing. Can anyone tell me why this is happening? So basically all these have executed once, but my before method is executing twice. Okay, Arun says parallel. Okay, Salary says once can you give the link to install the software of TestNG? Sure, Salary. Let me just give it to everyone. So it's bust.com/. Guys, so Arun says because it's running in parallel. Okay. Others, can you tell me why there are why before method is executing twice over here? It's okay, guys. You can at least try. It's the most that will happen. It will be wrong that you're saying, right? So if anyone can tell me why before method is executing twice. Okay, so Subramani says because you have 2 @tests. Okay. Samsundar says we have 2 methods and it ran twice. Uma says before each test methods. Okay. Murli says because before test method runs before any test method inside the test tag is run. All right. Deepak says because we have 2 tests. Samsundar says if we have 3, it will run 3 times. Okay. Karthik says, is it a prerequisite before running test? All right. I guess most of you got it right, guys. So basically, the reason for that is because we have 2 tests, right? We have 2 times method which is running. Now, what does it tell us about the annotation @before method? If you have 5 tests in your program, @before method will run 5 times before it will run your test. But that is only limited to @before method and @after method as well, right? For example, if I write @after method, okay, and let's say I find the function over here. And let's give the print statement as well over here. This is the print statement. And this is after method is executing. All right, let me check, guys. Let us see the way it works. So let me save the program and let me run the program now. Okay, great. So if I scroll up, I have before suite, before test, before class, before method, test is executing, after method is executing, before method is executing, test2 is executing, and then after that I have after method is executing. So I guess most of you, almost all of you were right. So the after method, see, if my before method is running before test, right? So after before method, obviously test will run. And once the test is done, after that, you will have the after method, which would be running. Now let's try putting the annotations for all the @before class, @before. Let's try to put @after test. Okay, and now let's try to write public void after test, and now let's try to print the program. Right, this would be after test is executing. Now, according to you guys, when will this come? Will this come after the test or will this come after the method? Where will it come? And how many times will it come? Okay, guys, let's try it out. Let me save the program and let me run the program now. Now let's check the output. So after test is executed once, after method is executing, we test to before method, after method, test executing and before method. Great. So after test is only executing once. Can someone tell me why?
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous delivery and monitoring. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, guys, let me clear the air for you. So after test only executed once because before test also was only executed once. Do you get that? So before test and after test are basically complementary methods or complementary annotations. When you had two tests, what was executing twice? Your before method was executing twice, right? That would mean my after method obviously will execute twice, but because my before test method was only executed once, my after test method will also execute only once. Okay, that is the reason. Okay, so we were done with annotations. So what we did was we started to understand why my after test method was executing only once. And the reason for that was because before test method or before test annotation was also executing only once, right? And that was the reason we were only getting it once in our output. So we can verify that. As you can see, after test is only executing once. All right, guys, I think we have now understood how annotations work and why are they exactly used. Let me come back to my slides. So we have understood what annotations are, guys, and we have successfully done a working hands-on exercise on annotations with TestNG. Now let's move forward and now let's create an automated test with TestNG. So now we know how to find elements, we know how to perform actions, we know how to do the testing using TestNG, as in using annotations. Now, because we are a go with all the commands, how to find elements, how to perform actions, and how to do tests, let us go ahead and do this particular exercise. Now, while we're doing this exercise, guys, you'll learn a lot of new things as well. So I want you to pay a lot of attention over here. So the first thing in this demo that we have to do is that I have to open a website, which is Intellipaat.com. Okay, let's go step by step. Let's try to just focus on step one right now. Let's try to open Intellipaat.com automatically using my program. Okay, so I'll come back to Eclipse. All right, and let us just have @test method for now. So what I can do is I can remove before suite, I can remove after test, I can remove before class, I can remove after method, I can remove before. Okay, let's try to keep these. And let's say what I want to do over here is, one second. Okay, so the first thing that I have to do is how I have to tell my driver how to open the browser and exactly which browser to open. Okay, so for that, what I can do is I can quickly just show you the syntax for that. Okay, so the first thing that I'll do is I'll have to set the property, that is I'll have to tell where exactly or how exactly to open Chrome. Now for opening any browser, guys, you will have to download the driver for that particular browser so that your program is able to interact with that particular browser. Okay, in our case, if I want to connect to Chrome, I will have to download a Chrome driver, right? And that Chrome driver I will use to basically connect to my browser. So in this case, once I have told my program where the Chrome driver is, I will initialize a new Chrome driver variable. And then this is the command to go to any URL. You have to type in driver.get and then you have to specify the URL. Okay, so in our case, we have to go to intellipaat.com. Now, let me show you the error which is happening over here, which you might also face while you are setting up your program. Okay, so it says session not created. This version of Chrome driver only supports Chrome version 75. Now, how do we fix this kind of an error? So it supports only Chrome version 75. Now, let me check my browser version. I can go to help, I can go to about Google Chrome and I can check my version of Google Chrome is 74. Okay. Now for this, what will I have to do? I will have to download the Chrome driver for my particular browser. Now, how will I do that? I will type download Chrome driver over here in my browser. The first link, let's click on that.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now let's continue with the session.
And now I will have all these versions. So I have Chrome driver 75, I have Chrome driver 74. Now this is the driver that I need to get with regards to my browser, which is also 74. Let's click on this. When you click on that, you will reach this kind of a page wherein you can choose which Chrome driver to download based on whichever operating system you are on. You can choose the Chrome driver. Okay, so in my case, the Chrome driver that I'll be downloading is this one, the Windows version, right? Let's click on that. And as you can see, my Chrome driver is now being downloaded. It has downloaded successfully. Let's try to open it. Let's try to extract it. Okay, this is my Chrome driver, guys. Now what I'll do is I'll just change the folder name. Let's change the folder name to, let's say, something as Chrome 2. Okay, here is where my Chrome driver exists. Now let me come back to Eclipse, and now let me just change. So you will have to enter the path over here for your Chrome driver. My path is in downloads and it's in Chrome 2. Okay, let's save the file. And now let's try to run the program once more. Can you see it's going to facebook.com as specified? Great. So that means my program is running. Okay. Now let us try to replicate this in this new file that I created while I was working. Okay. So the first thing that I have to do is I'll have to set the property for Chrome. So the command for that is system.set. Okay, we can see the syntax from here. So the syntax is system.set property. And then you will have to specify this line, right? Let's specify this line. Okay, so this is very important, guys. WebDriver.chrome.driver, and this has to be imported over here. Okay, WebDriver. You also have the Chrome driver over here. So this Chrome driver actually needs an executable to run, right? It does not mean it will download the executable also. Okay, so Prasanjit says, why the driver path in the file system uses double backward slash? Can't we use single slash? So you can use single slash, Prasanjit, but in Windows, it always works like this. Not sure why, but it works like this. If you are into Linux, then of course, you will have to specify the forward slash, and over there, the single slash will work. But while you're in Windows, always the double slash will work. And it's not like you have to specify this. Let me show you something. So if I go to Chrome 2, let me copy this path. Let me remove the path from here. Okay. And let me now paste it. Can you see it puts double slash? I think the double slash is to escape the character, right? So for escaping a character, you have to put a backslash. So this backslash could mean something else. And what we want the code to understand is that we want that it's a path that we are specifying. So if we want to escape the functionality of a particular symbol, we again specify, and that is why double backslash is coming. But you can easily see I didn't specify backslash separately. If I delete it and if I copy the path from here where I have only singles backslash, if I paste it over here, it automatically makes it double backslash, right? So because this is the directory path, now I also have to specify the executable, which is chrome driver.exe. Great. All right, Prasanjit, great. Thanks for the confirmation. All right, now let's go ahead and so my system.set property is done. Next step would be to initialize my Chrome driver. So that I can do using this line. Let's paste this line over here. Great. Next line would be to go to the particular address that we have to go to. So we'll type in driver.get and let's specify this as www.intellipaat.com. Intellipaat.com, and let's check whether if you go to Intellipaat.com whether it's HTTPS or whether it's HTTP. Okay, so it is HTTPS. So you'll have to take care of this thing, guys. When you're specifying the URLs, you have to take care whether it's HTTPS or HTTP, and the same thing you'll have to specify over here. So our step one is now done, guys. Let us check if our code is now running. Let's save it, and now let's execute the program. Okay, so the browser is getting opened. The net seems to be a little slow, but all in all, I think you can get the idea that we are able to go to Intellipaat.com, right? I'm not sure why it's taking such a long time, but okay, so yes. So I'm able to go to Intellipaat.com. Now let's see what our next step is. So let's come back to our slides. 1 second. Yes. So our next step would be to enter DevOps term and click search. Okay, so on my website, which is this, I have to click on this particular text box and I have to enter DevOps over here, and then I have to click on search. Okay, so there are 3 actions involved over here. First, I will have to click on this text box. Then I will have to write in this text box, and then I'll have to click on search. Okay, so these are the 3 things that I have to do. Let's go one by one. So I'll come back to my Eclipse IDE, and now let's try to enter this. So the syntax for that is driver dot find element, and what do we want to find it by? The easiest that I told you is using XPath. So what we can do is we can click on the search bar and we can click on inspect, and then what we can do is we can go to CrowPath. I'm not getting that over here, probably because I was in the automation browser window. So if I go here and if I click on inspect over here, and yes, I should be able to find CrowPath. And now let's click on that particular text box. Here's the CrowPath, guys. XPath, guys, sorry. So we'll copy this XPath and let's now try to paste it by dot. Now what do we want to find it by? I want to find it by XPath. Here's the command, enter, right? And now it says XPath expression, put double quotes, inside double quotes put your text, and now put a semicolon after it. Great. Now this is just the finding part. What do I want to do with it? I want to actually click on it. So I'll say dot click, and then I'll say the function is this. So now my program, what will it do? It will open Intellipaat.com. It will then go to then go on the web page and it will try to find this particular element with this particular XPath, and then it will finally click on it. Great. This is what we want. Let's go ahead and try it, right? So let me save the file. Let me run the file, and let's see what happens now. So can you see the cursor actually is now on this, right? Which means my Selenium successfully clicked on this text box. Great. So it's working fine. Now let's go ahead and now let's enter some value into this, right? Let's copy this particular syntax. Let's paste it again. And now let's remove click. And now let's try to specify send. So the beauty of Eclipse is the moment you're trying to type something, it'll give you the suggestions automatically. It'll also give you how to use that method, right? What is that method doing? Character sequence to send the element. Great. I'll just hit enter and it'll autofill it for me. And now what I have to enter is the data that I want to search or that I want to enter in that particular text box. So the text that I want to search for is DevOps. Let's save it. And now let's try to run the program. Let's see what happens. Okay, so Intellipaat.com is open. Great. So DevOps also has been typed by my program. Great. Now next step is to actually click on search. Okay, let's do that. Let's go back to our code. Again, what we'll have to do is we'll have to copy the same command. No, not this command actually. Driver.find element by .xpath. Let's copy only till here. Next step, let's paste it. Now we want to find the element. Now, what is the element that we want to find? The element we want to find is search. So let's close this window first, this window as well. And now let's see what is the XPath of our search button. So this is the XPath of my search button. Let's copy this. By XPath, we'll search this particular button. What do I want to do with this button is I want to click on it. And that's it. I think we forgot a bracket here. Let's put that bracket. All right, we're all set. Great. So now what it'll do, it'll go to intellipaat.com. It'll click on the search bar. It'll type DevOps in that search bar, and then it'll click on the submit search button. Great. Let's go ahead and try this now. Let's save the program, run the program. So it opens a browser, opens intellipaat.com, enters DevOps, clicks on search, and now you're on the search page. Great. So I think half of our hands-on is now done. So we opened the browser, we went to intellipaat.com, we searched for DevOps, we clicked on search, and we reached the search page. Now let's see what is the next step in a slide. On the search page, check for DevOps certification course. If it exists, then click on the course. Okay, so what that basically means is that I will have to go to DevOps. So if I click search DevOps here, if I click on search, it should be able to find something of this sort, that is DevOps certification training, right? Let's try to see the XPath for this. This is the XPath for that, right? Let's copy it. And now what I want to do is, this is the XPath. This is the syntax. And what I want to do is I want to check the element. If it's there, I'll want to click on it. Great. If it finds that element, it will click on it. If it doesn't find that element, it will not click, and therefore it will hang basically on that page. And we'll see how that goes in a little moment. But for now, if it exists, click on the course. We did that. On the course page, verify if the page DevOps certification training is present as the header. Great. Now, how will you do that? So that basically means once I'm here, I've clicked on it. The header over here, it should be DevOps certification training course. Great. We'll figure this out. First, let's see if it is able to click on the DevOps certification course icon. Let's save the program. Let's run the program now. So we are going to intellipaat.com. We will, once the page load is complete, it will execute the second step, which is writing DevOps. It clicked on search and it went on the DevOps certification training page. Great. Now it has to check whether this particular text is present or not. Now, how can we test that? So now we'll be making use of TestNG. So there is a command which will basically help you to check, which is called assert equals in TestNG. Let us see the syntax for that. So one second, guys. Okay. This is how you use assert equals. So first, you specify the place on the web page where you're getting the title from. Second thing is you specify the actual title. Now, if this returns a true value, then your test passes. If this returns a false value, then your test fails. Let's try to use this. So I'll just copy this code. Let us try to paste it over here. And it says assert, we'll have to import. Okay. Import testng.assert. We'll have to do this. Great. And now, great. So now the error has been, it is only this warning that I'm getting for this particular variable because I'm not defined this. So the actual title has to be string actual title. This would be equal to, now let's go back to our slide. So it says verify if the page DevOps certification training is present as header. So DevOps certification training. This is the actual text. Let's copy it. Let's paste it here. DevOps certification training colon. And again, this also we will change to the text that we want. Okay, so now we will have to check whether this text is present or not in the header. Okay, so let me just go to my, so this is the text that we want to check whether it's present or not. And the way we can do that is let's inspect. Because this is the automation window. Okay, so I will select this text, right? And I can see that the XPath for this is this. Okay, let's copy it. Let's come to our page. So what we'll do now is we'll again try to find an element, driver dot find element by XPath, the value for which is this, right? And what I want to do is I want to get the text from this particular web element. Okay, I close it. Because I'm getting a text, I'll have to store it somewhere. So let's say I define a variable string actual value is equal to what I'm getting from this particular XPath. Okay, and then what I do is I specify that variable over here. So it will be actual value that I'll be specifying here. Great. So now what is happening is it is basically finding my element and it is storing its value in actual value. And then what it is doing is it is trying to basically check whether my this variable and this variable are same. If it's not, then it will fail the test. If it is, then it will pass the test. Let's try to do this. So we'll save the program and let's try to run the program. Okay, so it will go to Intellipaat.com. Now it will search for DevOps. It will click on the course page, and now it should have checked. Now, how should we know that our test passed or failed? We'll have to check in the console. So it says failures 1. Let's try to understand why. So if you go up, it says expected DevOps certification training, but found DevOps certification training course. Okay, if we come back to our page, okay, so actually the text says DevOps certification training course, right? And let's specify the actual title to be DevOps certification training course. Let's see if it passes the test now. We'll close the window and let's try to run the program now. So go to Intellipaat.com. Also remember guys, until and unless your web page is fully loaded, it will not execute the second command. So it waits for your page to execute first and then it gives you a output. So you can see it says total test runs were 1, failures are 1. Let's check why. Let's go up. So it says it expected DevOps certification training course, but it found DevOps certification training course. Okay, all right. That it is case sensitive. So over here in my website, I can see the O is capital and even the O which is here, I've specified it to be small, right? So let's specify that capital O. Let's save the file and let's try to run the file again. So it'll open the browser. It'll go to Intellipaat.com. It'll wait the page to load fully. Then it'll search for DevOps, click on search, then go to the page. And now it should. Yes, so now as you can see, the failures are 0 and the test runs are 1. And if we go up, it says the test has passed. Okay, now what you can also do over here, guys, is I can go to source. One second. I can actually see the HTML output for this as well. So I think that should be somewhere here. Just give me one moment, guys. Let's search once. Where is exactly a TestNG report generated? Test ng report generate, not generated or generated path on Eclipse. Okay, there should be a test output over here, and the way we can get that, okay, let's check. So this was an app, and this is basically in test 4. Okay, refresh. Yes, so we have the test output folder now, and now we will have to go to TestNG results. There should be an HTML file over here, index.html. Yes, here it is. Just click on that, go to properties, and here's the path. Just copy that path and just try to run it in your browser. So I'll just go here, I'll run the path, and as you can see, it says test results one suite, default suite, and what I want to check is this pass methods show, and as you can see, it says the test has passed. Now let's try to fail the test. Let's see how that goes. So what I'm going to do is I'm going to search for something else. Let's see how it goes. So I'm going to search for AWS. Let's save the file, and now let's click on run. Okay, so now it will open the browser, go to intellipaat.com. Instead of DevOps, now it is actually going to search for AWS. It will click on search, it will come here, and since it will not be able to find, or it will not be able to find DevOps certification training, it will not go to that particular page. And as you can see that failures are 1. If I come back to my TestNG report, if I refresh this, you can see that the test has failed, and you can actually see why it failed over here. So you can see that no such element, unable to locate element which should have DevOps certification training course, right? And that is why your test is failing. So you can just see why your test is failing over here and accordingly make changes to your application.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the popular scripting language of DevOps? A. Java, B. Python, C. HTML, D. C++. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so guys, this was the hands-on that we were supposed to do. Let's come back to our slides. All right. Our next question is, guys, that we have to run the test that we just made in a headless mode. Now, what is a headless mode? Headless mode basically means that right now we can see that the browser is opening, right? But I don't want the browser to open. I basically want it to execute in the background. And how is it helpful where the browser is not opening? How is it helpful? That is particularly helpful when you're running tests on a command line operating system. Okay, like for example, right now we have a graphical user interface, correct? And because we have a graphical user interface, we can see the browser opening. We can actually go to a particular domain and check everything out. But what if you are on an operating system where you don't have the access to the browser or the user interface? So in those kind of scenarios, we run the browser in a headless mode. Okay, that is the only option that we have with us. Now, how to run a browser in headless mode? So obviously when you're coding your Selenium test, at that particular time, if you're testing it, you can test it on your computer which has a GUI. You can check whether Chrome is opening, everything is functioning fine or not. When your program is full and final, when you know that it's executing without any trouble for whatever edge cases you decide, after that what you will do is you will come here in your code and you will go to this particular line where you have defined the Chrome driver option. Okay, after this you will have to define the Chrome driver options, wherein you will specify the headless mode. Now again, there's a syntax for that. We can just quickly check that syntax online. Headless mode Selenium Java. Okay, in headless browser, and then we can just check the syntax for that. Yeah, so here it is, options.add arguments. And first you will have to define this particular line. Let's specify that. This is the line that we'll have to specify. And after that, you will have to include the option headless in your WebDriver, which should be over here. So this line will basically come after options, and here you will specify this particular variable, that is options. Great. Once you have specified that, let me see what the warning says. So it says import Chrome options. Okay, let's import it. So as you can see, this line has automatically been added once I clicked on that extension. So now basically my browser should not open, yet my test should run. Let's check how that goes. Let's save the program and let's try to run the program now. So now, as you can notice, there's no browser which is opening, right? So once the test is complete, you'll get the output in this console, and that's when you'll know that, okay, so my test has completed. All right, so it says failures 1. So your test has failed. And this information you got without having to open the browser. So if you can go to my TestNG result, I'll just refresh the result, and it says unable to locate element, which is this. And the reason for that is I did not change this text. So let me change it to DevOps. Okay, let's save the file. And now let's try to run the test again. Okay, it still has failed the test. Let's check why. So it said element click intercepted, element ahref title, which is this, is not clickable at point 184.592. Okay. Other element would receive the click, info stripe, nav par, fixed bottom nav. All right. This particularly happens when there's a resolution problem. So what we can do is let's remove this options as of now, and let's try to run it in the browser mode to see where exactly the problem is occurring. So opens, it's entering DevOps, it's searched for it. Okay, so problem lies here where it's not able to click on this particular page, and that's when the failure is occurring. Great, let's solve this. So the way to solve this, guys, is to maximize your window so that the resolution becomes the same. Now, how can you maximize your window using Selenium? There is an option for that. Maximize Chrome window Selenium, and over here you should have the options that add arguments. Let me just search for Java. Okay, and the syntax over here is this is the syntax that we want. driver.manage.window.maximize. We'll come back here and we will open Intellipaat, and after opening Intellipaat we'll just maximize the window. Great, this should work now. Let's check. Let's try to run the program. Okay, so it's opening Intellipaat.com, and after it is opened, it should maximize the window. Great, search for DevOps. Now it is able to go into this page, and after that, you can see the test has passed. Great, now let's just specify options over here, and now let's check if the headless mode test also passes. Okay, it says failure. Let's check why. All right, let's try to run it one more time, guys. Save it, run it, and now let's check. Still failing. Okay, now why is it failing? To verify that, let's try to copy this error and let's try to run this on Windows. Now I'll have to remove some things from here, like the title, which is not going to be generic. Even this I'll have to remove. Other thing that I can remove is this particular thing. Okay, what else can I remove from this query? Even this is not required. And what else? That's it. Okay. Okay, so it says this is caused by following three types. The element is not visible to click, which is true in our case because it's in headless mode. So use actions or JavaScript executor for making it to click. All right. Page is getting refreshed before it's clicking the element. Page element is clickable, but there is a spinner overlay on top of it. I think the first should not be a problem. Reason being, it is able to go to DevOps. It is able to search for DevOps and click on the search button, but it is not able to click on the DevOps certification page. Correct? So let's verify. Element is clickable. There is a simple spinner or overlay on top of it. One more problem there that could be, guys, it could be because of the multiple instances which are open in our background. Let us remove options and check if our test passes again. So open Intellipaat, maximize the window, this, search for DevOps, click on the DevOps course. Okay, it is yet not again able to click here. Great, so this seems to be the problem. All right, no worries, let's try to fix it. Let's close the window. Also, let's check how many Chrome windows are open. Okay, so it says there are 66 instances running. Okay, this seems to be the problem. Let's try to end this task. Great. So Chrome is now closed. And to avoid getting this problem, what we can do is that we can close our Chrome browser once our test executes. So basically what we'll do is we will add an annotation at the rate after test. And then what I can do here is I can close the window, right? But that would be a problem. Why? Because the scope of the program limits my driver to be defined inside this. So let's try to close the window here itself. So let's try to close or exit the browser. Exit Chrome, Java, Selenium. Let's try to search for this. And this is the syntax, guys. Let's try to quit the driver. Great. And this should happen after the test, but let us try to define the driver before that. So this can go here. One second, guys. So this is, if it's executing here, it's fine. And then we have to go to Chrome options. Okay, let's try this. So this would run after the test, and this would be basically public void close Chrome, the function. And let's see how it works. Let's run the program, and obviously this has to be without the options so that we can see what is happening. Went to intellipaat.com. It should then maximize the window, search for DevOps, was able to click on DevOps now, and it closed the window. Great, so it's working. Now let's try to add options over here. Save the program, and now let's try to run it. Okay, it again failed. Let's check the problem. Element click intercepted, element which is this, DevOps certification training, title which is this, training course. So the problem seems to be occurring on this particular option, driver.find element where the front page submit search. No, actually it's happening over here where the element of ahref DevOps certification is not clickable. Other element would receive the click, which is this ahref. Okay, let's try to search this on our code to understand where exactly the problem is occurring. It could be that the XPath for that particular thing is not working, but let us check. If it is able to click the search button, it should be able to click over here as well. And now what I can do is I can do a control F. And I can search over here, console, sources, network. Okay, if I do a view page source, correct, this is the code. And if I inspect this, this is what I'm trying to click. What if I change the XPath to actually click on the image? Let's try that. Say this is the XPath that I would be clicking on in that case. Let's try to copy this into the XPath of this code, save it. Let's try to run it now. So Prasenjit says there's overlay, I suppose. Let's check Prasenjit once. So the text executed. Oh, the test executed fine now, guys. So the problem was with that element. Basically, that element, I guess what Prasenjit is saying is right. That what is happening is when you come here, there's an overlay of this particular element, right? And hence it becomes unclickable. Can you see? I cannot click here now. I can only click if I come quickly on this particular page. So what I've done now is I have given the XPath for this particular image. So this is clickable, but this is not clickable, and hence I guess this is the problem, right? So now it's supposed to be working. This is options is enabled. So let's try to run it one more time so that we know that this was the problem. Save the program, run it, and it's executing in the backend. Great. So as you can see, the test has now executed successfully. And if I go to the test output, which is in the properties of this particular path, I can see the test has passed and it executed successfully. Great, guys. So I think I'm sorry I had to troubleshoot a bit this website, but I guess we have solved that problem. The problem was that whenever the mouse was coming back here, it was becoming unclickable, this particular element. So sometimes if the mouse came fast, it could have clicked here, but if in most cases, if this element appears before that, it is not able to click, right? So what we did, we changed the element to the image so that it becomes clickable. And that's what we have changed in the code as well. We changed the XPath to the image of what we are going to click, and then it works like a charm. All right, now talk about continuous testing. So we have successfully ran the headless test in Selenium, and now I guess most of you guys know how to create a test in Selenium. We have also encountered a lot of errors, so you guys know how to solve errors as well. Next step is, what is continuous testing? So guys, we know how to do testing, but what is continuous testing exactly, and how do you integrate what you have learned right now with DevOps? Okay, so for that, what we do usually, so let's first understand what continuous testing is. So the process of continuously testing while a DevOps cycle is being executed, that is like, if you would have studied DevOps so far, you would have seen that if I want to test my application, if it's working or not, how will I test it? I'll basically commit on my GitHub, right? And then that GitHub will basically trigger my Jenkins to deploy my application on the testing server. And on that testing server, what you do is you test, or you run the test that you have created on your application, right? Then and there, you will get either a failure or a pass message. If you get a failure message, you will know that, okay, I have to do some changes and I have to write my code again. You do those changes, you again commit it on GitHub, again your Jenkins will deploy that application to the test server, and on the test server, then again your Selenium code will be ran against your application, right? And if the test passes, it automatically will push that application to production without giving you a message that your application has failed or not, but you will do get a message that your test has passed. You can do two things over here, guys. You can either set a trigger so that your manager will review what you have done, the test cases have passed, and then you push it to production. Or if it's a very mature DevOps lifecycle and the test cases are to the to the point. In that case, what you can do is, on a successful test case, when all the test cases pass successfully, it can be automatically be pushed to production. That can also be configured. So this process of continuously committing on your GitHub so as to improve your application so that it can test the past test cases, this is called continuous testing. Now imagine when 10 or 15 developers are working and everyone has their own testing environment, there'll be a lot of testing going on, right? And when you become part of this kind of a DevOps lifecycle, it is called continuous testing. Now, how does a continuous testing architecture looks? I've already explained you guys, but this is how it looks like. A developer will basically be committing on a version control system, which will basically trigger my continuous integration tool to basically deploy my application on the testing server. If everything goes well on a testing server, it will push it to production. If my testing server fails or my testing fails, the feedback is given back to the developer. And this process is called continuous testing. The process of continuously giving feedback to my developer would again be continuous monitoring. Okay. Now, how does a continuous testing framework usually work, and how is actually automated test created? Let's understand that. Now, the products are built with their test suites, right? And let's say there are X features on my website right now, so there'll be X tests to test each of those features. So if I have feature A, I will have a test suite for feature A as well. When I add a feature B, I will also have to create the test suite for feature B, right? So my automation testing development and my application development goes hand in hand. All right. And as and when all my test cases are complete, let's say developer pushes feature A, the version control system, it will be deployed on the testing server, and then it will be feature A is tested. Similarly, if feature B, when the developer pushes feature B on the version control system, and at the same time you have added feature B to your version control system, your feature B also will be tested. But it is very important to update your testing suites with all the new feature testing as and when the new feature is being developed. Okay, and that would be the end of this session, guys. So continuous testing is nothing but making testing a part of your DevOps lifecycle, right? And then moving forward with it. So how do you test in the DevOps lifecycle? The way you do it is that, let me come back to my clips. So what you do is this is my project test for. What I'll do is I'll right click it and I will click on build. There should be an option for build over here. Yeah, so sorry, there's an option for export over here, right? You'll click on export, and now you want your application to be a runnable jar file. You click on next, it'll create a jar file with test.jar. You click on finish, and now all your dependencies will be packaged into test.jar. Click on yes, and it will say jar export finished with warnings, but warnings doesn't mean that your program will not run. So now you have a workable jar in your computer that you would just have to push on your testing server. So it was in C app, and this is my jar file. Now what I can do is, if I want to run this particular jar file, I'll just have to open command prompt. Let's assume we are in a command mode operating system. I would go into that particular directory, and now I will write java-jar and then test.jar. I'll hit enter, and you'll be able to see that your program execution will happen over here now, right? Remember guys, that whatever operating system you are pushing your jar file on, right, you will have to specify the Chrome driver path for that particular machine on which the jar file will run, right? This will not change automatically. This you have to set. So if your testing jar will run on Linux, you will have to specify the path for your Chrome driver on Linux over here, not anything else. It will be the path of Chrome driver in your Linux machine. Where does it actually exist? So for example, if it's in /home, let's say it's in /home/ Ubuntu, and let's say the Chrome driver is over here. So this is how you will specify the path when you want your jar file to run on a Linux machine. Okay. All right, so why do we need continuous integration? Let's understand this using an example. So imagine yourself being in a company and where there are 3 or more developers who have been asked to add features to an already existing website. Right? So in the beginning, you all were given version 1 code and you had to work on this code to add your features. So developer 1 had his features to add, developer 2 had his features to add, and similarly, developer 3 had his features to add. Right? So developer 1 added his features and he submitted first, right? And he submitted to the source code management system and his code was labeled as version 2. But when developer 2 has to submit his work, he basically added changes to the version 1 code, not to the version 2 code, right? So his changes in the version 1 code had to be integrated with version 2 code, and only then it would amount to become version 3. And at the same time, testing was also supposed to be done. Once this was integrated, testing was also supposed to be done to see whether the new features who have been added to the website, are they not interfering with the already existing features of the website? Is everything functioning normal? So this was the normal routine, or this is a normal, I would say, the life cycle of a software development methodology, right? So once the bugs have been identified in manual testing, everything was given back to the developers saying that, these are the bugs, please fix them. Now, there were problems in this structure. You would say that this seems perfect, but there are some problems in this structure. Let's understand those problems. So the first thing is that because it took a lot of time in integrating things and it took a lot of times in manually testing things, developers used to work on 3 or 4 features together, and at once, say twice in a 6 month time or once in a 6 month time, they used to commit their changes or to the source code management system, and then a manual integration was done because such a large code base is there. So a manual integration took a lot of time because there were a lot of features which had to be integrated, and I'm just talking about 3 developers. Imagine in a company when there are 100 plus developers working in the company, right? And everyone is committing to the source code management system. Now integrating that takes a lot of time, and this was a problem. So first you have to integrate that, and of course after that you'll have to test him, and testing was also done manually, which again took a lot of time. And because of a lot of time in manual integration and manual testing, it affected the time when we will give the feedback back to the developer. Now imagine you submit your work to the company, but you have not got the feedback how your work is. And of course, no person is perfect. Every code that goes through the software development lifecycle will have some bugs that we'll have to fix, right? So the developers.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now let's continue with the session.
Used to wait for the bugs to come back from the testing team, and took a lot of time, and this led to a big gap in the software development lifecycle. It took a lot of time to develop code or to develop applications with respect to the features that were requested from the application, right? And because of this, there was a high risk and uncertainty when you look at it from the business perspective, because you could not pinpoint on a date which would near to the customer expectations. It always took a lot of time to make changes in an already existing application, right? So these were the problems before continuous integration, and we had to solve this time problem that we have so that our release cycles become shorter, our work becomes more accurate. And because of this, we came up with continuous integration. So what is continuous integration exactly? So continuous integration is basically the process of having shorter release cycles by creating small features in our code and simultaneously integrating them to our source code management system. But there's a catch. The integration and testing now happens automatically rather than manually, right? And this is why continuous integration is such a hype, and it benefits a lot of organizations, because not only do you have shorter release cycles, that is, your features are going out every day, but also you have automated integrations and automated testing, because of which a lot of time gets saved, right? So how does the time get saved? Let me prove you using an example. So this is a classic scenario of how things happen these days. So you have a developer, the developer finishes his code and he submits his code to the version control system, which is picked up by the continuous integration tool. Now the continuous integration tool automatically deploys it on the testing server, and the testing server automatically has build suites which have been defined for your application. It tests all the features of the application automatically, and if there are any bugs which are identified, probably a test case failed or something like that, it gives that feedback to the developer, and all of this happens in a matter of minutes, right? That's how fast it is. Now imagine yourself in the earlier world, when I told you it took a lot of time to manually integrate things, to manually test things. So you used to get feedback in days, if not hours. And in this case, that is today, you get automatic feedback in a matter of minutes. And this has led us to improve our release cycles in such a way that today we are getting releases, 2 or 3 releases in a day. Earlier, we used to have releases twice or thrice a year, and now we have 2 or 3 releases every day. Obviously, it's shorter releases, shorter features, but that's how powerful our software development lifecycle has become with the use of continuous integration. And it does not stop here, right? With more mature continuous integration, or with more mature DevOps model, what happens is if your test succeeds, it is automatically also pushed onto production, right? And this is the power of continuous integration. Now obviously continuous integration is just a concept. If you want to implement it, it will be implemented using some tools. So we're going to discuss that in a few moments, but before that, let us summarize what we just discussed, right? So the advantages of continuous integration include frequent commits and hence small feature updates to our website, but every day or every twice or thrice a week, right? We have automated build and testing that saves a lot of time. It gives the feedback instantly to the developer, and also because of this, there's a low risk and faster delivery of products when you look at it from the business perspective, right? Now, like I was saying, that all of this is possible using continuous integration, but continuous integration itself is just a concept, right? It can be implemented using hardcore tools, and we're going to discuss that in a few moments. So continuous integration is a topic for today, and the continuous integration tool that we're going to discuss today is Jenkins. Now Jenkins is an open source tool which is basically used for continuous integration. It is based on Java, and a lot of companies are working on Jenkins to get their day-to-day work in the DevOps lifecycle done, right? So this is a brief introduction about Jenkins, and I already told you the features of continuous integration are all of them pertain to what Jenkins can do in your life, right? So without wasting any time, let's go ahead and start with Jenkins by first installing it on your system. So how can you set up Jenkins on your computer? Now there are a set of commands that you would need to run on your Linux box that would set up Jenkins, but there are 2 or 3 ways you can install Jenkins with. If you have Docker installed on your system and you are just into testing, you can have Jenkins installed in a Docker container. So with that, you do not have to set up your environment with Java. You do not have to go through the process of downloading things. Just download that container, and that would have Jenkins up and running on your system, right? But this is a bare metal installation that I'm going to show you guys. So let me just switch back to my server that I've deployed on AWS to see how you can deploy a server on Jenkins. Alright guys, so this is how my AWS server looks like. So what I have to do is I have all the commands written over here in my notepad. So let me copy these commands. The first command will basically install OpenJDK 8 on my system. So let me do that. Okay, so it's unable to update. Reason is we haven't updated. So let me update the system first. Sudo apt get update, and once that is done, I'll install OpenJDK 8. Alright, so now it's installing OpenJDK 8. Next step would be to copy this command. This will basically add the Jenkins key in the repository. So let us do that. All right, so this is done. The next step would be to install this command. All right. So this is our next command. This would basically add the binary of Jenkins to this list. And now we're going to update. So our repository links gets updated. And now let's install Jenkins. Alright guys, so Jenkins is installed. So first of all, let's check the status for our Jenkins service. So for that, we can check it using service Jenkins status. Alright, so the Jenkins service is active. So our next step would be to open the ports of the EC2 server. So let us do that. So the inbound connections. Let's open all traffic to be on the safer side. If you want to be more secure, kindly open port 8080 because that is what Jenkins operates on. All right, and let me click on save. All right, so this is done. So now what I'm going to do is I'm going to come back to my dashboard. This is my Jenkins master. Let me copy the IP address, and this IP address I'm going to use with the port 8080 to open Jenkins. So as you can see, the Jenkins dashboard is now visible. So the first time you install Jenkins, you'll have to enter the administrator password, which can be obtained from this path. So what I'm going to do is I'm going to go to this path and I'm going to cat over there. So this will basically, so let me do a sudo. So this will basically give me the password, and let's copy it and paste it over here. Continue.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous delivery and monitoring. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And now Jenkins is booting up. So the first screen that you would see is customize Jenkins. So let's install the suggested plugins. This would basically install all the plugins that we would require for today's session. So once you have clicked over there, your plugins will start to install. And we're going to wait a while till this finishes. All right, our next screen is going to ask us for adding a user. So let us do that. Let's give the username as Intellipaat, password as Intellipaat. Once you've filled out all the details, let's click on save and finish. And this would bring you to your Jenkins dashboard. So you would get the Jenkins is ready page and just click on start using Jenkins. Alright, so this is how your Jenkins dashboard looks like, and we're going to come back to this, but before that, let's just go back to our slides. Alright, so guys, we've successfully installed Jenkins on our system. Our next topic would be to understand the Jenkins master-slave architecture. Alright, how does Jenkins work in the production environment is what we're going to discuss over here. So the Jenkins master-slave architecture is basically important to accomplish continuous integration. Reason being, your testing will always happen on the testing server, and your production code will always be deployed on the production server, right? So you always have to deal with multiple machines when you're working in a DevOps environment, and that is exactly why you need Jenkins master slave. So for in this kind of situation where you have to deploy your code to the testing server, Jenkins becomes your master server and your testing server becomes your slave server for Jenkins, right? Similarly, your production server would become slave server for Jenkins, and the master Jenkins will only have the Jenkins installation. Jenkins will not have to be installed on any of the other systems which are serving as the slave of Jenkins, right? The third thing is, why do we need a master slave kind of scenario? So I've seen a lot of people basically just use Jenkins on the same computer where they have to deploy the code as well, and that is because they are not dealing with probably parallel jobs of deployment, or they're not dealing with complex builds, and that's the reason they have it on the same machine. But when you're working on the production environment, you have to have a master slave kind of an architecture, wherein the testing and the production server would become slave for your Jenkins master. All right. So now what we're going to do is we are going to set up master slave on AWS, and let's see how we can do that. All right. So the first thing that we have to do is deploy two servers on AWS, that is slave 1 and slave 2, and then we connect it to Jenkins using the JNLP connection. So let's see how we can do that. So the first thing that I'm going to do is let me jump onto my EC2 management console and let me create two slaves. By specifying the number over here, that is 2. So we're going to launch the instances. So our instances are launched. Let us rename them as slave 1. And we have our other, which is slave 2. Now, mind you guys, we will not be installing Jenkins on either slave 1 or slave 2. We will be controlling these slaves through the Jenkins master. Now, there are some settings that you'll have to do in your Jenkins master. Let us go through that. So the first thing, so this is your dashboard. So the first thing that you have to do is you'll have to go to click on Jenkins and go to manage Jenkins, go to configure global security. Once you're here, just scroll down and you will reach this section which talks about agents. Now over here we are talking about TCP port for JNLP agents. Just change this to random and click on save. Once you've clicked on saves, now we will go to manage nodes, and now we will add a new node. Let's name this node as slave 1, and now click on permanent agent and click on OK. Now over here you will have to add the launch method. You'll have to change it to launch agent via Java Web Start, and the current working directory path, specify that to /home/ubuntu and /jenkins. All right, just specify this and click on save. You will reach this screen. So I'll tell you what to do after this. For now, let's add one more new node. Let's name it as slave 2, and we'll copy everything from slave 1 and click on OK. All right, so everything is the same. So the remote root directory would be this /home/ubuntu and then Jenkins. All right, so slave 2 is also configured. Let us check what we can do now. All right, so the next thing that you have to do is now click on slave 1 and download the agent.jar by clicking over here. All right, so your agent.jar is now downloading. I had one before, so just ignore this thing. So this agent.jar is now downloading, and now I'll have to send this file to my slave 1 server, and I'll show you how you can do that. Right, for now, just click on show in folder, remove the older agent, rename this as agent. All right, and now we'll have to send this to our slave 1, and the way we can do that is by first selecting slave 1, take the IP address from over here. You'll have to download a client called FileZilla. Just open that. In FileZilla, paste the IP address over here. Username would be Ubuntu for the Ubuntu operating system. Port is 22. And in the settings, you'll have to click on edit and then click on settings. Go to SFTP and you'll have to add the key file over here. I've already added that. Just click on add key file. Just go to your key file, select that, click on open, and it'll be added over here. This is important to connect because when you're connecting to AWS, the only method that you can connect to is using your PEM file or your PPK file, and this is the way you can add it in your FileZilla browser. All right. So once you have added that, just click on Quick Connect, and now you will be connecting to your slave one. So once you're connected, you will be given all the directories. So here are all the directories. Now I'll have to copy my agent.jar on my slave one. So just click here and it'll copy your file to slave one. Okay, so let us also verify that if our slave one has been copied or not. So let us connect to our slave one. So we'll connect it using this IP address. Let us go to putty, click on new session, connect to slave one, and let us give a special appearance to this. Let us decide a color on this. So let us decide the orange color. So the orange color is slave one. So let's click on OK and let's click on open. All right, so login as Ubuntu. Great. So now if I do an ls, I can see that agent.jar has been successfully copied. All right, so slave one is done. Now we'll have to do the same thing for slave two. So let us go to slave two, download the agent.jar. While it's downloading, just copy the IP address for slave two, enter it in FileZilla so that we can connect to it. All right, click on Quick Connect. So you will have the directory listed over here. All right, now we'll go here and we'll rename our agent1.jar to agent.jar, and the way we can do that is like this. So we'll just go here, rename this, all right, remove the older agent file and rename this to agent.jar. Once that is done, just drag and drop it on the server. And now let's connect to slave 2 using putty. So let's click on new session, SSH, add the file, and let us keep the color for this slave as white itself. All right. So this is slave 2, and if I do an ls over here, it's the agent.jar file has been copied successfully. All right, so now the next step would be to basically go to your slave and you'll have to execute this particular command at the place where your agent.jar is present. All right, but before executing this command, we'll have to install OpenJDK on both these servers, that is slave 2 and slave 1. So let us do that. So here's the OpenJDK command. Let us pass it over here. So we'll have to update the server first. So let us update it. All right, and now let's pass the command. All right, so while Java is being installed over here, let's do the same for our slave 1 as well. So let's update it first. So it's updated, and now let's install OpenJDK. All right. So while Java is being installed on this, I think we are almost done on our slave 2. All right. So slave 2, the Java is installed. So what I can do now is I can go to my Jenkins page and go to slave 2, and I can run this command over there now. And this is it. The moment you run this command, can you see it says connected? And the moment it says connected, just come back here, refresh the page, and your slave 2 is now connected. Let's do the same with our slave 1. Just copy this command, go to your slave 1, let's clear the screen, and paste this command. All right, so now both the slaves are connected to your AWS Jenkins server, and you're set. So if you see the nodes, you have a master now, you have slave 1, and you have slave 2. And this is what we were supposed to do. So let me come back to my slides. All right, so we have successfully set up Jenkins master slave on AWS. Our next task is to basically create a pipeline which would be triggered by Git webhook to deploy a project on Jenkins. So let us do that. So for that, these are the steps that we'll have to do. So basically we have a project. I've created a project on my GitHub repository. Now this project has a Dockerfile, and this Dockerfile can be built to basically deploy a website on Docker. All right, so we're going to deploy a website on our slave 1 first, which will basically act as our testing server. It will be pseudo testing kind of a thing, right? And if our website is successfully deployed on our test server, that is slave 1, it will then get deployed on slave 2, which will be our production server. So this is basically our job, and this should happen automatically. So a Git webhook basically means that the moment I commit on Git, it should automatically trigger a job on Jenkins. It should automatically deploy the website on my website on my testing server first. If it gets deployed successfully, then it should move forward and deploy the same on my production server. All right, so this is what we are going to do. So let us quickly go to our GitHub website to see how our code looks like. So basically this is my code, guys. I have the Docker file, I have the website in here. Docker compose, please ignore it, we're not going to use it. So we're going to use the Docker file. The Docker file code looks something like this. So basically this is a container which it's going to pull, and after pulling the container, it is going to add the DevOps IQ folder inside the var www.html DevOps IQ directory. This is inside the container. All right, so this will get deployed inside my server once I trigger it from Jenkins. Now to do this, first we have to install Jenkins on both the slaves as it is mentioned in the steps. And like it says, like we'll have to configure it in a way that if the build on Jenkins slave 1 is successful, then it should be built on slave 2. Once it's done, we should finally trigger the job using Git webhooks. All right, so let's do this, guys. Let's go ahead and start with the demo so that let's see how it can be done. All right, so the first thing that we're going to do is install Docker on both the slaves. So let us go to our putty terminal. Let's go to slave 1 first. Now remember, guys, you will have the connected state over here. Do not close this terminal, otherwise your connection will stop. So what I'll do is I'll just minimize it and I'll duplicate the session so that I can work in a different terminal. All right, so the first thing that we have to do is install Docker. So let's do that. Sudo apt get install docker.io. Okay. So Docker will start installing now. So while Docker is installing over here, let us do the same on slave 2. So just duplicate the session and go to Ubuntu. Now install Docker. All right, so Docker is being installed on slave 2. It has installed on slave 1. Let us check. So docker -- version, if we can do that, that means Docker is installed. Yes, so Docker is installed on slave 1 and is installed on slave 2 as well. Let's check. So sudo apt sudo docker version. Okay, so Docker is installed on slave 2 as well. Awesome. So our first job is done. We had to install Docker. Now our next job is to configure Jenkins to build the project on slave 1. If successful, should be built on slave 2. So for this, we will have to go to Jenkins. So Jenkins is over here and we'll have to create a job. All right. Now you can check the status of your slaves over here. So you can see that master is idle, slave is also idle, and slave 2 is also idle. Now first, let's create a job for our slave 1. So our slave 1 basically will have a pre-style project, and let us name slave 1's job as slave 1. So or let's name it as test. Okay. And then click on OK. All right, so the job has been created. Now the first thing that we had to do was to copy our code to the workspace. So let's just clone our repository or mention the repository link over here and by clicking GitHub project. Okay, and then go to source code management, click on Git and mention your repository over here as well. Now because this job has to run on slave 1, we'll have to restrict where this project can be run and select slave 1, right? So slave 1 is job, and slave 1, once you select slave 1, this job will only run on slave 1. Okay, once you have done with that, the next thing that you would have to do is come down and click on add build step. But before doing this, let us check if my job is being built or my workspace is being populated by the Git repository content if I build this job on slave 1, right? So this would basically test our connection as well. So let's do that. So let me click on build now, and this will basically start a build wherein it will copy the Git content on slave 1 ideally, right? So the blue ball basically tells us that the job has completed successfully. So let us click over here. And I can see that, it has been successfully been finished. So let us verify that. Let's go to slave 1. And if I do an ls over here, great. So I can see the workspace is there. Let me go inside workspace. All right. So inside workspace, let us see what do we have. We have test. So this is the job name. Awesome. So if you go inside test, do we have the Git repositories content? Yes, we do. All right. So my Git repository was successfully cloned into the test job. That basically means from my master, I'm able to build a job on the slave 1 node, which is great. So that basically means our connection is working fine. Awesome. So let's go ahead and go back to configuring our job, right? So what we want to do is we want to deploy the website which is mentioned over here in this repository to my project. Now the way to do that is by running this Dockerfile, right? For running this Dockerfile, I'll have to check what is the present working directory. So my present working directory is this. So let us copy this. And once you come back to Jenkins, you'll have to scroll down and click on add build step. Once you click on add build step, click on execute shell. What will execute shell do? So execute shell is basically used to run any commands that you want to run on the terminal of the other machine that you're trying to build on Jenkins, right? For example, we are trying to build on slave 1 from Jenkins. So what commands do we want to run over there? So I want to run docker build command. So I say docker build and then docker build and then the repository where the Docker file is. So it's over here. And then the name of the image that I want to give. So the name of the image would be, I want to say it's test. Okay. So this is the image name. Once the image is built, I'll have to run it. So let's run it on port 80. No, so let's run it on port 82. And then let's run the image like this. So this is the command for running the Docker image that you have just built, right? Once it's built, the next step would be to check whether it's there or not. We can do that on the browser. And I forgot one thing. I'll have to add sudo And because this job can be built time and again, what we'll have to do is we'll have to remove the older containers which are running on the system, right? So for doing that, I can say that sudo docker rm hyphen f, and for removing all the containers which are running, I'll have to pass in sudo docker ps hyphen a and hyphen q. This should delete all the containers which are running inside my slave one. Now to check if my Dockerfile is building my containers or not, what we can do is we can simply copy the commands from over here. So the first thing that I want to do is I want to build it. Let's build my Dockerfile. So the file is now being built. Awesome. So it's been built. The next thing that I want to do is I want to check if I want to run this command, right? So for running it, the command is this. Let's copy it, paste it over here, hit enter, and my container is now running. So I'll have to check that if it's running or not. So I'll go to slave one, copy this, paste it over here. So, and port number is 82. So I can see the Apache page. That means the container is working. Let's check if our files are being showed or not. So if I go to DevOps IQ folder, yes, I can see the website. So means these commands are running fine. But what I have to do is I have to check if it's running through Docker or not. So I have configured the commands over here, and these commands work on the terminal. They should work over here as well, right? So let us go ahead and save this. Okay, so our job has been saved, and the next thing that I would do is let me remove all the containers which are running over here. So for that, I'll have to do sudo docker ps. Let me remove this container. So the container is removed. Now let's go ahead and run this container, run this job. All right, so now let's go ahead to our Jenkins dashboard and let's build the project now to see if everything goes fine. So I've clicked on build now. All right, so it gives me a failed build. Let's see what the problem is. So the problem is over here. It says the first command sudo docker ps -a -q docker I'm require at least one argument. Okay, so I've got the problem. So the problem is there's no container running over here as of now, right? And that's why it is not able to remove any container, and that's why it is giving me this error. Okay, to solve this, what we can do is for now, let's in the configure part, let us just remove this line, or what we can do is we can start a container over there, right? So let's run any arbitrary container, docker run -it -d and then ubuntu. Let's run it so that there's a container running, because ideally there will be one container running at least on my system. So let's click on save, and now let's try to build the project. Okay, so the build has gone successful. Okay, for checking that, I'll say let's just refresh this, and yes, my website is being deployed over here. Awesome.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the popular scripting language of DevOps? A. Java, B. Python, C. HTML, D. C++. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So let me just do it one more time so I'm sure it's working. So let me just do a docker ps. sudo docker ps, and let's remove this. Sudo docker rm-f, remove this, and now let's run our arbitrary container. Let's ensure that this website is now not working. So it's not working. Now let's rebuild this project. Alright, so now if I come here and I refresh this, yes, so the website is working successfully. Awesome. So it works on slave 1. Let us now configure the same thing in slave 2 as well, right? So let's come back to our dashboard. So the test job, this could be our arbitrary test job. So basically we are trying to deploy it on a server. If it gets deployed successfully, we are going to deploy it on the prod as well. So let's create a new job and let's name it as prod. Freestyle project, click OK. And the GitHub project is going to be the same, this one. Let's paste the URL over here. And we have to restrict this to run on slave 2. Great. The source code management is this Git repository. And the build step also would be the same. So basically we want to delete all the containers which are running right now. So for that, it's sudo docker rm-f $docker ps-a and -q. Okay, next step is to build the file. So do sudo docker run -it -p, and we want to run it on port 80 because it's production, right? And the image name is test -d and test. And before this we forgot one command, which was sudo docker build, and then the directory, which is /home/ubuntu/workspace/ the job name, which is prod, and then over here the Docker file would be present, and I want to name it as say production. The container name would be production, and over here also the container name would be production. Awesome. So let's click on save, and let's now try to build it. But before that, we'll have to launch one container on test. So let's run an arbitrary container. All right, so container is ready. Now let's check by clicking on build now if this job is working fine. So I've clicked on build now, and if you want to see the console output, we can see it over here. Okay, so it says job failed, and the reason for that is got permission denied. Okay, so the problem is I forgot to add sudo. So let's add sudo. Let's add sudo over here, and that should be it. Let's click on save and let's try it again. Okay, again we have a problem, but I think it's a new error, so let us try to resolve that. So it's unable to prepare context, and the path is /home/ubuntu workspace and prod not found. Okay, so let's check if this path exists. So if we do an ls, we have Jenkins. Okay, let's go inside Jenkins. If we do an ls, okay, so workspace is over here. So basically I'll have to change the path to /home/ubuntu/Jenkins/workspace/prod -t and then production. Click on save. Let me check if there is a container running on my slave 2. If there is no container running, then I'll have to run one. So sudo docker run -it-d ubuntu. Okay, container is running, and let us also ensure that we do not have any website running on our slave 2. Okay, so this is the command that we are getting right. This is the output that we're getting right now. All right, so let's click on build now and let's see if our build is successful.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now, let's continue with the session.
All right, so it's getting built. Let's hope for the best. Let's hope it's successful. All right, so it gives us a blue sign. Blue means that build was successful. Let's try to refresh over here. And yes, it works. Now let's just go to DevOps IQ folder and see if our website is up and running. Yes, so our website is up and running. Awesome, guys. Now what I want to do is I want to trigger. So first I want to trigger prod job only when the test job is completed. Now let's see how we can do that. So we'll go to configure and let's see if we can configure this. All right, so I'll have to go to test job actually. Let's go to the test job. Let's go to configure. And over here, I'll have to go to add post build actions. Okay, let's click on that. And after this, we'll say build other projects. Click on that. And which project to build? I want to build prod. And trigger it only if the build is stable. So if the build passes, only then it should start with prod. Okay, awesome. Great. So let's click on save. And if my test gets succeeded, then my prod job will run. All right. So let us check this as well. So let me try running it. So we can run the test job using a pipeline view as well. So if you just have to come back to the dashboard and over here you'll find both your jobs. Just click on the plus sign that you see over here. And once you click on the plus sign, you should be seeing a build pipeline view option over here. If you're not, so that means the plugin is not installed. So let's install that plugin. For that, you have to click here, go to manage Jenkins, and then click on manage plugins. Click on available, and then search for build pipeline. Build pipeline, select it, and then install without restart. Just click on that. All right, and now your plugin will start to install on your Jenkins server. All right, so my build pipeline plugin is installed. Let us go back to our dashboard, click on the plus sign, and you can see there's an option now which says build pipeline view. Select that and name this view as CI/CD or anything that you want, right? Click on OK. All right. Everything seems fine over here. Build pipeline view title, let's name it as CI/CD. Okay. Let's click on OK. All right, let's check. So in my CI/CD view, I just see the prod job. So let's see how we can fix that. So I want the test job to also be there. So let's see. So let's click on configure and build other projects after the test is done. Okay. Okay, so we forgot to choose the initial job. So the initial job will be test, right? And let's click on OK. Okay, so now it looks good. So the test job will be executed, and then we'll have the prod job executing. Okay, let's try running these jobs by clicking on run. All right, so as we can see, our test job started and then our prod job started and it completed. So this completed in 1.5 seconds and this completed in 1.5 seconds as well. And both of these have these websites. Awesome. Now what I want to do is I want the moment I commit on my GitHub, this should trigger my Jenkins job. So for doing that, let's go over here. That is my Jenkins dashboard. And let's try doing that with test. Okay, so we'll click on test and we'll click on configure. All right, and yes, so in the build triggers option, just go to GitHub hook trigger for Git SCM polling. All right, and just click on save. The moment that's done, just come back here on your GitHub. So for configuring your webhook, all you have to do is click on settings and click on settings, go to webhooks. Inside webhooks, click on add webhook. And now just copy the IP address and port number of your Jenkins dashboard or your Jenkins page and paste it over here /GitHub -webhook. Specify that and click on add webhook. If the response is received by Git and everything works fine, it will give you a tick, which means everything is working fine, right? And just go back to your dashboard and you can see that everything works out. Great. Now, what we have to do now is we'll have to push a commit on GitHub and that will automatically trigger a build over here. So let us check that. So we'll just open this over here and we'll go on our master. Let us trigger a build. So this build can be triggered from anywhere. I'm just doing it on master for the sake of simplicity. So I'll just do a git clone of your repository. Git clone. All right, everything is done. Now I have something on my I have a website, right? So what I'll do is I'll change the contents of that website and let's see if that content is visible on our servers as well. So I'll just change the index file. The first thing that I'm going to change is the title. So I'll change this as Jenkins prod website. Okay. And let us change the image as well. So I have one more image over there. So let's name the image as 2jpeg. Great. So now let's push this on Docker Hub. So let's add it, commit it. All right, and let's push it now. Git push origin master, the username, and the password. All right, so the push has been made. Let's check if anything is triggered over here. So as you can see, the test got triggered and now the prod also got triggered. So both the jobs have been successfully completed just on a push. Let's verify that. So this is my, so let me see which one is my slave one. So slave one is 108. So let us see. Okay, so this is my slave one. Let us refresh this and see which website is coming. As you can see, the background got changed, and as well as the title also got changed. Similarly, if this job is successful, it should also be triggered over here. Let us check if the website is also pushed here, and yes. So the job is also pushed here. Awesome. So let us try this one more time. And with this, let us try to bring back the same background that we had, right? So let's do a nano on index.html and let's change the title to Jenkins final website, and let's change the image name to 1.jpg, which was the earlier image. Save it. Now let's push it on GitHub. So we'll add it, commit it, and now let's push it. All right, so our code is now being pushed. It's been pushed. Now let's come here and see what is happening. So our job should now be running. So test got completed. Prod is being completed. So prod is running right now. And prod also got completed successfully. Awesome. So let's check if our website got changed over here. So this is my testing server. So the title got changed and even the background. Let's see for our production, and even our production website got changed. So awesome, guys, we have successfully completed what was asked to us in the hands-on. So we were supposed to create a Jenkins pipeline, which would basically, if slave one job is complete, it should be built on slave two, and the job should be triggered by a Git webhook, and that we have done successfully. Alright, so why do we need Kubernetes? So to understand this topic, let's go ahead and understand how our applications were designed before, right? So this is a sample monolithic application, guys. And this is exactly how our applications used to be coded in the past, right? A monolithic application is nothing but where all the features of the application are consolidated into one code base, right? For example, let's take this sample application to be Uber. Right? So you have features like location services, then you have customer service, notifications, mail, payments, and passenger management. Right? All of this is part of one application that you have in Uber, right? But now when you click on notifications in your Uber app, what your application basically does is it contacts the server, and basically you get the notification from the server to your application. So your application is basically reflecting whatever it is getting from the server, right? Now, earlier, all these features used to be on one server, right? For example, if my application has to reach or stream notifications, it will reach out to the same server, and if I have to call the customer support, that API query will also go to the same server. Right now, this might seem okay to you, but this caused problems. Reason being, first of all, this is all in one code base, right? So if I have to do any update to any part of this application, for example, if I have to make changes in passenger management, the way we work with passenger management, I want to change something in that code, I want to update something, right? So for that, I'll have to work in the same code base where my mail is, where my notifications is, where my customer service is, and chances are highly likely that some of these functions may stop working or may malfunction based on the changes that I'm doing in my passenger management, right? So there were a lot of dependency between all the features of this application, reason being it's in one code base, right? They're not interacting using JSONs, they're not interacting using some other communication, they're interacting within the code, right? And this caused a lot of dependencies. So say for example, tomorrow my passenger management code fails, so that would lead to all the features will lead to basically failing, reason being all of them are dependent on each other, right? And this was solved by using microservices. Now what was microservices? In microservices we basically decided that all the features should have different code base and should be deployed separately. Now my customer service is deployed separately, it's in a separate code base. My notifications have been deployed separately, it's in a separate code base, and all of them they interact using JSONs, right? So if they have to communicate with each other, they'll have to send each other some files or encoded message which the other service will decrypt, and then it will try to read it, and any response which has generated it is again sent to the other service using that same mode of communication, right? So now there were no function calls between these services, it was only API calls that is using JSON that these services were interacting with each other, right? But the problem is now how to deploy these services. Where will I deploy these services? One way is that, say, my customer service module I deploy on one computer, my notifications would be on the other server, my mail service would be on some other server, and similarly, if there are 5 features that are listed over here, there will be 5 different servers which will be serving each services request. It sounds cool, it sounds very distributed also, but when it comes to scaling, it becomes a problem. Reason being that my customer service, the customer service module might not require that much of power that is there in one server, right? But still my customer service module is occupying the whole server and I cannot deploy anything over there. So downscaling it became a problem, right? Upscaling is no issue, you can also upscale it, but upscaling would also cause the same problem, that is, say your server is able to handle 10 replicas of your customer service module, or say let's your customer service module is being bombarded with requests and it peaks your CPU to say around 85 to 90% of its usage. Now what will you do? If you have deployed this application on some cloud, your cloud will basically deploy one more server which will have exactly the same service, and now the request will be divided between the two servers, right? But again the problem is that on the second server, because just the customer service your module is running, it might not be able to utilize the full server, right? It will always be underutilized. So this was a problem that we had to solve, and we solved it using Docker. Now how did we solve it using Docker? Now Docker gives you a separate environment, right? So we deployed services on different servers because we wanted them to be totally independent of each other. They should not have any dependency on the other features environment, right? So what we did, we all Dockerized these services, and now all these services could exist on a single computer, right? But at the same time feel that as if they are on different computers. So your application in that case will only be down when your computer or your server as a whole fails, right? Still your applications are independent of each other. For example, your customer service could be running in a Red Hat Docker container, your payments could be running inside a ZS Docker container, your mail could be running inside an Ubuntu Docker container. They all could be different and they all could be running on the same system. So this solved the problem of underutilization or scaling, right? So upscaling is also okay. So if I feel that passenger management is being overutilized and it's causing a spike in my CPU, what I can do is I can probably deploy one more instance of passenger management, or one more container of passenger management, and the request will then be routed between the two. Also, if my passenger management is not working properly, what I can do is I can shut down passenger management, I can deploy one more container on it, and this will not affect the other application or the other features of your application, right? So with microservices, what you get is zero downtime, right? You get a chance to update your application without causing a problem to the other services, and many more, right? So when we got a Dockerized kind of a scenario, we were like, okay, so things seems to be okay now. But now again, the problem was that how do we monitor these containers, right? So if there are like 300 or 400 containers running, how do I assess which container is running fine? What is the health of a container? Say a container goes down, how do I automatically deploy one more container on it? So this orchestration of containers was a problem, and this is where Kubernetes came to our help. Right now, there are many container orchestration tools, and all of them perform differently based on the kind of features they have. Kubernetes has the most number of features which are essential for basically doing container orchestration. Natively, Docker also gives you Docker Swarm, which you can use to do container orchestration. But personally, I feel Kubernetes has way much more features than Docker Swarm, and that is the reason we're discussing Kubernetes today, right? And most of the industries today are also using Kubernetes for the same reason, that it gives you a lot of flexibility in terms of what you can do with your application. So because your containers were in large number and you had to do monitoring, we came up with Kubernetes. So if Kubernetes was not there, what were the problems? Let's discuss that. So each service, which that is the each instance of a feature which is running, it became difficult to monitor it, right? Scaling a particular feature also based on load was not possible. Reason being that you could not automatically monitor it. You had to keep someone monitoring your usage of the containers, and if they feel that your container is being overutilized or your container has died because of some reason, then in only in that case it was manually updated, that let's launch a new container and let's scale down the other container, or let's delete the other container. So because of this, like I said, there was too much manual intervention which was required from the programmer's end. Also, if you felt like I told you that all of this existed on one server, right? So the only way that your application will be down is when your server is down. So we had to mitigate this. So if we deployed containers on multiple servers, now to manage or to know how many containers are running for a particular service on multiple nodes also became a problem, right? And there was no way we could solve it without a tool which could basically orchestrate the containers for us. And this is exactly where Kubernetes saves us. So what is Kubernetes? So I think we have discussed most of it, but Kubernetes is nothing but a container orchestration tool which is used by our application to to basically monitor or orchestrate multiple containers. The kind of features that it gives us is monitoring. It helps us monitoring containers, it helps us scaling containers, it also helps us restarting containers if any of them fails, and this all happens automatically. There is no manual intervention required for this, right? And this is what Kubernetes is all about. Now, what are the features of Kubernetes? So we discussed some of them, like it could monitor it, it could scale it, but let's just come more about it in detail, right? So the features of Kubernetes include the first one being that managing multiple containers as one entity, right? So if you have 400 containers which are running, which probably have 5 features running on it, you will only see those 5 features. You will not see how many containers are running behind it, right? I mean, you don't have to worry about the number of containers running behind it, because Kubernetes automatically it takes care of the health monitoring and scaling up of your containers, right? You only have to worry about what kind of services you want to launch. Is if there is a new feature that you have to include in your application, all you have to do is launch a new deployment which will basically have those feature and the number of containers that you want for that to be supported with. You just have to specify the number, and Kubernetes will automatically take care how it deploys it in the backend, right? So managing multiple containers as one single entity became very simple for us after Kubernetes. Resource usage monitoring was also solved by Kubernetes. So with Kubernetes, what you can do is, for every container which is running, you can basically define how much of your computer resources it is going to utilize, right? And the moment the container utilizes more resources, what Kubernetes does is it deploys a new container, right? And that is how it basically does resource usage monitoring. Then we have networking. So networking is a fantastic feature in Kubernetes, wherein all the containers which are deployed on the Kubernetes cluster basically can interact with each other as if they were on one system. But they could be on 100 nodes or 200 nodes or 300 nodes, but still they can interact with each other irrespective of the fact that where they exist on the cluster. So that is also a fantastic feature. Then we have something called as rolling update. So if you want to update your application, you have the option of doing a blue-green deployment using the rolling update feature. Then we have something called as load balancing, right? So all your containers, if there are multiple replicas of the containers which are running inside your cluster, you can automatically load balance among these containers based on the request, right? That is also a feature which is there in Kubernetes. You have health checks, right? So health checks basically means if your container is not running as it was supposed to run, or say it is down, or the service itself is down, Kubernetes will take care to redeploy the container so that your service is always up, right? So you will never notice any downtime when your container is running inside Kubernetes until and unless there's some problem in the code, right? If your code runs fine, everything is going to run fine in Kubernetes. Moving forward, now let's discuss about how Kubernetes actually works, right? So Kubernetes, like I said, it's basically a cluster. So you have a master and then you have several nodes inside the master, right? The job of the master is basically to schedule containers on the nodes which are under it, right? Monitor the nodes, monitor the containers which are running inside each node, and also keep a track of the logs of what operations are being performed on each container, right? So basically the master plays an important role here of monitoring everything, of scheduling everything, while the workers or the nodes do the job of processing with whatever is required in your application. If it's processing, if it's sending API calls, it could be anything, and that is handled by the nodes. But Kubernetes is running on both the master and the node, right? And basically it's the same software running everywhere, and they can interact with each other as if they were one whole system, right? It is also very easy to add more nodes to the cluster, to an existing cluster. It can be done in a jiffy. All you have to do is just, there is one command that the master gives you once when it's initialized. Just save that command, and whenever you want to attach a new node to the cluster, all you have to do is first install Kubernetes on it and then run that command, and your node will automatically get joined with your Kubernetes master. Right? So this is how Kubernetes actually works from the outside. Now let's understand how it works from the inside by understanding its architecture. Alright guys, so the first thing in Kubernetes that you will deploy is a pod, right? A pod is nothing but a container. But the difference is a pod can have multiple containers as well, right? And that is the case when, say, your application is deployed in a container, but it also needs, say, a separate container to run along with it, right? For example, if you have a PHP container and your files are in a different container, then basically these two containers cannot work without each other, right? Your files needs the PHP container, and your PHP container needs the files to basically give you the website.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous delivery and monitoring. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So these two containers are bound together. They are supposed to work together. And for those very reasons, we have pods. So usually pods have a single container, but like I said, there could be a situation where you have a container which cannot exist without the another container. And in those cases, you deploy multiple containers inside a pod, right? But for the sake of simplicity, you can understand that a pod is nothing but a container, right? So this is one single pod, this is a second pod, and this is a third pod. So basically we are deploying three containers of the same application, right? For example, I want to deploy a website on Kubernetes, right? Let's assume that. Now, when I'm deploying the website, I have an option of specifying how many replicas of my website do I want to run on the cluster. So that if one container goes down, my application doesn't go down, my traffic is automatically redirected to the second container or the third container, right? So for those reasons, you basically specify the number of replicas that you want for your application, right? So this is the simplest entity in Kubernetes, that is a pod. So you deploy a pod, or you deploy a number of pods by specifying it in the deployment, right? You can deploy a pod or you can deploy a deployment. Now, what is a deployment? A deployment basically takes care of the number of pods which are running inside Kubernetes, right? So what you do is basically you create a deployment which automatically creates pods for you. But while you're creating the deployment, you specify which image in the container do you want to run, and how many instances of your container you want to run, right? That is, I'll specify the number of replicas, and I'll also specify the image of the container in the deployment, and my deployment will automatically take care that my number of containers are running on the number of I specified while creating the deployment. Also, the image that I've specified is present inside each pod, right? So this is what a deployment is. So to summarize, a deployment basically deploys the number of pods that you want and the kind of image that you want in that pod. Okay, so this is a deployment. Now, if a user, our understanding that we want to gauge from this particular slide is how a user or how a person like me who is using our application will be able to access the application which exists inside your pod, right? For example, if you go to Intellipaat.com, how will Kubernetes serve your website to you, given that the Intellipaat website itself is inside a Kubernetes cluster, right? So as a user, you basically will be going to a URL, and that URL will be pointing to the server, which will basically have your application. So in this case, the deployment exists on any node on the cluster, and therefore you would not know which node do you have to contact on. So in Kubernetes, what happens is any application that you deploy can basically be accessed through any of the IP addresses that is there on the cluster. For example, if there are 4 servers, 1 master and 3 nodes, any of the IP addresses of the master or of the nodes would give your way or give you access to the application, right? So in your now, for example, if I go to Intellipaat.com, Intellipaat.com can point to any of these IP addresses. That is my choice, what I want my domain to point on, right? That is my choice. But irrespective of the fact, any IP addresses that I go on, I'll be able to access my deployment. But I cannot access my deployment directly. What I have to do is I have to have a service that I'll be accessing. Now, what is a service? A service is basically an internal load balancer for all the pods which are running. Now, the problem statement was, if there are 3 pods which are running inside my cluster and which basically are hosting the same application, how would the user know, or how would the cluster know where exactly should this user end on, right? Should his request be routed to pod 1 or pod 2 or pod 3? Because all of these have the same application. So my user doesn't care which pod is serving his request, but how does the cluster handle this request? For this reason, in front of every deployment, you have a service. And service does nothing but exposing the deployment to the outside world, right? So this service automatically load balances the requests coming to it randomly, right? So not randomly, basically if you are sending a request for the first time, if yours is a first request that the service is receiving, it'll probably send your request randomly to any pod. But as and when more and more requests comes in which are concurrent in nature, right, then service decides whichever pod is more free will get more requests, right? So basically, service is nothing but an internal load balancer which will be catering to your request. So the moment you send you want to go to Intellipaat.com, it will basically point to an IP address, and that IP address would point to the service, which will basically internally load balance your request to any of these pods which are available over here. Okay, now the question is that, say I want to go to intellipaat.com/blog, right? And when I want to go to intellipaat.com, how would it differentiate where exactly my application is, right? So for example, if I type in intellipaat.com/blog, it should basically go to the blog page, right? If I go to intellipaat.com, it should basically come over here. And there comes the problem of having multiple services. So say this is my blog service and this is my website, I mean my homepage, right? Now how will a user know that which service to go on? Obviously for a user, the only way he can interact is a URL, right? So say he goes to intellipaat.com/blog. Now how will the cluster know where exactly to send his request, right? For that we have something called as an ingress. So what an ingress does is, based on the request which the ingress is getting from the user. For example, if the ingress says that this user is requesting for intellipaat.com/blog, so what the ingress will do, it will basically send the request to this service. If it sees that the user is requesting intellipaat.com, it will send the user to this service, right? And basically this has the blog application in it, and this has the homepage application in it, right? And this is how basically internally your Kubernetes works. So your user would send a request which would go to an ingress, and the ingress will decide based on the path that the user is requesting which service to send the request to, right? Your cluster can also not have ingress. In those cases you might not have multiple exposed services on your cluster, right? In those cases you will not be requiring ingress, but in cases when you have multiple exposed services on your cluster, in that case you always have to use an ingress, right? So basically this is a summary of how Kubernetes works internally. Now let's go ahead and do some hands-on to see how actually we can implement what we just learned. Alright, so before starting the session, I would just like to tell you guys, if you guys have a cluster on Minikube, if you have a cluster on Google Cloud, AWS, anywhere if you have a cluster, all the commands that we're gonna run right now are gonna run the same, right? Most of you guys must be working on Minikube. What I'll be doing is I am basically working on an installation on AWS, right? So I'm not gonna discuss how do we set up the Kubernetes cluster in this session. Probably I'll add a new session for that where I'll discuss different ways you can set up a Kubernetes cluster. In this, I've already set up a cluster. So let me just quickly go to the terminal to start with our hands-on. Alright, so our terminal is here. Now over here, the cluster is up and running. Now the way you can see that the cluster is up and running is by checking the number of nodes that are joined on the cluster, right? So for that, if I type in kubectl, which is basically kube control. So the kubectl is the command with which you control the whole Kubernetes cluster. So the first thing that I want to see is the number of nodes which are running on my system, right? So the number of nodes running on my cluster are kubectl get nodes, and these are the two systems which are there in my cluster. This is basically my master. So all my applications will be deployed on this. That is my worker node, right? And both of them are in the ready state, right? Now you can also see what all pods are running on your system. To see all the pods which are running on your system, all you have to do is type in kubectl get pods and then -- all namespaces. This will basically show you all the pods which are running throughout your cluster, right? And if you want to see where exactly your pod is running, so all you can do is just go again here and type in -o wide. Right, so here are all the pods which are running on your cluster, and some of them are running on one node, some of them are running on the other node. Your master is basically 172.31.44.86. So all the 86 IP addresses that you see here are running on the master. So this pod is running on the master and this pod is running on the worker. right? Then you have IP addresses like this, wherein you have 192.168.1.2. All these IP addresses are basically the IP addresses of the container. So like I told you guys, Kubernetes works off their own network, right? So if one container on or one pod of your cluster wants to interact with another pod, they can interact through these IP addresses. But these IP addresses are only valid inside the Kubernetes cluster, right? They are not valid outside. So if you type this IP address in your browser, you will not get anything. So let us try that. So if I go to my browser and I type in Control V, you'll not be able to see anything. Reason being that this is a private IP address, right? This is only visible to the cluster which is basically working over here, right? Now the first thing that we want to do is basically deploy pods. Now we have to create a deployment. Now in order to create a deployment, you have to write a YAML file. Now what is a YAML file? A YAML file is basically a file in which you specify all the specifications of your deployment. For example, I want a deployment which goes by the name of Nginx, right? The specification of this deployment would be that I want 3 replicas which should be running, right? And the containers should have the image Nginx 1.7.9 running on it, and the container should expose the port 80, right? Now this is the deployment that I want to run. Now say I want to change the number of replicas to say 5, right? So I'll specify 5 over here. I'll save and exit this file, that is deploy.yaml. And now in order to create a deployment, all I have to do is kubectl create deployment and then specify this file, which is deploy.yaml, hit enter, and now it should create a deployment for me. The reason it didn't create the deployment for me was this. Alright, so kubectl create and then you specify -f space and then deploy.yaml. Now this should correct the error. So let me first clear the screen. So clearing the scene, and now in order to create the deployment, there are 2 ways of doing it. Either you can specify create deployment and then the name of the deployment, that is Nginx say 1, and then the image of the deployment, which is Nginx colon 1.7.9. So if I do this, it will create a deployment called Nginx 1. So like you see, it has created, and now what you can do is you can basically see the pods which are running for your Nginx. So since you didn't specify any number of replicas, there's only one pod which is running for this particular resource, right? And it's Nginx 1. Now let us see how we can create it from a file, that is deploy.yaml. In order to create a deployment from a file, all you have to do is kubectl create and then -f and then specify your file name, which is deploy.yaml. Now if I hit enter, all you have to do is see kubectl get pods, and you can see that there are 4 replicas of Nginx running over here, right? It's not 4, it's actually 5 replicas of Nginx running over here, right? And now if I go to my my deploy.yaml, I can actually see how much of replicas I've specified. So I specified 5 replicas, and hence I have 5 replicas of Nginx running over here, right? So these are all pods, and like we discussed in the architecture, so let me quickly go to the architecture. So here is the deployment, and it has the number of pods specified inside it, right? And this is what exactly what we have done. We have created a deployment, we specified the number of replicas, and these are the pods being run for that deployment, right? And all you have to do for deleting all the pods, all you have to do is delete the deployment, and it will delete all the pods which are running inside it, right? For example, I created the Nginx 1 deployment, so all I have to do is kubectl delete deployment and then specify the name, which is Nginx 1, right? Hit enter, and now Nginx 1 has been deleted. So if I do a kubectl get pods, I can see that there is no Nginx 1 pod running right now. There's only Nginx deployments pod which are running, right? So we have deployed a deployment which has number of pods which are running inside it. Now, in order to access these pods, now what is running inside these pods? So if you want to see, like I said, where exactly your pods are running, all you have to do is kubectl get. So let me first clear the screen. So kubectl get pods -o wide if you want to see where your pods are exactly running. And your pods are all running on the node, right? So this is the IP address of your master, which is 172.31.44.86. And all your pods are running basically on the client, that is on the worker node, which have the address 172.31.38.140, right? Now you can check if these pods are running as containers on your worker by going over here. This is my worker, right? So if I specify, say, Docker PS, I can see that these are all the containers which are running right now. And all these containers are basically the containers which are running inside this pod with the system containers which are running for Kubernetes, right? So
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now, let's continue with the session.
my pods are now running on my worker. The next thing that I want to do is being able to access these pods. So if I go to these IP addresses, I'll be able to access these specific pods, right? But only inside the cluster. For example, if I type it in the browser, I'll not be able to see anything. Let's try that. So if I go to my browser and I type this IP address, obviously I can't see anything, right? But if I type the same IP address over here, I'll be able to get what is there inside the pod, which is basically my Nginx file, right? So I am able to access the pods on the cluster. Now I want to access it outside. Now for that, what we discussed in our diagram was we need a service. We need a service in order for us to basically interact with the pods. Now let's create a service. Now for creating a service, all you have to do is type in kubectl create service and the type of the service. Now there are 3 or 4 types of services that you can deploy. Right now we have to deploy a service called nodeport. Okay, what all different type of services are there? We're going to discuss this in our coming sessions. Right now, let's just focus on creating a service which is of type nodeport, right? Once you specify the type nodeport, the next thing that you have to do is specify the name of the service. And remember guys, the name of the service should always be the same as that of your deployment, right? So for our case, our deployment's name was Nginx. We'll specify that. And now let's go ahead and specify the ports where your service should basically point on, right? So the 80 port of your service should basically point on 80 port of your pods, because when you created the deployment, you specified that 80 port of the pod should be exposed, right? So you specify 80:80. Why 80? Because Nginx works on port 80, right? You specify this, you hit enter, and now your service has been created, right? So to see your service, all you have to do is kubectl get service, you enter, and now you can see that a service has been created which is of the type nodeport and is available on this particular port. Okay, so nodeport basically means that a port will be opened on the master and on basically on the cluster, and using this port you can access your pods, right? So if I copy this port, and now basically what I want to do is go to my master's IP address, which is this, and then open a new tab. Now specify the port, which is 31827. 31827. I specify this, and now all I have to do is hit enter. So the moment I hit enter, I can now see my Nginx image, which basically means my service is working correctly. It is basically pointing to my pods. My request is being load balanced among all the pods which are running. So there are basically 5 pods which are running. So my request is being load balanced among these 5 pods. Okay. So now let us check if it's actually the service which is load balancing it. So let us try deleting the service. So kubectl delete service and then specify the service name, which is Nginx. Hit enter, and now if I go over here and try to enter, I will not be able to access it. So let me just copy this once more and open it in a new tab. So as you can see, now I'm not able to access my cluster, right? So for the first 2 minutes, it was basically accessing my website from the cache, right? What I did was I opened an incognito window, and when I entered the IP address now, it is not able to access the website, right? Similarly, if I do a refresh here, it is still able to access because it is accessing this from the cache of this system, right? That's why it is able to access. But in an incognito window, you can clearly see it is not able to access this service. Okay, now again, if I create a service, it will be able to access. So kubectl create service, which is Nginx, and the type of the service is no port, right? And I want this service to be available on port 80. So I specify that. Okay, so it has been created, and if I do a kubectl get service now, I can see that this is the port it is available on. I copy this port number, I paste it over here, and I'm able to access the Nginx service. So it is that simple, guys. Also, like I told you guys, that my this port is also available throughout the cluster, right? It's not just on the master. So if I copy the node's IP address, which is this, and come back here and basically just change the IP address to the node's IP address, you can still access the service, right? As you can see, you can still access the service. Reason being, this port is available throughout the cluster. Any IP address that is of the master or the node I specify with this port, I'll be able to access the Nginx service. Alright, so guys, this was the hands-on that we had to do today. So guys, continuous monitoring is basically the process of continuously keeping a track of all the servers and the applications which are hosted on that servers and creating a log out of it, right? Now, how does it help? Basically, it helps in cases when your application transitions from an active to a critical state, right? And sometimes what happens is you're not on the application all the time checking whether your application is up or down. So your work is basically done by a tool which continuously checks whether the application is up or down, right? If there are any performance issues, is there any non-responsiveness, is there any downtime, all of this is managed or is basically monitored by the continuous monitoring tool, right? Now, the moment application transitions from an okay to a critical state or a non-responsive state, there are a set of rules that you defined, right? For example, if it's unresponsive, probably a mail or a notification is triggered to the administrators, and basically what will the administrators, they'll properly restart the service or they'll restart the application, right? If there is a bug that is encountered, so for example, if the program goes into a infinite loop and the memory goes haywire, or the memory basically gets full under seconds, in that case also it becomes a critical case, right? So earlier we saw that it was probably a non-responsive case, but in this case it becomes a critical case because even the other applications on the same server becomes affected, because now the memory of the whole server it became full. So in that case, the mail would go to the developers and also the administrators. Developers, why? Because now they have to identify where exactly the problem is, right? So probably the problem is within the code that they've written for the application. So they'll fix it, and the notification also goes to the administrators, because once they are done with the code, the administrators basically have to take that code and upload on the servers again, right? So guys, this is what a continuous monitoring tool is. Now, why is a continuous monitoring tool important? Let's discuss that, right? So let's discuss these points one by one. So your continuous monitoring tool detects any network or server problems. Like I said, it continuously monitors all your services, all your applications, all your servers which are running and hosting your application, right? And it tracks for any kind of change, right? It generates a stream of log, and in that stream of log, the moment there is a change, the continuous monitoring tool automatically creates a notification or an email and send it to the specified contacts in the rule, right? So what kind of changes? It will look at any network or server problems. It will basically see all the security issues as well, right? For example, if someone is planning a DOS attack on you and they try to do that, they initiate attack. So your continuous monitoring tool, if you set up it with the correct configuration, it would be able to identify if a DOS attack is happening on your website, right? And continuous monitoring tool does not only help you to identify what just happened to your set of systems, right, or your server, it also helps you to identify what exactly caused that problem, which is very helpful, because now the developer knows exactly what has to be done, what has to be fixed. Rather than just saying that the application is down, your continuous monitoring tool will also tell you the details of the event which occurred, which is a great thing, because that would help us narrow down on the problem or the segment which basically caused the problem in the whole program, right?
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the popular scripting language of DevOps? A. Java, B. Python, C. HTML, D. C++. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
The next thing is, it also monitors and troubleshoots server performance issues, right? For example, your hardware on which your application is running, your continuous monitoring tool also keeps a track of how the server health is, right? How fast is it to all the requests which are made, right? And how are the response times, how are the performance basically of that server. So all of that is logged, and at times when the performance goes below a certain level, for example, what happens is, guys, the computers never get slow. It's just that the applications or the softwares which run on those computers, they become advanced, right? For example, if you have Windows 10 and you updated your Windows 10 one day, you probably get some new features added to it, but with those new features, that particular operating system is now going to take up more processing power or more resources from the memory, etc., right? And this can cause a problem when you have servers which run 24/7 and have applications which get upgraded timely, right? In that case, you might have to change your server or system, or you might have to upgrade your hardware. So basically, your continuous monitoring tool can also help you in identifying when your system health goes into a critical state, so that you know that when you want to change that particular system, right? So guys, these were pretty much all the reasons that why continuous monitoring tool is so important, right? Why companies are preferring the last stage of their DevOps to be a continuous feedback cycle, wherein they have put the continuous monitoring tools, right? So these were the reasons. Now moving forward, let's discuss continuous monitoring quickly using a DevOps life cycle. So we have discussed this diagram before, but let us just summarize what we just learned, right? So that we can picture it better while we are basically implementing our DevOps life cycle. So a developer does a commit on the version control system. The version control system basically picks up the code and deploys it on the testing server, right? The testing server does its test. If the test fails, the feedback goes back to the developer. In case the feedback doesn't fail, in that case, the code is again pushed by the CI server to the production server. And now from here, the continuous monitoring starts, right? So your continuous monitoring tool is basically going to check the server on which the website has been, or the application has been hosted, for any performance issues, right? It will check for network errors, etc., etc. So it will be on a vigilante mode in that case, right? And check for any faults in that particular application or the hardware on which it has been hosted, right? And the stream of logs that I was taking, so even if your systems are okay, the logs are continuously generated, right? And if there is any change in the log, a notification is basically passed on to the developer team, right? Now, based on the severity of the severity of the event which has happened, it could be a critical event, it could be a non-responsive event, it could be a minor event as well. So based on the events, we define rules. So if it's a critical event, we'll probably want to employ our solutions architect guy of our company as well. If it's a minor issue, probably only one or two administrators would be able to solve it. Either two administrators or one administrator and a developer, so that if that minor issue is being caused by some code which has been recently uploaded, only the developer can fix it, right? So all of this is followed, and keeping in mind all your organization needs, you create this life cycle, and continuous monitoring becomes an integral part of it, because without it, you will not be able to identify how well your DevOps life cycle is actually performing. Alright guys, so we saw that Nagios is one of the most popular continuous, or is one of the most, like, we looked at top 3 continuous monitoring tools and we saw that Nagios was one of them, right? And today in this module, we are going to discuss in detail about what Nagios is and how it works. So guys, Nagios is nothing but an open source software which helps us in continuously monitoring applications which are running on remote hosts, right? For this, Nagios follows a master slave architecture. There is one server on which Nagios is installed, and the others are basically just normal systems on which applications are running, right? So in order for this Nagios server to interact with the services which are running on some other server, you have to install some plugins on those servers, on those hosts which wants to get monitored, and these plugins are chosen based on the platform that they're running. For example, are they running a Windows platform, or are they running a Linux platform, right? Now, what all can you monitor with Nagios? So as you can see over here, you can create monitoring service for literally any kind of things. You can monitor printers, you can monitor applications, you can monitor switches, network switches, right? And you can monitor hosts, right? You can monitor literally anything in Nagios which is in the computer realm and is running on a remote host. With the first topic, which is what are the components of Nagios, right? So there are basically three main components of what make Nagios the most effective continuous monitoring tool. So the first component is the Nagios GUI, then you have the scheduler, and then you have plugins in Nagios. So let's understand this one by one, right? So let's first talk about the Nagios GUI, guys. So inside, basically the GUI is the web interface that Nagios offers you, and that is basically a dashboard for you on which you can monitor all the services which are running on different servers that you have attached to your Nagios server, right? And also you can have a look at all the hosts which are connected to your Nagios server, right? So along with checking them, you can also have a look at their status. You can also have a look at the logs. All of that is possible inside the Nagios GUI. So basically Nagios GUI acts as a front end for you, right? The second component is the scheduler, right? Now scheduler itself is again a very main centric component of Nagios, which basically does all the work of scheduling, right? So what has to be monitored and when exactly it has to be monitored. For example, you are basically monitoring the ping service of a server, right? Now, when do you have to manage it, right? So at what intervals you'll have to go ahead and check whether that ping service is working or not, and what exactly do you have to manage, right? If, for example, ping you have to manage, what all other services you have to manage, and what all servers you have to manage it on or monitor it on, right? So that all of this job is done by the scheduler, right? And then you have plugins. So basically, when you talk about monitoring hosts, talk about monitoring different servers. So if you have like 1,000 servers in your company that you have to monitor, it's not that you have to install Nagios on the servers that you have to monitor. For example, like I told you guys, you need a Nagios server. So your Nagios server will basically take care of all the monitoring part, right? And with your Nagios server, you attach your application servers, right? And your application servers are basically going to have some plugins. So you don't have to install Nagios on them, on the application servers. All you have to do is install a plugin on it, right? And those plugins are called NRPE plugins, right? You install it on them, and using the NRPE plugin, what the scheduler does is the scheduler basically sends a request to the NRPE plugin along with the command using which it has to monitor that particular host, and the NRPE plugin basically helps the scheduler to get all the log related to that particular service which was requested. And once the logs have been received by the scheduler, they get forwarded to the GUI part of Nagios, and then that Nagios GUI then represents the log in terms of their status, in terms of graphs, in terms of many other useful visualization techniques through which you get to know how your host is performing in terms of its hardware, in terms of the application which is running on it, and etc. Right? So this is how basically the Nagios architecture works, guys. So Nagios follows a master-slave architecture. All your hosts are on separate machines, right? And your Nagios has a dedicated server for it. You can also have applications installed on the same system as the Nagios is installed on, right? And Nagios has the capability of monitoring its own services as well. But usually when you talk about it in production environment, or you talk about how companies use it when they are dealing with monitoring application, it always happens on a scale that you have a Nagios server, and beneath the server you have a lot of hosts which are basically hosting your application, getting monitored by Nagios scheduler. So let me quickly jump on to my browser so that you guys can see that we have two hosts right now, localhost and slave one. This we already did in the last session, where I showed you guys how you can add a host to the Nagios server, right? The host which is being monitored. So right now the status of this host is that it is up and running, right? Now what I want to do is I want to create a monitoring service which for an application which will be running on this slave. So what I'm going to do, if I go to services right now, I can see there are no services which are monitoring any application which is running on the remote host, right? So what I'll do is I'll first install a service called sudo apt get install Apache 2. I want to install an Apache service which I can monitor in Nagios for this particular server. Okay, so Apache is getting installed. Yes, so Apache is installed now. Now if I go to the browser, I should be able to see for the Nagios slave an Apache service, right? So Apache page is working. Now what I'll do, I'll go to my server, right? Let me just clear the screen. And now I will go to templates, or let's go to templates, or let us go to localhost configuration first, right? Now in this localhost configuration, you will find a service for, right? So I want this service to be copied. I'll just copy this service, right? And what I'll do, I'll make changes to this particular service and I'll make it a service for monitoring the HTTP connections. So what I'll do now, I'll just go to the configuration file of my host 1, right? And I'll paste the service over here. And let's make changes to the service now, right? So this is the service. Now we want to use a template for the service. Let's say it's not a local service. I'll say it's a generic service. So there's a template for generic service inside templates.cfg. You can have a look at that. The host name for this service would be the same as the host name for your host. So the host name for my host is slave 1, right? So I'll write exactly slave 1 in my service as well. So I'll do that. I'll call it slave 1. Service description, what do I want this description for this service to be? Check Apache. Okay, and the command for this particular service would be check underscore HTTP, right? So this is the official command for checking the if anything is running on port 80 of any computer, right? So you can have a look. If you want to try some other application that you want to monitor, you can just Google out the service or the command that you would use over here to monitor that particular application, right? And most of the times you will get a command. In case you don't get a command, just Google how you can define a command for basically monitoring the application that you want, right? Now, all you have to do is, if you find the right place where you just have to create a command, go inside commands.cfg, right? That is there in your etc directory. And inside the commands.cfg file, all you do is create that command, and which I'll show you in a moment, the way to create a command, and then you can use that command over here as well. So check_HTTP is already a command which is existing in my Nagios server, and I'll show you the definition of this particular command when we go in commands.cfg. For now, the service is ready. So what I'll do, I'll just save the service, right? And now I'll just restart the server. So for restarting, this is the command. I'll pass this command. So my Nagios server is now restarted. Now if I go inside hosts, I can see slave 1 is up. Now if I go inside services, I can see that slave 1 now has a service which is in the pending state, right? So what will happen, it will basically take like 2 minutes for this to refresh and to check whether a service is actually running on port 80 of slave 1. Okay, so let's give it that time and then check after some time. Alright guys, so as you can see, the service that we defined is now under the status of OK, right? So now my service is running fine, and you can check the status over here that HTTP is OK, and 11,192 bytes were responded back to the request in 0.002 seconds. So you can get all the performance details here. You can see that the service is up and running since the past 5 minutes. So I think it took around a good 2.5 minutes for the service to turn green, because Nagios took that time to basically analyze if the service is healthy or not. Alright. Now similarly, if I disable the service, you will be able to see that in another 2 minutes, this server will go into critical state. Right. So let us do that. I'll just go to my terminal and I'll say sudo service apache 2 stop. Right, I just did that, and now if I go to the IP address, I can see that the page is no longer coming. Now it is 5 minutes 39 seconds right now, so let's see 6 minutes 45 seconds right now. Let's see when our service gets into a critical state. Alright guys, so as you can see, the status has now changed, and it says that the status has changed since the past 18 seconds, right? So it took a good 4 minutes for this service to go into critical state. I guess that's how long Nagios checks in intervals as to whether a service is working or not, right? So as you can see, it says connection refused, reason being now Apache is not running on that particular system. Alright guys, so this is how you create a service in Nagios, and similarly you can create any kind of service for your particular application that you want to monitor. Right, all you have to do is either check if you have an internal command which is going to match for your application, or you'd have to create a command for yourself using some plugins, right? So all of that can be checked online when you're working, because there could be zillion applications that you would be working with. Having a look at all the applications is difficult, because with everyone they'll have different kind of needs for the kind of applications that they are monitoring. Okay. Alright, so I forgot about one thing. Let us also have a look at how you can create a command in Nagios, right? So let me jump back to my terminal. So all I have to do now is I'll have to go inside commands.cfg, right? So let's go inside it. So we use the command check_HTTP, right? So let's first that command first. So if you go inside commands.cfg, you will have all these commands over here. Notify host by email, then you have check host alive, then you have check local disk, check local load, then you have check local procs, check local user, check local swap, check local MRT, check FTP, right? So all these commands are then being mapped to their command line usage. So if you pass this command, this command is basically being passed on your Nagios host if you are using the command check FTP. Okay, then you have check HPJD, check SNMP, check DSP. What I'm gonna do is I'll just go click on where is, and I'll search for HTTP. Okay, so here I get it. So on this command, you can check that if you want to define this command, the command name is check_HTTP. The command line for this is $user1 and then check HTTP -i host address $argument1, right? So this is the command which you are using when basically you are just calling check_HTTP while defining a service. So basically what you're doing is in your service, you're basically calling the check underscore HTTP command, which in turn is calling this particular command, which is being passed on to the command line, through which you are able to check whether HTTP is working or not, right? So let's define a command for ourselves. Let us call this command as, command name would be command underscore name. Let's call it test underscore HTTP. Okay, and the command line for this, the command line command for this would be this. Let's paste it, right? And let me just align it. All right, so this is done, and now basically all we have to do is close the brackets, save the file, right? So the file is saved, and now let's go inside sudo nano host 1.cfg. okay, and now I would want to create a service, right? Let's name this service as, we'll use everything which is the same here except the command. So we'll just go down to the earlier service that we created, we'll just copy everything, paste it here. So we have to paste this commands here, and then we'll close the brackets. The check command will now change to test underscore HTTP. The check Apache, let's change the text to check Apache test, right? And everything else will be the same. Okay, now let me show you one more thing. So you can also control the interval in which Nagios is basically checking your command. So what you can do is, let me just save the file here. We'll go to templates.cfg, right? So let's go inside. So we're using the generic service template, right? So let us go inside sudo nano templates.cfg, and now let's try to search for generic service, right? So here it is. So the generic service is defined like this, that you have check freshness is 0, notifications enabled is 1, event handler enabled 1, flap process performance data, and you can check over here that in check interval it's 10 minutes, right? And the retry interval is 2 minutes. So if the service is functioning normally, in that case, it should check for the freshness of the service, or check whether the service is again working or not in 10 minutes from the time that the service goes down. So let us change this to 1. Or what you can do is, you can also change this when you're calling this service. So let's change it over there. So basically you have to remember that this keyword, which is check underscore interval and retry underscore interval. Okay, so let's go out. We're not going to change anything here. What I'm going to do is, I'll go to sudo nano host 1.cfg, and now in the service I'll just specify retry underscore interval, and I'll give that number to be, say, 1 minute, right? Similarly, what I'll do, I'll say check underscore interval, and I'll again specify it to be 1 minute. So every 1 minute, even if this service is up and running, it will check if the service is running now. If not, it will retry again to check the service whether it's up again or not in the another 1 minute. So with this, you should get a faster response onto when your service will become okay on your Nagios dashboard. All right, so we have specified this. So we have changed the services. So let's save the file now. So I'll save the file like this, and now I'll restart Nagios. So let's search for that command. Here it is. I've restarted Nagios, and now if we go inside the browser, here's my browser. What I'll do is, I'll do a refresh. I'll go to services, and now I can see there are 2 services which are running. So because we stopped the Apache service on our server, that's why it is saying it's in a critical state right now. So what I'm going to do, let me go here and okay, so we'll start Apache server, but first let's wait for this pending state to become to critical. So what I'll do, I'll just click refresh once again. I'll go to services, and let's wait for this service to become critical. In that case, what I'm going to do, we're going to see that in how much time it becomes okay from the time when we basically up the service. All right, so let's wait for this to become critical. All right, so as you can see, the service is now critical, and what we can do now is, we'll go to this system and we'll start the service now. So I'll start the service like this, right? So this service of mine, which is check Apache, is basically working at 10 minutes interval and 2 minutes retry time. On the other hand, this service, which is check Apache test service, is retrying at every 1 minute and checking the service also at every 1 minute. So let's see if there's a difference that we see over here. So we'll just refresh it and see which service becomes up and running again. Alright, so you can see that my check Apache test is already in the OK state now, right? So it became OK faster than the check Apache service. If I again refresh the service, I can see that my check Apache service is still in the critical state. Reason being, the check interval in that case I did not configure, and it took the default values of my generic service template, which had 10 minutes of check interval and 2 minutes of retry. Right? So basically, if this state is in the retry state right now, it should take around 2 minutes for this to become okay, right? On the other hand, my Apache service, because my check intervals is just 1 minute and even my retry interval is 1 minute, it became okay faster because Nagios is now checking the service pretty early than the way it is checking it with this particular service. So if I again click on these services, I can still see that this is in a critical state and check Apache state is in a OK state. Alright, so this was it for this session, guys.
First, we'll see why DevOps Engineer. So a DevOps Engineer must manage the IT infrastructure as per the requirement of supported software code. So what does this mean is, in a software development lifecycle, there are a lot of stages from planning till deploying the code to the production environment. So to do that properly and in a structured way, you need a DevOps engineer. A DevOps engineer basically monitors all of these tasks and creates an automated process which will automatically deploy your software. So he'll build a system, he'll build a life cycle which starts from the planning stage till the development and deployment stage. So a DevOps engineer is required to implement the DevOps principles in a company. So DevOps is not a technology, guys. It is a set of principles, or it is a methodology which you can use, and you can use various tools and services, and you can create a complete DevOps lifecycle which will benefit your business. Moving on, now we are going to discuss the DevOps engineer salary. So pay by experience level for development operations engineer. So basically, a DevOps engineer is a person who is in between development team and the operations team. So the development team is the team which develops the code, and the operations team is the one who deploy that code into the production environment. So there was a gap in between them. So DevOps engineers are the people who is the bridge between the development and the operations team, so that they can create a complete business life cycle. So they can build software from planning stage, then developing it, and then testing it, and then building it, and also deploying it. So now let us discuss the salary. So if you have less than 1 year experience, you might get up to 3.63 lakhs or 363k in Indian rupees. And with 1 to 4 years of experience, you can get up to 5.73 lakhs per annum. And then with 5 to 9 years of experience, you can go up to 10 million rupees, and not 10 million, it's basically 1 million, that is 10 lakh rupees. And with 10 to 19 years of experience, more than 10 years of experience, you can get up to 2 million, that is 20 lakhs per annum. So this was provided by payscale.com. So moving on, let us see the average salary of a DevOps engineer in various locations or countries. So first, in the United States, you get $100,000 per annum. And then in India, the average salary is 569,000 INR every year. And then in the UK, it is 62,500 euros or pounds per annum. So moving on, now let us see the popular employer salaries for DevOps engineer. So TCS, Accenture, Amazon, Wipro, Oracle Corporation, then Infosys and IBM are very huge organizations all over the world. So let us see TCS first. TCS provides you a 6.27k. This is the average salary. And then Accenture Technology Solutions provides 5.15 lakhs. And moving on, you can see Amazon provides 1 million, that is 10 lakh per annum. And then Wipro provides 6, Accenture provides 6.5, Oracle provides 10, And Infosys and IBM provide the same 6.5 and 9 lakhs per annum. So moving on, now we are going to see the steps to become a DevOps engineer. So the first step you'll have to take is you'll have to check what are the common skills which are for DevOps engineers. So you'll have to go through multiple job descriptions and check what does the employer need from us. So to understand that, you'll have to go through job descriptions and find out the most common skills which are asked from the employer. So now let us discuss them. I've chosen 3 different job descriptions. We are going to discuss the common tools and the common skills which the employers ask from us. So the first one is from Unilever, and it is for a DevOps engineer post, and you should have at least 5+ years of experience. So basically they need shell scripting and also Python. So they need you to know some programming language. Even though programming language is not part of a DevOps engineer, but learning how a programming language works and that programming language will help you very much in DevOps engineering. And then comes automation. You will need to know either Ansible, Chef or Puppet as per this company, and then Jenkins 2.0, and then Java, and then Docker and Kubernetes for containerization and also orchestration. And then you also might need to know about operating systems, virtual machines, containers, proxy and engines. Moving on. So this role is from SAP. This role is for SAP and they need a 4+ year experience DevOps engineer. So they're asking for the latest technologies, that is, as I told you, containerization and orchestration tools. They're asking for Kubernetes and containers. And then for monitoring tools, they want us to learn Nagios, Grafana, Prometheus, and these are some various examples for monitoring tools. And then basic knowledge of virtualization, that is creating virtual machines on cloud-based systems and also network. So they're asking us to know cloud technologies like OpenStack, GCP, Azure also. And then configuration management tools or automation tools, which are Chef and Ansible. And these are asked by SAP, and these are some common tools which you will have to learn if you want to become a DevOps engineer. And then this is for a DevOps engineer mainly on continuous integration and continuous development or deployment, that is CI/CD. So this particular role needs 7+ years of experience, and then they're asking us to have a good knowledge in cloud services, that is AWS, Azure, GCP and other forms of cloud services. And then they're asking us to be strong in CI/CD and also tools like Git, Bitbucket, TeamCity, Artifactory and Jira. So basically Git and Bitbucket are version control tools. TeamCity is used for deployment purposes. Artifactory is used to store artifacts in binary files. And then they're also asking us to learn about Git, Atlassian, Jira, Confluence, Bitbucket. So Atlassian tools, Jira, Confluence and Bitbucket are Atlassian tools. So if your company is using Atlassian environment or Atlassian ecosystem, you might have to learn Jira, Confluence and Bitbucket. And then they're asking us to learn Docker and Kubernetes. As I told you, they are containerization services. And also you'll have to learn Python shell. So you'll have to learn shell scripting basically if you want to become a DevOps engineer. That is very helpful. And then configuration management tools. So configuration management in the sense Puppet and Ansible. So as I already told you, we saw Puppet, Ansible and Chef in all those 3 job descriptions. So these tools are very much important if you want to become a DevOps engineer. Moving on, now I've summarized the common tools which you'll have to learn if you want to become a DevOps engineer. So the first thing is automation tools. Why? Because DevOps engineers' main objective is to automate the software building process, that is the software development process. So you'll have to learn a lot of automation tools like Puppet, Chef, Ansible and Jenkins. So these all automate the software development process. And then comes CI/CD tools. So CI is continuous integration and CD is continuous deployment. So under CI/CD tools comes Jenkins, TeamCity, Excel Deploy and various services. And then comes testing tools. So when you write a code, you will have to check that code for readability, bugs. So also it might have warnings and loopholes and vulnerabilities which hackers can use against us. So basically when you create a code and try to launch it to a production server, you will have to know and learn testing tools like Selenium so that you can check the bugs before even deploying those code into the production environment. And then comes cloud services, because most of the companies are shifting to cloud-based systems right now. Many companies are shifting to AWS, Azure, GCP, Ali Cloud. There are a lot of clouds, even IBM Cloud. So you should learn the cloud service, so you might be trying for a particular company and you'll have to learn the cloud service which is used by that company. But learning AWS, Azure and GCP is very helpful because these are the world's most top 3 cloud services and they are used by a lot of firms and organizations. And then a programming language. So programming language is helpful if you do anything. A programming language is useful for any role you take up in the technical field. And for a DevOps engineer, as he's creating a complete life cycle for software development, so learning a programming language will give that person better understanding of how software works. So these are the 5 different tools or 5 different summarized tools which you will have to learn to become a DevOps engineer. And in this session, we'll also be seeing few tools like for few automation, CI/CD testing and cloud service tools. We'll be looking at them right now. So also skills that affect DevOps engineer salaries. So these services might include your salary, so they might increase your salaries. So
just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now let's continue with the session.
To become a DevOps engineer, learning a DevOps course or learning from somewhere, learning all the DevOps tools is very helpful. If you think your experience in your last company to move to a DevOps field is enough, then you might get a 6% less salary. But if you have a DevOps certified course, if you have a DevOps certification, then that might help you. And then Python, as I told you, a lot of scripts are written in Python, and learning how a language works is very important. And then comes cloud computing, Amazon Web Services. So Amazon Web Service is a cloud computing service. So learning cloud computing will help you because most of the companies' architectures and infrastructure is on cloud right now. And then shell scripting, as I told you, shell scripting is one of the important concepts because for creating configuration and managing that configuration, you will need to know shell scripting. And then comes Jenkins. Jenkins is one of the most popular tools for DevOps tools. It is used for CI/CD. So learning Jenkins would be very helpful because Jenkins is an open source tool and it is used by a lot of companies.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous delivery and monitoring. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
And let's see what our first question is. So our first question asks us, can we explain the Git architecture? Now this is fairly an important question, reason being only if you understand the underlying basics of how Git works, will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right, so let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository onto the, or push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and this is the main principle of how Git works, and that is the reason it is called a distributed version control system. Right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in our remote repository. So the first thing that they have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they have done with the changes, they will have to do a git commit, or they'll have to commit the files to the local repository. Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right. And this is how the whole Git architecture works. Now, I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says, in Git, how can you revert a commit that has already been pushed and made public? Right? So basically you have done some changes in the code. You committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you come to sense that the code is wrong, and you quickly have to change the code so that everything becomes working again. Right? Now, this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server. Right? So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command, and let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right. So this is my terminal, guys. Basically, I will SSH into an AWS server, and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. So we'll just copy this address. 1 second. Yes. So we'll just copy this address, and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside our Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called Devops IQ, which has been created inside this folder. I will go inside Devops IQ and do an ls. And you can see there's one more folder called Devops IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.123.58/DevOps IQ and /DevOps IQ. All right. This is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right, let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes, and the message should say changed background. All right, so the changes have been committed, and now I'll push these changes to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg. I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong, and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this, and now just go ahead and do a git revert. So git revert and then give this ID which you just copied, okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything, and then you can see that the commit has been reverted. So now I have not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well, all I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed. Right now, if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right, so guys, this is how you can do a revert on a basically a commit and a push that you have made to your remote repository as well, right? So if you encounter any problem during working while working as a DevOps engineer, you should remember this session where I taught you how to revert a particular commit. All right, so with that, let's move on to our next question, which says, have you ever encountered failed deployments and how have you handled them? Now see, any DevOps engineer in the world will have faced a problem in which, probably the things that he had planned, the things didn't go according to his plan, right? That absolutely happens. And if somebody is asking you in a DevOps interview, have you committed mistakes? So you should, just to impress them, probably never say yes, right? So if you have never committed mistakes, that's awesome, right? But then I know that every engineer or every DevOps engineer who has worked in the industry would have faced a problem while working and would basically account to a mistake that he made while deploying things, all right? Now, the important thing or the important key takeaway from this kind of a learning should be that whatever mistake you make, you learn from it, right? And you never commit it again. And that is basically the intent behind this question as well. The interviewer would want to know, if you made the mistakes, what did you learn from those mistakes? Okay, so if an interviewer was supposed to ask me this question, I'll say, obviously I have encountered failed deployments, and what have I learned from them? I'll just give you the best practices that I think are viable for any DevOps engineer who is working in the industry. So the first thing that everyone should follow and should make it a thumb rule is that you should automate code testing. Not only does it save time, because now your tester does not have to wait for your developer to basically push the code and then check it. The developer can check it in real time because you have written a script for his application, and all the major tests which are to be done, which are pretty common, can be done using automated code testing, right? Now, like I said, it's not only for time saving, but also it removes the part where a human error can occur, right? So if you are working, if you are now, when you work with people commit mistakes. But if you can write a code which will basically test each and every functionality, that code will never make a mistake. And that is why you should always automate things as far as possible, right? So like in my example, what happened was that there was basically a commit to the repository, which was basically a feature addition, right? And the tester did not see all the functionalities, or forgot to see some of the functionalities that could impact the other components of my product. And because of that, when it got pushed onto production, basically disaster happened. Everything stopped working, right? And that was only because the testing did not happen properly, right? So for all the critical processes of your website or your product, you can basically create a code which will test that website. And basically that would basically close down most of the doors to mistakes. All right. The next thing is you should always use Docker for same environment, right? And this is basically the ideology behind DevOps, that these kind of problems where a developer used to work and the tester could not run his code on his computer, but the developer said that everything is working fine on his system. Docker basically solves that problem, right? So use Docker as much as you can for the same environment problem that you might face. Then we should always use microservices. Now, when you are working in a company, it could be that the product is in the legacy phase and hence it's on a monolith kind of a thing, but you should never encourage this kind of an architecture, right? Reason being, say you did a bad commit or you did a bad push on the production server, but it should not impact the other components of your product, right? If probably you have done something to search, and if it's a bad commit or a bad push, the only functionality that should be impacted should be your search functionality and not the other functionalities. And that is the sole reason behind why we should use microservices. That is, we should divide our application into different small products which we would deploy on servers, and these products should be independent of each other. When you talk about the monolithic architecture, all these components are coinciding with each other, have the dependency upon each other. But when you talk about a microservices kind of an architecture, you remove that dependency so as to, even if one component fails, it does not impact the whole application. Fourth point being, you should always overcome risks to avoid failures. Now, this basically means that if there is a code change, or if there is a feature addition which works sometimes and sometimes it does not, and you're not able to figure out why is exactly that thing happening, it is better to wait and troubleshoot it than to push it just to meet your dates, right? Because the latter can cause you a big problem in production when you're in a company like probably like Airtel, or in a company like Samsung or Ericsson, where their products, each second of their website's uptime brings in money, right? So if your website is down for 30 seconds, that could amount to a huge loss, and that would be on you, right? So for you to not face that kind of a situation, always be 100% sure before you make a change or a release onto the production server. Alright, so this is the end to the domain of continuous development. Let's go ahead and now talk about virtualization and containerization. Alright, so let's start with the first question of this domain, which says, what is the difference between virtualization and containerization? Now, this is a very important question, guys, because most of us get confused between virtualization and containerization. So let's see what are the differences between these two things. So virtualization is nothing but installing a new piece of operating system on top of a virtualized hardware. What does that mean? So basically there are softwares like hypervisor or any other software which specializes in virtualizing hardware. So if you have a server which has around 64 gigs of RAM and 1000 TB of hard disk space, with a software like hypervisor, what you can do is you can take that space and divide it among multiple operating systems, right? You can deploy multiple operating systems on the same hardware by virtualizing the hardware so as to the operating system will feel that, say, if you virtualize 1 GB of RAM from this whole system and say around 100 GB of storage, the operating system will think that, you know, it only has 1 GB and 1 GB of RAM and 100 GB of storage space available to it. It cannot go beyond that. Reason being, it does not know of the hardware which is beyond or which is ahead of the hypervisor software. All right. So in virtualization, basically you have an hypervisor which sits on top of your operating system and virtualizes the hardware beneath it, right? Then you have a guest operating system. So basically once you have virtualized the hardware, you install guest operating systems on top of that. For example, the best example for this would be VirtualBox, right? You install VirtualBox and then you can install operating systems on the VirtualBox with a given spec that you will decide, right? And once you've installed the guest operating systems, on top of that, there would be the binaries or the libraries that you probably would be downloading or that came with the operating system. And on top of that, you have the applications which would be running, right? So the key takeaway from virtualization should be that it's the whole operating system is installed from the kernel level to the application level. Everything is fresh, everything is new. Now let's talk about containerization. So the thing in containerization is that the host, on top of host operating system, you install a software called the container engine. Now the container engine is just like any other software, like you have an hypervisor, you have a container engine. Now the container engine does not encourage installing a whole operating system. For example, if you want to run a container for Ubuntu on, say, a Mac machine, you can do that, right? It will basically, in that container, you will have basically the bare minimum libraries that amount to become the Ubuntu operating system minus the kernel, right? So in a container, you do not have a kernel. The kernel is always used of the host operating system. And this is the main difference between virtualization and containerization, that in virtualization, you have a separate kernel present of the virtual operating system. But in containerization, you do not have that. And that is the reason the containers are very small. They have the bare minimum libraries required for that container to behave as a particular operating system, but the container itself does not contain any operating system. It basically is based on the same kernel on which the host operating system resides. All right, and this is basically the main difference between virtualization and containerization. Moving forward, now the next question says, without using Docker, that is without using Docker to get into a container, can we see the processes that are running inside the container of the Docker container engine? All right. So this basically is relating to the same fact that if you want to see the processes of a container which are running inside the Docker container engine, if you can see them from the outside, basically that means that the processes are running in the same kernel of the host operating system, right? The processes that are running in the Docker container engine would be basically as an addition to whatever is running on the host operating system as well. And you can see that using the ps aux command. right? So for the host operating system, it's just like any other software or any other process that it has to run. But for the container, it basically thinks that it is running inside an operating system, which it actually is not, right? So can you see the processes? So the answer is yes, you can see the processes which are running inside a Docker container. And how can you see that? How can you basically see these processes? Let me demonstrate it to you. Okay, so we have come back to our AWS server. Let me clear the screen. All right, so if I do a Docker PS right now, you can see that there are no containers which are running on this system as of now. Now what I'll do is I'll run a container for Ubuntu. So I'll do a Docker run -it and then -d and then Ubuntu. All right, so this ran a container for me. And if I do a Docker PS now, you can see that there's a container running, which is basically of the Ubuntu image. So if I go inside this container now, so I'll do a Docker exec -it and then bash. Docker exec -it and then I forgot the container ID. So the container ID and then bash. So if I do that, I'm inside the container, right? And there's no process running inside this container as of now. Now, if I were to duplicate this, let me quickly again do an SSH. So I'll do an SSH into the same server again so that I'm on $. Okay, great. So if I do a PS AUX, these are all the processes which are running inside the operating system right now, right? But let us make it a little simpler. What we can do is, let me see all the processes which has the word watch in them, right? So let me make it more clear for you. So these are the processes which have the watch keyword inside of them. Okay, so there are basically 4 processes which are running and which have the keyword watch inside of them. Now what I'm gonna do is, inside this container, I'm gonna launch a watch process. So what is that watch process? That watch process is basically going to watch a particular command in a set interval of time. And what is that command? I basically want to say, let's see the ls-l command. Okay, so what is it doing? It is keeping a watch on the command ls-l in every 1 second, right? You can see the time over here. It is incrementing every second, and basically it's keeping a watch on all these files which are there inside the container continuously. Okay, now again, so this is the $ prompt. That we are outside the container right now. Now if I again do the same command, that is again I search for processes which have the word watch in it, I can actually see that there is a new process which is running over here, and this process is running inside the container, which I'm able to see from the host operating system level, right? So the host operating system is basically treating this particular process as if it was running on its own system. That is, the container and the host operating system, because they are sharing the same kernel, the host operating system is taking this process as if it was running inside of it, right? But if we look closely, this watch command is running inside the container, right? Let me just quickly stop it. You can see we are still inside the container and we have stopped the watch command. And if I go here and if I refresh, you can see that this watch command is again gone, which was being mentioned over here before. And this is exactly what we wanted. We basically wanted to see a process which was running inside a container from outside the container, that is from the host operating system, and that is exactly what we just did. All right. So the question that without using Docker, can you see the processes that are running inside a container? So the answer is yes, you can do it. All right. So the next question is, what is a Dockerfile used for? What do you basically use a Dockerfile for? So a Dockerfile is nothing but it's basically a text document to create an image using an older image and adding some files into it. All right. So it's basically like a script that you run in Linux, which can do all the things for you that are required. For example, I might need an Apache image and I want my website to be put inside the var/www/html folder inside this particular Apache container. Now, in order to do that, if I were to do it without a Dockerfile, I would have to first download the Apache image. So I would probably type docker run -it-id and then Apache. Once I've done that, I will exec into the container and then go to the directory called var www.html. Probably I'll do a git clone of the website that I want, and then my website will be available in that container, and hence I'll be able to use it, right? This is one way. Second way is I can create a Dockerfile, which will basically build this image for me without me having to do all these things, all these manual things, which I just told you, all right? So let's see how we can do that. So let me just exit this container and let me remove the container which are just running inside my system right now. Okay, so if I do a docker ps now, it's clean. Now what I want to do is I want to run this particular container, docker run -it-p. I want to basically expose the port 83 to this container's port 80, and I want to run it as a daemon so that it runs in the background, and that is it. Okay, so I have the container running, which is this, and what I want to do is I want to basically copy the website into this container. So let me do a docker exec into this container -it. This is the container ID, and then container ID and then bash. So I want to go inside this particular folder. So if I do an ls over here, you can see that there is an index.html and an index.php which are running, right? So it's exposed on port 83, which basically means if I go to a browser and if I go to the server's IP address on port 83, I should be able to see this Apache page, and this is basically the container which I just ran over here. Okay, what I want to do is inside this particular directory, I would be basically copying the code of my website. Now let's see how we can do that. So let me just exit this container. Let me do a docker ps. Let me do a docker stop to this particular container. So what would this do? So basically, if my Apache was running over here, it should stop once I have stopped this container. Okay, so it is stopped. So if I do a refresh over here, you can see the site can't be reached. This is exactly what we want. Okay, now let me do a git clone of my GitHub. I'll do a git clone. All right. Awesome. Now I'll go inside this folder, and basically I want to copy this particular folder inside the container. All right. So for doing that, let's create a Dockerfile, and what I want to say is in the image shhar/webapp, I want to add the folder DevOps IQ. And where do I want to add it? Inside the container, I want to add it in this particular directory. Okay, this is where I want to add it, and inside DevOps IQ. Okay, fair enough. And that is it. That is all you have to do. I'll just come out of this editor, and I'll now do a Docker build of this Dockerfile with the name test. So it says successfully built an image and it has been tagged as test. Great. Now if I run this image now, docker run -it -p, say I run it on port 84, run it as a daemon and run the image. Okay, great. So if I go to port 84 now, let's see if the container is working first. So yes, the container is working. Now if I go inside DevOps IQ, what do I see? Great. So I can see the web. So basically my website is now available inside the container by simply writing a Docker file to do that. And this is exactly what we wanted. Awesome, guys. So what is the Docker file used for? It is basically used for creating an image without having to do all the manual stuff of adding your files and everything. All right. Now, once this image of yours is ready, you can push it to Docker Hub and anybody in the world can download it and can basically use your website on their local system. Great. Now, the next question is explain container orchestration. Okay, so till now we have seen that, we can deploy a container, we can use it, we can probably deploy an application on it, and we can use it on the web browser, right? But it is not that simple. When we talk about a website like Amazon or a website like Google, right? It has a lot of components with it. For example, on Amazon, you would see that you have a comment section. Then on the home page, you see that there are a lot of products which have the prices, the ratings. Now, each and every component, the prices, the ratings, the name of the product, the image of the product, the comment section, each and everything is basically a microservice. It is a small part of an application which is running independently of all the other parts of the website, right? And all of this is possible using containers. So basically what they would have done is they would have ran each and every component inside a container. Now the problem over here is, now when you have a website like Amazon, you would be dealing like you would be dealing with minimum like 10 or 11 containers for one particular copy of that website or one particular instance of that website, right? Now, when you're dealing with 10, 11 containers, these containers have to be working in conjunction to each other. They should be in sync with each other. They should be able to communicate with each other, right? And they should also be able, we should also be able to scale a particular container in case it goes down. For example, the comment section container, it goes down for some reason. Now, if it goes down, we have to keep a watch on it and we have to redeploy it if it goes down. And all of these activities, which I just told you, comes under container orchestration, right? If you were to manually deploy these containers on Docker, you will have to keep a manual check on all these containers. But imagine when you have thousands or 10,000s of containers that you're dealing with, in those kind of scenarios, you need container orchestration. Now, container orchestration can be done using various softwares. So you have a software called Kubernetes, and before that there was a software called Docker Swarm, which basically made our life easier by doing all the manual work for us. That is, it will check the container's health. It could scale them in case they become unhealthy. They could always also notify the administrators by an email in case something happens, right? They can also run a monitoring software for you, which basically gives you a report or the health status of all the containers which are running inside that software. So this is what this is a very small part of what a container orchestration tool can do, right? And basically, if you were to understand what container orchestration is like I said, when you work with multiple containers, you have to take in note a lot of things, and that is possible using the container orchestration tools like Kubernetes and Docker Swarm. Okay, so the next question is, what is the difference between Docker Swarm and Kubernetes? Now, they're both container orchestration tools. We just saw that. But why do we have two? Or if I were to choose between Kubernetes and Docker Swarm, which should I choose? All right, so let's look at the differences between each one of them. So the first difference, which is probably the most important difference, or probably I'll say is the deciding factor whether you should go ahead with this tool given that you have a short deadline and you have to deploy a project. So installing Docker Swarm is very easy. It comes pre-packaged with the Docker software. So if you have installed Docker Swarm is already installed on your system. You don't have to worry about anything. On the other hand, installing Kubernetes is a very tough job, right? There are a lot of dependencies for Kubernetes. You'll have to see the system, you'll have to see the operating system on which it is running, and a host of other things, right? It has a lot of dependencies and hence it is very tough to install. But the moment you install it, it becomes very helpful. That is, Kubernetes becomes very helpful because of the features that it offers, which brings us to our second point. Docker Swarm is faster than Kubernetes, reason being that it has less features than Kubernetes and therefore making it a very light software and hence faster than Kubernetes. So if you want to use Docker Swarm, you should be reading about what Docker Swarm does not offer and what Kubernetes offers. And if you feel you do not need all the features that Kubernetes is offering, you can go ahead with Docker Swarm and deploy your application in a faster manner. But like I said, Kubernetes is complex and it has a lot of services and features, because of which its deployments are a little slower when we compare it to Docker Swarm. The third point, which is the most important point, is Docker Swarm does not give you the functionality of autoscaling. Meaning if your containers go down or if your containers are basically performing at their peak capacity, there is no option in Docker Swarm to scale those containers. On the other hand, because of Kubernetes monitoring services and the host of other features, you have that option of providing auto scaling to your containers, which basically means you can automatically scale your containers up and down as and when they are required. And this is an amazing thing that Kubernetes handles for us. Alright guys, so these were the questions around the domain virtualization and containerization. So moving ahead, now our next domain is continuous integration. So let's shed a light on what continuous integration is. So our first question itself is, what is continuous integration? So continuous integration is basically a development practice, or I'll say it's a stage which basically connects all the other stages of the DevOps lifecycle. For example, you push your code to Git, like we took an example. When you push the code to Git, you might have provisions which might allow you that the moment the code is pushed onto the remote repository, it automatically gets deployed on the servers as well. Well, if that is the case, basically that would be possible using integration tools that would integrate your Git repository with your remote server. And that is exactly what Jenkins does. It's a continuous integration tool which helps us integrate different DevOps lifecycle stages together so that they work like an organism, right? This is what continuous integration means. So, because we discussed about what continuous integration is, our next question says, create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So on every push that you make to the remote repository, the code should automatically get deployed on a remote server. All right. So this is something that we're going to do just now. All right, but before going ahead, let's see what is the architecture for this kind of a thing. All right, so this is how the whole thing is going to work. Basically, the developer is going to commit the code to his GitHub, GitHub basically, once it sees a change in the branch that we mentioned, it is going to trigger Jenkins, which in turn will integrate or will take the website from the GitHub repository and push it onto the build server on which we want the website to be deployed. All right, sounds awesome? Great. Now let's go ahead and do this demo. So for that, we will have to SSH into our server. So let us do that. Okay, so I'm in now. Let me clear the screen. So first let's check if our Jenkins is running on this server. So let me check the status for Jenkins. So if I do a service Jenkins status, I can see that the Jenkins service is active. Awesome. So I'll just go here and I'll go to the Jenkins website, which is basically available on AT80. All right, so I'll enter my credentials, and this is how the dashboard for Jenkins look like. Now our question is, or our aim is, to create a job which basically will push a website that we are uploading to GitHub on a particular server. All right, so let's create a new job first. So let's call our job as a demo job. Okay, and let's name it as a freestyle project and click OK. So this will create a job in Jenkins for us. All right, so our job has now been created. So what we want to do is I want to take code from my GitHub. So I'll have to specify the GitHub repository over here. Okay, and similarly I'll have to say that I want to trigger the build the moment my anything is pushed on my remote repository.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customer says about the course.
How was your learning experience with our trainers?
The learning is great. It's a lot of hands-on, which is quite good. So you learn in a fast way, saying like, and practical also. I'm encouraging people to take courses on Intellipaat.
Now let's continue with the session.
All right, and this should be it. Great. So I mentioned that anything that is pushed onto my master should trigger a build on Jenkins. Okay, and what should this build, or what set of commands do I want to run once build is triggered? So first I want to remove all the containers which are running inside my system. So I want to clean up, right? So for that I'll say sudo docker rm-f, then a $. This basically is going to clean all the containers which are running currently in the system. Once this is done, I want to build my website, which is going, or build my container which is going to have my website. All right, now how can we do that? For that I'll have to push the code to my GitHub, which will have the Dockerfile as well. Okay, so we created a Dockerfile inside. Okay, so here it is. So we have our Dockerfile created in the DevOps IQ folder, which was there in my home directory. Now what I want to do is I want to push. So what is there inside this Dockerfile? We saw that we could create a Dockerfile using if we write something like this in our Dockerfile, and this would basically create an image with our code which is there on GitHub. All right, so what we'll do, we'll just push this code to our remote repository. and let's add the message that we have ordered a Dockerfile. Great. And now let's push it to our remote repo. Great. So it has been pushed to my remote repo. And now if I just go here and check if my changes have been done or not, let me just quickly refresh it. So yes, I have a Dockerfile in my Git repository right now, which was committed 42 seconds ago. Awesome. Great. So now what I'll do is I'll come to my Jenkins and I will say that build sudo docker build the Dockerfile. Now where is that Dockerfile? The Dockerfile will basically be downloaded in the Jenkins workspace. So that is in var lib Jenkins workspace, and then the name of the job, which is demo job, and that is it. So inside this I will have my Dockerfile, and it will basically build it and name it as, say, Jenkins. It'll name it as Jenkins. In the next step, what I'll do a sudo docker run -it and then -p and say I want to deploy it on 84 or say 87 port. Okay, and what do I want to deploy? I want to deploy Jenkins. Okay, so this should do this should basically do all the stuff. So in the first command, basically we're removing any container which is running on the system. In the second command, what we're going to do is we're going to build the Dockerfile which is available in this workspace, and this workspace will basically have my GitHub project and the link I have specified over here. So it'll basically just copy, or it'll pull the project and save it in the workspace of demo job. So in this demo job, there's a Dockerfile. So we are building this Dockerfile and we are naming this created image as Jenkins. And then we are running this image and exposing it to port 87. Okay, so let's save it. Awesome. Now what we have to do is I'll have to go inside. So if you want to configure a webhook, the way to do that, when I say a webhook, basically you want your GitHub to interact with your Jenkins whenever there is a push to a particular repository. So in your repository, go to settings and then go to webhooks. So this is a webhook that I created for my Jenkins, right? So let me create it again for you. So all you have to do is click on add webhook, right? And enter the URL for your Jenkins over here. So in my case, it is this. I'll just enter it over here, followed by this keyword, which is GitHub-webhook. And that is it. Once you specify that, just go down, click on add webhook. And this should basically send a request to Jenkins, and if everything goes well, it will say last delivery was successful. Okay, so any changes that I make to my GitHub now should trigger a change over here. Now let me delete this job, because I think even this job gets triggered when my GitHub, any changes made to my GitHub, right? So let me delete this project. Okay, great. So I just have this job now. Awesome. Now let us see how it actually works. So what I want to do is I'll come back to my terminal, do an ls, and let me go inside DevOps IQ and let me do some changes in the code. So let's say I go into nanoindex.html. So the first thing that I do is I change the title of the website. So I call it as Jenkins test website. Okay. And I change the image from 2 to 1.jpg, and that is it. Let us see if I just push this website onto my server, what will happen. So I'll do a git push. Sorry, first I'll have to add these changed files into my repository. Git push origin master, git commit, and let me label this commit as test push. Okay, done. Now let's push this to our remote repository. Git push origin master, and let's give the credentials. Awesome. Now if you wait here, it should basically start a job. So as you can see, there is a job queued which is for demo job, and this got automatically triggered by my GitHub. Okay, so let me refresh this. Okay, so the moment it gives you a red, that basically means that your job has been failed. So let's see what had just happened, why our job got failed. So if you go here, you can see the console output just like this. Okay, so basically we forgot to add a sudo here, and that is causing us a problem. Okay, so we can fix this by just going down and adding a sudo here. Save it, and again we'll have to change the code. Let's call it as Jenkins test 2 website. We'll do a control X, Y, and now let's add our files to our local repository. Git add. Now let's commit it. Test push 2, and now let's push this to our master. I'll enter the credentials, and this should be it. Okay, so let's see. So our second job got triggered automatically, and it gives us a blue. Now blue means that your job was executed successfully. So let's check what happened. So we were deploying it on port 85. So let's check if it has been indeed deployed. So it was on port 85, and the folder was DevOps IQ. Okay, so let's check. I'm not sure if it was port 85. Let's check what are the port that we have specified. So the port is 87. Okay, so let's go to port 87. Okay, so it's giving an error saying unsafe port. So for our troubleshooting, let's check if the container is running. So yes, the container is running on port 87, but it says an unsafe port. So what we can do is let us change it to say 82. And now let's just try to build the job from here. We'll just click on build now. Job has been completed, and the port was 82. Yes, so Apache is working. Now let's try going inside DevOps IQ folder. And there you go. You have your website with this title which you pushed on GitHub. Now for one more time, for testing purposes, let us push our code once more and see what happens. So I'll say that this website is test3 website, and say I'll change the image as well to 2.jpeg. Okay, save it, do a git add, do a commit, and say call it test push 3, and now let's git push origin master, enter the credentials, great. Now let's check what will happen. Okay, so our build has been started and it has been completed. Great. So if I refresh this now, it says Jenkins test 3 website, and the background also has been changed. So congratulations guys, we have successfully completed the demo. So basically, if you change anything in your GitHub, the website is automatically getting deployed on your build server, right? And on top of this, just for making it more interesting, what we can do is we can do a git log, and we can revert on this commit that we saw earlier. Okay, so let's do a git revert and then paste it, agree to everything, and then push to master, enter the credentials, everything has been pushed, job is getting triggered, job is completed, and if I go here again, my website got reverted to a particular previous version. Awesome guys, so we have completed the demo, which basically asked us to create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So we have done it successfully. Awesome. Let's move on to our next domain, which talks about configuration management and continuous monitoring. Awesome. So what is configuration management and what is continuous monitoring? Let's understand it. So what is the difference between Ansible, Chef, and Puppet? Now, before understanding the difference between Ansible, Chef, and Puppet, these are basically configuration management tools. What is configuration management? If you have say around 200 servers and you want to install a particular software on each of these servers, what will you do? One way what you can do is you can basically go to each and every of these servers, run a script, and that basically will install software on that on these servers, right? The other way to do it is install a configuration management software using which you can deploy or you can install all these softwares, or you can control the configuration of all these servers from one central place. And that is exactly what configuration management means, right? Now, in configuration management, you have many tools like Ansible, Chef, Puppet, etc. But these are the 3 top tools which are used in the industry. Now, the question is, what is the difference between Ansible, Chef, and Puppet? All right, so let's go ahead and see the differences. All right, so let's first talk about Ansible. So Ansible is very easy to learn because it is based on Python. So you don't have to sweat a lot, or you don't have to sweat much on learning the commands for Ansible because it is based on Python. So if you know Python, Ansible is going to be a cakewalk for you. It is preferred for environments which are designed to scale rapidly. Basically, with Ansible, the thing is that you don't have to install the Ansible client software on the systems on which you want to basically deploy the configuration. Ansible just has to be installed on the master, and that is it. No other configuration required. You can directly control the configuration of the client server given you have the access to it. So it offers simplified orchestration, reason being, like I just told you, that you don't have to worry about installing softwares on the client machines. Ansible can standalone take care of all the complications that come forward when you are dealing with deploying configurations without installing a particular software on the client machines. This is basically a disadvantage of Ansible, that it has a very underdeveloped GUI. That is, you only get the CLI to work with, right? And it has very limited features when we compare it with Puppet and Chef. Now let's talk about Chef. How is Chef different from Ansible? So it is Ruby based and hence it's difficult to learn. Now Ruby is a language that not many people are acquainted with, and hence people might find it difficult to get versed with the commands of Chef. The initial setup is complicated. When I compare it with Ansible, the setup was very easy because I just had to install Ansible on the host machine, and on the client machine I didn't have to install any software. So, but with Chef you have to do that, and hence it becomes a little complicated. But once all the setup and everything is done, Chef is very stable, right? It has been, since it's a community product and it has been well contributed to, it's a very stable product and it offers you resiliency. So of course, when you're working on production servers, probably working on Chef would be a better idea than Ansible, because Ansible does not have that great community when you compare it with Chef. And of course, Chef is the most flexible solutions for OS and middleware management. Now, middleware basically means the software management part. Chef offers to be a great choice for configuration management. Reason being, it is very reliable and is very mature, because it was probably among the first configuration management tools to come out. And because community has contributed a lot to this project, it is very mature in its development stages as well. Now let's talk about Puppet. So Puppet can be tough for people who are beginners in the DevOps world, right? Because it uses its own language called Puppet DSL, right? The setup part is smooth when you compare it with Chef, but it's a little harder than Ansible, because when you're using Puppet, we use a master and an agent as well. So you will have to install Puppet agent on the client machine, and only then Puppet will be able to interact with the client software, right? Now it has a strong support for automation. So if you're planning to do some configuration management that you want to automate, Puppet is very compliant in that part. You can easily do the automation part using Puppet, and it is not suitable for scaling any deployment. So if you have say around 50 or 60 servers and you plan to add more in the future, probably Puppet would not be the right choice for that kind of an architecture. It is good to have when you have a stable infrastructure where you're probably not adding servers now and then. But if you are working on cloud and you do not know the capacity that you would be running, probably Puppet would not be a good idea to manage your configuration on your clients. Okay. Our next question is, what is the difference between asset management and configuration management? So asset management basically deals with resources. It deals with hardware, which we'll have to plan so that our IT workforce can work with maximum efficiency, right? So we'll have to plan the planning of your hardware, of how many resources a particular team might need. Giving the right resources to the right people is what asset management counts in. When we talk about configuration management, it basically employs not the hardware but the software component of what all softwares are required by a particular employee of a team or a particular person in the team. What softwares are required by that person, and for other person what software is required. I mean, rather than taking the radical approach of installing every software in every machine, which should not be done because some softwares are licensed. So configuration management basically means installing the right software on the right system on which a particular person or on which a particular workload is going to run. So our next question is, what are NRPE plugins in Nagios? Okay, so NRPE plugins are basically extensions to Nagios which help you monitor the local resources of the client machines, right? So you don't have to SSH into the client machines to see how much of memory or how much of CPU is being used. Nagios being a monitoring tool, you just have to install the NRPE extension on the client machine, and it will give you a real-time data of the resources that are being consumed on that particular client machine. And obviously, when you're working in production environment, you will be monitoring multiple machines, and with NRPE plugins installed on each of those machines, you can easily monitor the resources of them at one central place. And that is exactly what NRPE plugin is. Our next question is, what is the difference between an active check and a passive check in Nagios? Okay, so in Nagios, if the data, the monitoring log that you're getting from your clients, if it's being delivered by a Nagios agent, in that case, it is called an active check. Reason being, Nagios is actively involved in taking all the data or in collecting all the data from your clients. But in case when you're dealing with systems wherein it does not allow you to install any other software, or probably the software itself can generate monitoring logs, in those cases, what happens is rather than Nagios, the software component pushes the logs to the Nagios master, where it can take the logs and probably create a graph or create the metric for you in the dashboard. So basically, using those logs which are being published by some other software, Nagios will create a report of the health monitoring part of your client systems, right? And that is why it is called a passive check. Reason being, Nagios is not involved on the client side at all. It is basically the software's own services which are basically pushing the log to Nagios master, and hence it's called a passive check. All right, but if you talk about the architecture or the working or the life cycle of how this actually works, on the master itself, the logs which are published are actually published to a queue, right? And whether it's an active check or a passive check, the logs have to be published to that queue so that the Nagios master can pick them up and create the monitoring metric which is required. All right, so in a passive check and in an active check, the queue is going to be there, but it's only difference between the agents. That is, in an active check, the Nagios agents are involved, but in a passive check, third-party software tools are involved which publish the log to the Nagios master. All right, so our next question says, create an Ansible playbook to deploy Apache on a client server. So basically, we have to do configuration management. So as to, without, going inside the client system, we'll have to install a particular piece of software inside it. Okay, so let me quickly do an SSH into my AWS machine. And what I'm gonna do is, I have a slave machine which I have already configured, which can interact with my master. That is, if I do a Ansible ping all, you can see that there is a server 1 that I have configured, which has successfully responded to my master's request. Okay, now let me show you the server, which is basically working. So this is the server which is configured with my master, right? This is my client machine, and on this machine I'll have to install Apache. So if I right now go to the IP address of this machine, it says connection refused. Reason being that there is nothing installed on this server, or there is no Apache software installed on this particular server right now. All right, so let's install Apache. Now to do that, you will have to write a playbook. Now, what is a playbook? A playbook looks something like this. So it's basically a YAML file that you'll have to create. So I have created one for me. So where do you want to install the Apache software is the part where you'll have to specify in hosts. So basically my client machine is a part of a group called servers that I've created, right? So the hosts are servers, and where can you actually specify what part is your machine, or which group is your machine a part of? So that you can specify over here. So it's in /etc/Ansible and /hosts. Okay, so as you can see over here, this is the group name, that is servers, and inside servers I've specified a server 1 client machine which has the IP address this. So this is the IP address of my slave. So if you can compare, it's 18.223.101.172, and if I compare it with my slave, this is the IP address of my slave, right? And this has been configured over here. So I can refer to my server 1 as servers, or I can refer it to as server 1, right? So if I do, let me do a clear over here, I can say Ansible -m ping, and I can say server 1 as well. It will reach out to my server 1, or I can say servers as well, because it's part of the group servers. Okay, so this is how it works. Now I want to install Apache. So for installing Apache, I'll have to write a playbook which looks like this. Basically it's a YAML file. So you start with the 3 dashed lines, and then you specify hosts. So hosts, I've specified every server, every machine which is inside the servers group should install Apache on it, right? And what is the task? I want to install Apache 2. This is basically a name. You can specify anything over here. Then I've specified apt. Basically I want to use the apt package to install Apache 2, the latest software. Okay, now what I will do, I will type in Ansible -playbook, and I'll type in apache.yaml. I'll hit enter, and now it has started to install everything. So it is installing on the servers group. It is gathering the facts, and it saw that it is able to communicate with server 1, and now it is accomplishing the task of installing Apache. All right, so it has been done successfully. So if I go to my Chrome browser now, and if I refresh the address, you can see that Apache is installed on this server automatically. So I didn't have to basically SSH into the server. It all happened automatically. And if I had like 5-6 computers which were running on AWS, and if I wanted to install the software on it using Apache, using Ansible, this would have been the same way. It's only that in the server group, I would have specified more IP addresses which my Ansible could talk to. Okay, so this was our task of basically deploying an Ansible playbook on a client server without SSH, doing an SSH into that client server and doing it from a central location. All right, so this is done. Now let's move on to our next domain, which is continuous testing. Now what is continuous testing? So we talked about continuous development, which is done using GitHub. We talked about continuous integration, which is possible using Jenkins. We talked about continuous configuration management, which can be done using Ansible. And next online is we have continuous testing. So once the code has been deployed, it has been integrated with Jenkins, it has been deployed on a server. The next thing is automated testing that we discussed in the best practices before, right? And it can be done using a tool called Selenium, a software called Selenium WebDriver, right? So the first question is, list out the technical challenges with Selenium. So the Selenium tool is used widely for automatic testing or automated testing, but what are the problems that you get with Selenium? So if you're using Selenium, mobile testing cannot be done. So if you have developed an application for your mobile, you cannot test it using Selenium. The reporting capabilities of Selenium are very limited. If your application or your web application deals with pop-up windows, or it gives pop-up windows, Selenium would not be able to recognize those pop-up windows and work on them. And again, Selenium is only limited to web applications. So if you have an application that probably runs on desktop, probably it's a software that you have designed, you cannot test that software using Selenium. Selenium is only for those applications which can run inside a browser. And if you want to check whether there is some image in your web page and that image should have some particular content, it is a little difficult to implement it in Selenium. Although it is not impossible, it is possible. You'll have to import some libraries and other things like that. But natively, Selenium does not support image testing. You'll have to work around. You'll have to work around with Selenium to import some libraries which could do it for you. But like I said, natively Selenium does not support image testing. So our next question is, what is the difference between verify and assert commands? So let us see the differences. So if you're using assert in Selenium, if the command fails, the whole execution comes to a halt. Whereas in verify, it does not come to a halt. It keeps on continuing the rest of the lines which are written in the code. Now, how can it be helpful? How is it helpful to basically put execution at halt whenever there is an error which occurs for a particular line? It is helpful when you're dealing with critical cases. Like for example, if there are 5 cases and say if case 3 fails, case 4 and 5 cannot execute because they have a dependency on case 3. In those cases, I would say that you would have to use assert with the case 3. But in the same example, if you talk about case 1 and case 2, they do not have a dependency or they do not create a dependency for any other test cases that have to run, right? For example, case 3, case 4, case 5 are not dependent on case 1 and case 2. In those cases, we can run the verify command, which will not stop even if the test case fails, right? And this basically is done to basically see what all is working and what all is not in one shot in a testing program. And for those cases, you would use verify. But in the cases where you are testing critical cases and you do not want to waste your time testing other things, if one of your case fails, in those cases, you will use the assert test. So like I said, it is used to validate critical functionality, assert command, and verify is used to validate functionality which is of the normal behavior kind of scenario, which comes into the normal behavior. That is, it does not create a dependency for other things to not work because it stopped working. All right. So our next question is, what is the difference between set speed and sleep methods? So set speed is basically used for executing tasks at a particular interval that we specify. For example, say I want to echo hello world at intervals of 5 seconds. In that case, I can specify it using set speed. But sleep method basically suspends the execution of the whole program for a particular interval. For example, if you're doing a Selenium web test and the web page takes around 3 seconds to load, and you don't want testing to happen just after each line, you can specify a sleep method of say around 3 seconds, where it waits for 3 seconds for the website to load, and only then it will start executing the tests which follow that particular line. All right. So this is the difference between set speed and sleep.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job.
Thank you for watching the video. If you have any doubts, put down in the comment section. Thank you.
Thank you.